Hey everyone, welcome to this Data Analyst Full Course video by Simplilearn. In this full course, you will learn all about how to become a data analyst. This video will help you get acquainted with the duties and career prospects of a data analyst along with various data analytics concepts. Here, we will start by understanding the career of a data analyst and what a data analyst's duties are. Then we will list the top 10 data analyst skills and the top 10 data analysis tools. Moving on, we will distinguish a data analyst from a data scientist, and we will also pit the role of a data analyst against a few other roles like business analyst and data engineer. We will then move on to learning data analytics with Python. Following which, we will learn a few Excel concepts that can help you in your role as a data analyst. We will also look into pandas and matplotlib. Next, we will understand data analytics using R. Not to forget, we are also going to learn about SQL. Finally, we will conclude this full course by understanding the top data analyst interview questions that you could be asked in your next interview. Our team of experts will take you through the various topics in this full course. You can learn all of these topics in under 12 hours. But before we begin, make sure to subscribe to our YouTube channel and hit the bell icon to never miss an update from Simplilearn. In a world where there is data generation every millisecond, the role of a data analyst holds paramount importance. This video will help you understand what a data analyst does and the various skills required to bag this position. Before understanding the job role of a data analyst, let's understand the meaning of the term data analytics. So what does the term analyze mean? It merely means to scrutinize something to derive meaningful conclusions from it. Well, data analytics also works similarly. It is the process by which useful insights are extracted from raw data by studying and examining it carefully. These insights can be related to business information, market trends, product innovations, and profit loss report, to name a few. Here's an interesting comparison. I'm sure all of you have played with jigsaw puzzles at some point in time. For that, first you would have to gather all the pieces together and then fit them accordingly to bring out a beautiful picture, isn't it? We can simply relate the process of data analytics to how you make a jigsaw puzzle. As you can see here, data refers to the raw data which can be structured, semi-structured, or unstructured in nature. The process of data analytics incorporates collecting data from various sources, cleaning it, and then finally transforming it into something meaningful, which can be interpreted by humans. This information can be visually presented in the form of graphs and charts which provide precise results of the analysis. Various technologies, tools, and frameworks are used in the analysis process. Organizations take the help of data analytics to convert the available raw data into meaningful insights. Hence, there is a high requirement for professionals who can play with data and help organizations with crucial decision making. There are many job roles in the field of data analytics. If you have watched our previous video on data analytics career, you would have seen a few of these roles. Out of all the job roles, an important role is that of a data analyst. An interesting thing about this job role is that it can be taken up by freshers as well. It can embark on your career in the field of data analytics. It is a lucrative career as the field of data analytics is only going to continue to blossom in the years to come. So let's see who exactly a data analyst is. A data analyst is a person who collects, processes, and performs analysis on large data sets. Here, the statistical analysis is done on various data sets. Every business generates and collects data, be it marketing research, sales figures, customer feedback, logistics, or transportation costs. A data analyst will take all of this data and figure out various measures, such as how to price new materials, how to reduce transportation costs, how to provide better customer experience, or how to deal with issues that cost the company money. Data analysts also deal with data handling, data modeling, and data reporting. A data analyst has a number of duties to perform. Let's have a look at their responsibilities now. First and foremost, a data analyst is required to recognize and understand the organization's goal. This helps in streamlining and planning the analysis process accordingly. Data analysts assess the available resources, understand the business problem, and gather the right data. This step is done by collaborating with different team members such as programmers, business analysts, and data scientists. Data analysts need to use queries to gather information from a database. They write complex SQL queries and scripts to gather and extract information from several databases and data warehouses. They are responsible for data mining as well. Here, data is mined from various sources and then organized in order to obtain a new information from it. This is a vital role of a data analyst, as they have to extract data from various sources in order to work on it. With this data, they can build models that can reduce the complexity and increase the efficiency of the whole system. Another crucial step in data analysis is data cleaning and data wrangling. Usually, the data you can collect is often messy and has a lot of missing values, so it's important to clean this data to make it ready for analysis. Data analysts use a number of statistical and analytical tools, including programming languages, for performing analysis and logical examination of data. Using different libraries and packages, data analysts discover trends and patterns from complex data sets. This will help them find more unseen insights from the data to make business predictions. Another important role of a data analyst is to prepare summary reports for the leadership team so that they can make timely decisions. For this, data analysts use multiple data visualization tools. Some of these tools are discussed as part of skills required, which we will see later. Finally, data analysts interact with the development team, business and management team, as well as with data scientists to ensure proper implementation of business requirements and to figure out opportunities for better process improvement. Now let us look at the various skills required to become a data analyst. So the first skill is more of a prerequisite. You should hold a degree in any relevant field, be it engineering, computer science, information technology, electrical or mechanical engineering. You can also be a graduate in statistics or economics. Also, you should have domain knowledge in the field you are currently working in or the role you're applying for. The next important skill is that you should have good hands-on experience with programming languages such as R, Python, and JavaScript. This would help you write programs to solve complex problems. Then, you should have a good experience working with databases and data analysis tools such as writing SQL queries and procedures, knowledge of Microsoft Excel, IBM SPSS, and MATLAB to analyze trends, forecast data, and plan to drive accurate insights. You must have a strong understanding of statistics and machine learning algorithms. These include concepts such as hypothesis testing, probability distributions, regression analysis, and various classification and clustering techniques. And finally, a data analyst should be able to create different reports with the help of charts and graphs using several data visualization tools such as Tableau and Power BI. They must have good presentation skills as well. This will help them convey their ideas to clients and stakeholders better. Now that we have looked at the various skills required to become a data analyst, let's now see the average annual salary that a data analyst earns. Here we can have a look at the salary ranges of both in US and in India. So a data analyst in the United States can earn a minimum salary of $43,000 to a maximum of $85,000 per year. In India, you can earn anywhere between 1,98,000 rupees to 9,24,000 rupees per annum. The data analyst role is in very high demand, with companies looking for professionals who can handle their data effectively and efficiently. So let's look at the different companies hiring for the data analyst role. As you see, here we have the American e-commerce giant Amazon, the American multinational technology company Microsoft, Capital One, which is one of the largest banking companies in the US, Then we have the popular retail company Walmart. Then we have PayPal. Next, we have the internet and search engine giant Google, social media firms Facebook and Twitter, as well as Apple and Bloomberg. With that, let me now tell you how Simplilearn can help you learn data analytics and guide you to become a data analyst. So in a new tab, I'll search for simplilearn.com. Then here on the search bar, I'll look for data analyst. Let me now click on the first link, which is Data Analyst. I'll open this in another tab. As you can see on your screens, this is the Data Analyst Master's Program and it is in collaboration with IBM. On the right-hand side, you can see the different courses that will be covered as a part of the program. You will learn Introduction to Data Analytics, Business Analytics with Excel, then you have Tableau followed by Power BI. Later on in the course, you will learn Programming Basics and Data Analytics with Python, then R Programming. And finally, you will get to work on a capstone project. This is a kind of certificate you would receive after completing the course. It will have your name along with IBM and Simplilearn logo. These are some of the tools that will be covered in this program. You will learn Excel, then NumPy, Pandas, SciPy, IBM Watson, Power BI, Tableau, Python, and R. The course advisor for this program is Ronald Van Loon. Below, you can see the entire course curriculum and the different courses that you will learn in this program. Also, there are a few electives that you can choose in this course. There's Data Science in Real Life, Programming Refresher, Industry Master Class, Data Analytics, and there is SQL training as well. Let's quickly understand how important a career in data analytics is and what the future holds for professionals in this domain. Let's take a look at the growth of data. So back in the early 2000s, there was relatively less data generated. But with the rapid rise in technologies and with the increase in the number of various social media platforms and multinational companies across the globe, the generation of data has increased by leaps and bounds. Did you know that according to the IDC, the total volume of data is expected to reach 175 zettabytes in 2025? Now that's a lot of data. Let's take a look at how organizations leverage all of this data. As you know, there are zillions of companies across the world. These companies generate loads of data on a daily basis. When I say data here, it simply refers to business information, customer data, customer feedback, product innovations, sales reports, and profit loss reports, to name a few. Companies utilize all of this data in a wise way. They use all of this information to make crucial decisions that can either hamper or boost their businesses. You might have heard of the term data is the new oil. Well, it definitely is, but only if organizations analyze all the available data very well, then this oil is definitely valuable. And for that, we have data analytics. Organizations take the help of data analytics to convert the available raw data into meaningful insights. So what is data analytics? Technically, you can say it is a process wherein data is collected from various sources, then cleaned, which involves removing irrelevant information, and then finally transformed into some meaningful information that can be interpreted by humans. Various technologies, tools, and frameworks are used in the analysis process. As you might have heard of the term data never sleeps. Well, it surely doesn't. Every millisecond, some or the other data is generated, and this is a constant process. This process is only going to increase in the near future with the advent of newer technologies. The data analytics domain holds paramount importance in every sector. Companies want to leverage on all the generated big data and boost their businesses. They need professionals who can play with data and convert them into crucial insights. Organizations are constantly on the lookout for such candidates, and this opportunity will only increase as data is only going to grow every second. So if you want to start your career in this field, or if you want to switch your job role into a role in the data analytics domain, then we have a set of job profiles that you can look at. We will look into 6 job roles in the data analytics field and learn what each job role is all about, the responsibilities of a professional working in that particular role, the skills required to get that particular job, the average annual salary of a professional working in that role, and finally, the companies hiring for that role. So let's start off. First, we have the job role of a data analyst. A data analyst is a person who collects, processes, and performs statistical analysis of large data sets. Every business generates and collects data, be it marketing research, sales figures, logistics, or transportation costs. A data analyst will take this data and figure out a variety of measures, such as how to price new materials, how to reduce transportation costs, or how to deal with issues that cost the company money. They deal with data handling, data modeling, and reporting. Now, talking about their responsibilities, data analysts recognize and understand the organization's goal. They collaborate with different team members such as programmers, business analysts, engineers, and data scientists to identify opportunities for solving business problems. Data analysts write complex SQL queries, scripts, and store procedures to gather and extract information from multiple databases. They filter and clean data using different modern tools and techniques and make it ready for analysis. They also perform data mining from primary and secondary data sources. Data analysts identify, analyze, and interpret trends in complex data sets. This is done using statistical tools such as R and SAS. Another key responsibility of a data analyst is to create summary reports and build various data visualizations for decision making and presenting it to the stakeholders. Next, let us discuss the important skills that you need to know to become a data analyst. Firstly, you should have a bachelor's degree in computer science or information technology. A master's degree in computer applications or statistics is also preferable. You must have a good understanding of programming languages like R, Python, JavaScript, and also understand SQL. In addition to that, it is beneficial if you have hands-on experience with statistical and data analytics tools such as SAS Miner, Microsoft Excel, and SSAS. Basic understanding of machine learning and its algorithms would be an advantage. Acquaint yourself with descriptive, predictive, prescriptive, and inferential statistics. Most importantly, you need to have a good working knowledge of various data visualization software along with presentation skills. This will help you pitch in your ideas and viewpoints to the clients and stakeholders better. Now, talking about their salaries, a data analyst earns nearly 5,23,000 rupees per annum in India, while in the United States they earn around $62,453 per annum. Let's now look at a few of the companies hiring data analysts. So as you can see, we have the American e-commerce giant Amazon, then we have Microsoft, the American online payment company PayPal, then we have Walmart, Bloomberg, and Capital One. So that was all about data analyst. The next job role is of a business analyst. Business analysts help guide businesses in improving products, services, and software through data-driven solutions. They are responsible for bridging the gap between IT and business using data analytics to evaluate processes, determine requirements, and deliver data-driven recommendations and reports to executives and stakeholders. Business analysts are responsible for creating new models that support business decisions and come up with initiatives and strategies to optimize costs. Now let us look at the various responsibilities of a business analyst. Business analysts have a good understanding of the requirements for business. Their vital role is to work in accordance with relevant project stakeholders to understand their requirements and translate them into details which the developers can understand. They frequently interact with developers and come up with a plan to design the layout of a software application. They also run meetings with stakeholders and other authorities. They engage with business leaders and users to understand how data-driven changes to products, services, software, and hardware can improve efficiencies and add value. They ensure that the project is running smoothly as per the requirements and the design planned through user acceptance and validation testing. They make sure all the features are being incorporated into the application. BAs rely on different software to write documentation and design visualization to explain all the findings. It is extremely critical for any BA to effectively document the findings where each requirement of the client is mentioned in detail. Now let us look at the skills required for a BA. A bachelor's degree in the field of science, engineering, or statistics or any related domain will suffice. Knowledge of programming languages such as Python and Java is beneficial. You should be really good at writing complex SQL queries, and you should also have knowledge of various business process models. Along with knowledge of programming languages, ideas about statistical analysis and predictive modeling is necessary. Decision-making, strong analytical and problem-solving skills are necessary to solve software and business issues. You also need to have excellent presentation and communication skills, both oral and written. Moving on to their salary, a business analyst is expected to earn around 7 lakh rupees per annum in India. In the US, they earn nearly $68,346 per annum. IQVIA, Dell, Philips, Honeywell, the famous American messaging platform WhatsApp, the UK-based company Ernst & Young are few of the companies hiring for business analysts. Up next, we have the job role of a database administrator. A database administrator is a specialized computer systems administrator who maintains a successful database environment by directing or performing all related activities to keep the organization's data secure. They are responsible for storing, organizing, and retrieving data from several databases and data warehouses. Their top responsibility is to maintain data integrity. This means that database administrator will ensure that the data is secure from unauthorized access. Moving on to their responsibilities. A database administrator develops, designs, and maintains a database to ensure that the data in it is properly stored, organized, and managed well. They maintain data integrity by avoiding unauthorized access, and they keep databases up to date. They run tests and modify the existing databases to ensure that they operate reliably. They also inform end users of changes in databases and train them to utilize systems. They need to cooperate with programmers, data analysts, and the IT staffs to ensure smooth running and maintenance of databases. Database administrators are responsible for taking system backups in case of power outages and other disasters. So they should have an efficient disaster recovery plan. Now let's have a look at their skills. To become a database administrator, you should have a bachelor's degree in computer science or information technology. Knowledge of programming languages such as Python, Java, and Scala is important. You need to carry at least 3 to 5 years of experience in data management. You need to have an understanding of different databases such as Oracle DB, MongoDB, MySQL Server, and PostgreSQL. Also, they should have an idea about database design and writing SQL queries. Finally, you need to have a good understanding of operating systems such as Windows, Mac OS, and Linux, along with storage technologies. Talking about their salary, a database administrator in India can earn up to 4,97,000 rupees per annum. In the US, they earn around $78,000 per annum. Let's have a look at the companies hiring for database administrators. So as you see, here we have BookMyShow, Oracle, the American MNC Intel, Amazon, Robert Half, and the New York Times, to name a few. Fourth in the list of job roles, we have data engineer. A data engineer is someone who's involved in preparing data for analytical and operational uses. A data engineer transforms data into useful format for analysis. They build and test scalable big data ecosystems for businesses. A data engineer is an intermediary between a data analyst and a data scientist. Now let's jump into their responsibilities. Data engineers develop, test, and maintain architectures. They are responsible for managing, optimizing, and monitoring data retrieval, storage, and distribution throughout the organization. They discover opportunities for data acquisition, find trends in datasets, and develop algorithms to help make raw data more useful to the enterprise. Data engineers build large data warehouses using ETL for storing and retrieving data. They also recommend ways to improve data quality and efficiency along with building algorithms to help give easier access to raw data. Data engineers often work with big data and submit their reports to data scientists for analysis purpose. They need to recommend and sometimes implement ways to improve data reliability, efficiency, and quality. Moving on to the skills of a data engineer. A data engineer should hold a bachelor's degree in computer science or information technology. They should have good hands-on experience with Python, R, and Java. Also, data engineers should be well-versed with big data technologies such as Hadoop, Apache Spark, Scala, Cassandra, and MongoDB. Data warehousing and ETL experience are essential to this position along with in-depth knowledge of SQL and other database solutions. Basic knowledge of statistical analysis will be an advantage along with idea about operating systems. Here is what a data engineer can earn. So in India, a data engineer can earn up to 8,85,000 rupees per annum, while they can earn around $103,000 a year in the USA. We have Capgemini, Shutterstock, the American provider of stock photography, Spotify, Accenture, Genpact, and Facebook hiring data engineers. The next exciting job role is of a data scientist. A data scientist is a professional who uses statistical methods, data analysis techniques, machine learning, and related concepts in order to understand and analyze data to draw business conclusions. They make sense to messy and unstructured data and bring value out of it. They employ techniques and theories drawn from many fields within the context of mathematics, statistics, computer science, and information science. A data scientist understands the challenges in business and comes up with the best solutions using modern tools and techniques to analyze, visualize, and build prediction models to make business decisions. Let us now look at their responsibilities in the industries. Data scientists clean, process, and manipulate data using several data analytics tools. They perform ad hoc data mining, collect large sets of structured and unstructured data from disparate sources. They design and evaluate advanced statistical models to work on big data. They also create automated anomaly detection systems and keep constant track of their performance. Data scientists interpret the analysis of big data to discover solutions and opportunities. A data scientist takes input from data analysts and engineers to formulate the results. They use visualization packages and tools to create reports and dashboards for relevant stakeholders. They also adopt new business models and approaches. Apart from this, they regularly build predictive models and machine learning algorithms. Now moving on to the skills of a data scientist. A bachelor's degree in computer science or information technology will be fine, but a master's degree in the field of data science will hold a major advantage. You also need to have a good experience in the analytics domain. You should be proficient in programming languages such as Python, Java, and C++. Knowledge of Perl will also be an advantage. Familiarity with Apache Hive, Pig, and Apache Spark is necessary along with the knowledge of Hadoop. In addition to knowing programming languages, you also need to know SQL, machine learning, and deep learning. Data visualization and BI skills are necessary for creating reports and dashboards. You should also be able to communicate and present information and ideas properly. Now talking about their salary, a data scientist in India can expect an annual salary of 10,47,000 rupees per year. Meanwhile, in the US, they can earn up to $113,000 per annum. That's a lot of money. From the many companies hiring for data scientists, here we have a few companies named. They are yet again Amazon, Citibank, Apple, Google, the Japanese electronic commerce and online retailing company Rakuten, and Facebook. And finally, we have machine learning engineer. Machine learning engineers are professionals who develop intelligent machines that can learn from vast amounts of data and apply knowledge without human intervention. They use different algorithms and statistical modeling to make sense of data. They design and develop machine learning and deep learning algorithms. Their main goal is to create self-running software. Let's have a look at the responsibilities of a machine learning engineer. Machine learning engineers research, design, and develop machine learning systems. They use exceptional mathematical skills in order to perform faster computations and work with algorithms to create sophisticated models. They perform A/B testing and use data modeling to fine-tune the results. They use data modeling and evaluation strategy to find hidden patterns and predict unseen instances. Machine learning engineers work closely with data engineers to build data pipelines and interact with stakeholders to get a clarity on the requirements. Most importantly, they analyze complex data sets to verify data quality, perform model tests and experiments, choose to implement the right machine learning algorithm, and select the right training data sets. Moving on to their skills. A machine learning engineer should have a degree in computer science and information technology. They should have an advanced degree in computer science or maths. In addition to this, they should also have experience in the same domain. They should be proficient in programming languages such as Python, R, C++, and Java. Knowledge of statistics, probability, and linear algebra is necessary as all the machine learning algorithms have been derived from mathematics. Also, having an idea of signal processing would be beneficial. Machine learning engineers need to have a good understanding of data manipulation and machine learning libraries such as NumPy, Pandas, scikit-learn, etc. They should have good oral and written communication skills. Let us now have a look at their salary structure. A machine learning engineer earns 8 lakh rupees per annum in India. While in the US, they can earn around $114,000 a year. Now that's a whopping amount, isn't it? Let's have a look at the companies hiring machine learning engineers. So as you see, we have Amazon, Microsoft, Oracle, Salesforce, Rapido, and Accenture to name a few. That was all about the job role of a machine learning engineer. Now that we have seen the different job roles in the field of data analytics, let's also go ahead and see how an ideal resume of a data analyst should look like. Seen on your screens is a sample resume of a data analyst. You can grab some ideas from this and incorporate them in your resume. Nowadays, it's quite common to have a professional photograph of yours on the resume. You can go ahead and have that. Then your name in bold, followed by your contact details like email ID and phone number. Then moving on, you would have to write a summary. Briefly explain your current job role and what you're looking for in the future. Having a LinkedIn profile link works well these days. Employers can just go ahead and look at your profile and gauge you well. Make sure to have an active LinkedIn profile. In addition to LinkedIn profile, it's also good to have a GitHub profile link which can show your coding or other technical skills. If it's impressive enough, then a lot of times the rest of your resume is just secondary. As I mentioned, this is a resume of a data analyst. So as you can see in the summary here, we have just spoken about the basic responsibilities of a data analyst. Moving on to the experience part. You have to write the job title and below that you can mention the company and the tenure accordingly. Here you would have to give a brief description of achievements in the organization, any relevant accomplishments related to the job you're applying for, the tools and the various technologies you have worked with. So in the sample, you can see we have spoken about data visualization using R and Tableau. Next, we have spoken about how the candidate has worked with other teams for a better business outcome. Most of the data analysts use SQL and Excel to handle data for reporting and database maintenance, and we have mentioned that here as well. Do make sure that you always specify the tools you use. Then you can also mention if you have worked on improving data delivery. For example, here we have spoken about developing and optimizing SQL queries, data aggregations, and ETL to improve data delivery. Finally, you can speak a bit about your reporting skills and if needed, elaborate on it. Usually, professionals would have worked in a similar domain before becoming a data analyst. Here, we have taken the role of a statistical assistant as the first job, since it's easier for a candidate with this job role to shift into the data analytics field. Nevertheless, y'all can still mention your prior experience here, be it in any domain. Under the responsibilities for this job role, we have given basics such as coding data prior to computer entry, compiling statistics from various reports, computing and analyzing data, and finally some visualization and reporting. Moving to the education, here you can mention the name of your degree and the university name. If you have a post-graduation, well and good, you can list both the degrees here. Also, if you have any certifications, you can mention them here under the education category. Now moving to the skills, depending on your skills and your choice, you can either shift this part to the beginning of the resume or have it here. As you see on your screens, this is just a different way of displaying your skill sets. You can have all the 5 stars colored if you are excellent in that particular tool or language. As you see, it's crystal clear as to what the candidate's strong areas are. You can have various categories like shown. For example, under software development, you can list the languages that you know and how proficient you are in those particular languages. It's clear that the candidate knows Python better than JavaScript here. So the employer gets a clear idea about the skills you possess and the depth of it. Similarly, you can mention the databases as well. The few mentioned here are more or less a requirement to become a data analyst. At least, SQL is a must. Not to forget, data visualization is also very important when it comes to the job role of a data analyst. Mention the tools you know here and similarly give yourself a rating out of 5. 5 stars shaded being the highest. Here we have mentioned Tableau and Excel, which are more than sufficient to become a data analyst. Moving to the non-technical skills, you can mention the languages you know here. Here we have taken English and German. In addition to the languages, you can also feel free to mention the extracurricular activities that you are good at. So this is how an ideal resume of a data analyst should look like. You can alter it according to your achievements, skills, and experience. Welcome to this session on top 10 skills to become a data analyst. Before diving into our topic, let's quickly speak about the job role of a data analyst. In this 21st century, data analytics is used in every sector, be it in organizations where meaningful insights are drawn pertaining to the growth of the company, or be it in fighting the ongoing pandemic COVID-19. Data finds its importance everywhere. Speaking of the role of a data analyst, he or she is a skilled professional who is responsible for collecting and processing data. They perform analysis on large data sets. They also deal with data handling, data modeling, and reporting. A data analyst understands the trends and insights that are revealed in massive data sets. So if you want to become a data analyst, then there are a few skills that you need to possess. Let's have a look at the top 10 skills that can help you bag the position of a data analyst. Here, we will look into both technical and non-technical skills. At number 10, we have mathematics. Data analysts work with a lot of structured and unstructured data. In order to analyze and understand all the acquired data, a strong foundation in mathematics is essential. Most of the data analysis will use linear algebra, statistics, probability, and calculus for performing analysis and for the logical examination of data. Hypothesis testing, such as the null hypothesis and alternate hypothesis analysis, is another crucial task that data analysts perform to ensure that the data they have collected is relevant for analysis. They need to perform z-test, t-test, and chi-square test to make sure the sample data is good for analysis. Also, data analysts build machine learning models for solving business problems using classification, regression, and clustering algorithms. So to understand the working of these algorithms, knowledge of mathematics is compulsory. Moving to number 9, we have the big data tools and frameworks. Data analysts deal with complex and inaccurate data that is really huge in volume. Now, to handle this data, they need to possess big data technology skills such as Hadoop and the tools that are part of its ecosystem. Hadoop provides the Hadoop distribution file system to store data in several chunks. Scoop is popularly used as a data ingestion tool for extracting data from HDFS onto relational databases. Data analysts use HBase, which is a column-oriented database for processing semi-structured data. There are other frameworks such as Apache Pig and Hive for processing and analyzing data using Pig Latin scripts and Hive query language. It would be an advantage for a data analyst to have an idea about these tools and frameworks. At number 8, we have data cleaning and data wrangling. In this modern era of internet and social media, data is being generated every second, and often this data is noisy and messy, containing missing values. Data is also often unstructured, and this could be a problem for data analysts to perform analysis on such data. So they need to pre-process the data and clean it using various tools and techniques to make it fit for analysis. Data analysts must transform the data into the right format for carrying out analytics. They should also have data manipulation and data mining skills to find out unseen trends and patterns from the data. Some of the tools they should have knowledge of are OpenRefine and Trifactor Wrangler. They need to have hands-on experience in certain numerical computation and data manipulation libraries such as NumPy, Pandas, dplyr, SciPy, and TidyR. At number 7, we have BI tools for data visualization. In order to understand the complexities of business and derive the desired solution, data analysts should have an idea about business intelligence tools. Business intelligence is a process to analyze and visualize vast volumes of data. It helps in creating reports and dashboards to better understand the trends in data. BI tools help data analysts to sort and filter the data, perform data manipulation by joining multiple data sets, and build different charts and graphs to present the data in a pictorial format. It also helps them to forecast the data to make future predictions. The reports and dashboards created using BI tools can help data analysts convey their ideas to clients and stakeholders. Some of the popular BI tools used in analytics are Power BI, Tableau, ClickView, and SAS BI. All these tools feature in the Gartner Magic Quadrant for 2020 for business intelligence and analytics. At number 6, we have Microsoft Excel and ETL tools. Every data analyst should possess a good working knowledge of Microsoft Excel. Excel is the most preferred tool for analytics that is commonly used by managers across the globe. Microsoft Excel has really good features to manipulate and analyze structured data that is in the form of rows and columns. It provides a lot of inbuilt numerical and text functions. You also have the advantage of creating pivot tables and pivot charts. Along with creating different charts and graphs for building a report, you can explore advanced features such as Excel macros. Good knowledge of data warehousing and ETL tools is important. Data analysts often gather data from several data sources. Then they manipulate and transform data using different techniques. And finally, they load the data to a data warehouse for easy access. Some of the popular ETL and data warehousing tools are Informatica and Talent. At number 5, we have programming languages. Data analysts should have excellent hands-on programming knowledge for solving complex business problems. They need to know programming languages such as Python, R, SAS, and Java. Python and R are the most widely used languages in the field of data analytics and machine learning. Both Python and R are open-source programming languages. They are easy to learn and implement. Python has built-in mathematical functions, regular expressions, and libraries like Pandas, NumPy, Matplotlib, and Seaborn for data analysis. R supports packages such as plyr, dplyr, TidyR, tidyverse, ggplot, and lattice for manipulating and visualizing the data. SAS is another preferred programming software for statistical analysis and model building, while Java is mainly suitable for writing user-defined methods and object-oriented programming. At number 4, we have the most important skill for any data analyst, which is database and SQL. The database is a storage container where companies store huge volumes of data. Organizations deal with vast volumes of structured and semi-structured data on a daily basis. This data is stored in relational and non-relational databases. In order to retrieve, process, and manipulate the data from such databases, data analysts should use RDBMS and NoSQL databases such as Microsoft SQL Server, MySQL, IBM DB2, MongoDB, and PostgreSQL. They should know how to write SQL queries using commands such as select, insert, update, delete, drop, and truncate. Data analysts must have advanced querying skills like implementing where and having clauses to filter the data, using built-in SQL functions, joining tables, and writing stored procedures to automate complex tasks. Those were all the technical skills that are required to be possessed by a data analyst. Now that you had a look at all the technical skills, you must note that the role of a data analyst is a blend of both technical and non-technical. You need to focus on certain non-technical skills as well to become a full-fledged data analyst. So let's now move on and look at what non-technical skills are required to become a data analyst. If you enjoy watching informative tech videos like this one, consider subscribing to Simplilearn's channel to stay up to date on the trending technologies and hit the bell icon to never miss an update in the future. At number 3, we have problem solving. Data analysts should be prepared to face several barriers on a daily basis. Being able to problem solve a way out of obstructions is an essential skill. There can be multiple issues like budget constraints, short deadlines, and so on. These problems would require you to come up with innovative solutions. Hence, no matter what the circumstances, having strong problem-solving skills will always be a virtue. Being a data analyst also requires you to think like an analyst. Analytical skills, also known as logical thinking, refers to breaking down problems logically. Having strong analytical skills will help you arrive at a wise solution in any situation based on information and facts. Complex problems can be solved this way. Critical thinking also goes hand in hand with analytical skills. Critical thinking is a self-guided and self-disciplined way of thinking which attempts to reason in a fair-minded way. As a data analyst, critical thinking will help you stay grounded when you are searching for a solution to a tricky problem. You should also be capable of making well-thought, independent decisions. There are a number of tips that can help you improve your critical thinking skills. Moving on to number 2, we have business knowledge. Business knowledge or domain knowledge refers to holding a sound understanding of the domain you are working in. This knowledge is different for different organizations. For example, if you're working in the automobile industry, you might need to understand how systems work and how its output can be potentially influenced. Irrespective of where you work, you need to have good business knowledge and understand what you're analyzing. You should be in a position to understand the various business problems and how to solve them. Only if you have a strong industry knowledge can you try to improve the business. If you keep yourself updated with market trends, you can understand where your company stands and accordingly build a business model. This will also help you assist your business in exploring greener pastures. So now let's have a look at what's at number 1. Here we have communication and presentation. This might seem like a very common skill, but it's not as easy as it sounds. Data analysts interact with various teams to ensure proper implementation of business requirements, and for this collaboration to run smoothly, communication is very important. The ability to communicate in numerous ways is a key data analyst skill. This includes writing, speaking, presenting, and listening. Written communication is crucial. You will be required to write up your analysis and provide regular documentations of it. Data visualization and presentation skills go hand in hand. Presenting your analysis results to various team members and stakeholders holds paramount importance. You might also need to be in a state to explain a complex topic to non-technical teammates. There is no point of a great analysis if you are unable to explain it through your presentation. You can master the presentation skill with regular practice until you are comfortable to explain in front of a bunch of people. Having said that, you should also be very crisp with your presentations. You need to be clear, direct, and focus on the result rather than deviating from your topic. Like they say, you need to hit the bullseye. Before I start off with the top 10 data analysis tools, I'd like to talk a bit about data analysis. So have you ever wondered why data analysis is important? There are zillions of companies across the world. All these companies generate a lot of data. They literally work with this generated data. These companies depend on data to make crucial decisions which can impact their businesses. Data in its raw format has to be converted into meaningful information which can then be used by organizations. This is done by analyzing the generated data, and for this we have data analysis. So what is data analysis? Data analysis is not just a single step but a set of processes. It is the process of collecting data, then cleaning it. When I say cleaning, it simply means removing the irrelevant data, and then this data is transformed into meaningful information. We can simply relate this process to how you make a jigsaw puzzle. Just like how you gather all the pieces together and fit them accordingly to bring out a beautiful picture. Data analysis also works on almost the same grounds. To achieve the goals of data analysis, we use a number of data analysis tools. Companies rely on these tools to gather and transform their data into meaningful insights. So which tool should you choose to analyze your data? Which tool should you learn if you want to make a career in this field? We will answer that in this session. After extensive research, we have come up with these top 10 data analysis tools. Here, we will look at the features of each of these tools and the companies using them. So let's start off. At number 10, we have Microsoft Excel. All of us would have used Microsoft Excel at some point, right? It is easy to use and one of the best tools for data analysis. Developed by Microsoft, Excel is basically a spreadsheet program. Using Excel, you can create grids of numbers, text, and formulae. It is one of the widely used tools, be it in a small or large setup. The interface of Microsoft Excel looks like this. Let's now move on to the features of Excel. Firstly, Excel works with almost every other piece of software in Office. We can easily add Excel spreadsheets to Word documents and PowerPoint presentations to create more visually appealing reports or presentations. The Windows version of Excel supports programming through Microsoft's Visual Basic for Applications (VBA). Programming with VBA allows spreadsheet manipulation that is difficult with standard spreadsheet techniques. In addition to this, the user can automate tasks such as formatting or data organization in VBA. One of the biggest benefits of Excel is its ability to organize large amounts of data into orderly, logical spreadsheets and charts. By doing so, it's a lot easier to analyze data, especially while creating graphs and other visual data representations. The visualization can be generated from a specified group of cells. Those were few of the features of Microsoft Excel. Let's now have a look at the companies using it. Most of the organizations today use Excel. Few of them that use it for analysis are the UK-based company Ernst & Young. Then we have Urban Pro, Wipro, and Amazon. Moving on to our next data analysis tool, at number 9, we have RapidMiner. A data science software platform, RapidMiner provides an integrated environment for data preparation, analysis, machine learning, and deep learning. It is used in almost every business and commercial sector. RapidMiner also supports all the steps of the machine learning process. Seen on your screens is the interface of RapidMiner. Moving on to the features of RapidMiner. Firstly, it offers the ability to drag and drop. It is very convenient to just drag drop some columns as you are exploring a data set and working on some analysis. RapidMiner allows the usage of any data, and it also gives an opportunity to create models which are used as a basis for decision making and formulation of strategies. It has data exploration features such as graphs, descriptive statistics, and visualization, which allows users to get valuable insights. It also has more than 1,500 operators for every data transformation and analysis task. Let's now have a look at the companies using RapidMiner. We have the Caribbean airline Leeward Islands Air Transport. Next, we have the United Health Group, the American online payment company PayPal, and the Austrian telecom company Mobilcom. So that was all about RapidMiner. Now let's see which tool we have at number 8. We have Talent at number 8. Talent is an open source software platform which offers data integration and management. It specializes in big data integration. Talent is available both in open source and premium versions. It is one of the best tools for cloud computing and big data integration. The interface of Talent is as seen on your screens. Moving on to the features of Talent. Firstly, automation is one of the great boons Talent offers. It even maintains the tasks for the users. This helps with quick deployment and development. It also offers open source tools. Talent lets you download these tools for free. The development costs reduce significantly as the processes gradually speed up. Talent provides a unified platform. It allows you to integrate with many databases, SaaS, and other technologies. With the help of the data integration platform, you can build flat files, relational databases, and cloud apps 10 times faster. Those were the features of Talent. The companies using Talent are Air France, L'Oreal, Capgemini, and the American multinational pizza restaurant chain Domino's. Next on the list at 7 we have KNIME. Constance Information Miner on KNIME is a free and open source data analytics, reporting, and integration platform. It can integrate various components for machine learning and data mining through its modular data pipelining concept. KNIME has been used in pharmaceutical research and other areas like CRM customer data analysis, business intelligence, text mining, and financial data analysis. Here is how the interface of KNIME application looks like. Now coming to the KNIME features. KNIME provides an interactive graphical user interface to create visual workflows using the drag and drop feature. Use of JDBC allows assembly of nodes blending different data sources, including pre-processing such as ETL, that is extraction, transformation, loading, for modeling, data analysis, and visualization with minimal programming. It supports multi-threaded in-memory data processing. KNIME allows users to visually create data flows, selectively execute some or all analysis steps, and later inspect the results, models, and interactive views. KNIME Server automates workflow execution and supports team-based collaboration. KNIME integrates various other open source projects such as machine learning algorithms from Beca, H2O, Keras, Spark, and our project. KNIME allows analysis of 300 million custom addresses, 20 million cell images, and 10 million molecular structures. Some of the companies hiring for KNIME are United Health Group, ASML, Fractal Analytics, Atos, and Lego Group. Let's now move on to the next tool. We have SAS at number 6. SAS facilitates analysis, reporting, and predictive modeling with the help of powerful visualizations and dashboards. In SAS, data is extracted and categorized, which helps in identifying and analyzing data patterns. As you can see on your screens, this is how the interface looks like. Moving on to the features of SAS. Using SAS, better analysis of data is achieved by using automatic code generation and SAS SQL. SAS allows you to access through Microsoft Office by letting you create reports using it and by distributing them through it. SAS helps with an easy understanding of complex data and allows you to create interactive dashboards and reports. Let's now have a look at the companies using SAS. We have companies like Genpact, IQVIA, Accenture, and IBM to name a few. That was all about SAS. So for all those who joined in late, let me just quickly repeat our list. At number 10, we have Microsoft Excel. Then at number 9, we have RapidMiner. At number 8, we have Talent. At number 7, we have 9. And at number 6, we have SAS. So far, do you all agree with this list? Let us know in the comment section below. Let's now move on to the next 5 tools in our list. So at number 5, we have both R and Python. Yes, we have 2 of them in the 5th position. R is a programming language which is used for analysis as well. It has traditionally been used in academics and research. Python is a high-level programming language which has a Python data analysis library. It is used for everything starting from importing data from Excel spreadsheets to processing them for analysis. This is the interface of R. Next up is the interface of the Python Jupyter Notebook. Let's now move on to the features of both R and Python. When it comes to the availability of R and Python, it is very easy. Both R and Python are completely free, hence it can be used without any license. R used to compute everything in memory and hence the computations were limited, but now it has changed. Both R and Python have options for parallel computations and good data handling capabilities. As mentioned earlier, as both R and Python are open in nature, all the latest features are available without any delay. Moving on to the companies using R, we have Uber, Google, Facebook, to name a few. Python is used by many companies. Again, to name a few, we have Amazon, Google, and the American photo and video sharing social networking service, Instagram. That was all about R and Python. At number 4, we have Apache Spark. Apache Spark is an open source engine developed specifically for handling large-scale data processing and analytics. Spark offers the ability to access data in a variety of sources including Hadoop Distributed File System HDFS, OpenStack Swift, Amazon S3, and Cassandra. It allows you to store and process data in real time across various clusters of computers using simple programming constructs. Apache Spark is designed to accelerate analytics on Hadoop while providing a complete suite of complementary tools that include a fully featured machine learning library, a graph processing engine, and stream processing. So this is how the interface of Apache Spark looks like. Now let's look at the important features of Apache Spark. Spark stores data in the RAM, hence it can access the data quickly and accelerate the speed of analytics. Spark helps to run an application in a Hadoop cluster up to 100 times faster in memory and 10 times faster when running on disk. It supports multiple languages and allows the developers to write applications in Java, Scala, R, or Python. Spark comes up with 80 high-level operators for interactive querying. Spark code for batch processing, join stream against historical data, or run ad hoc queries on stream state. Analytics can be performed better as Spark has a rich set of SQL queries, machine learning algorithms, complex analytics, etc. Apache Spark provides fault tolerance through Spark RDD. Spark resilient distributed data sets are designed to handle the failure of any worker node in the cluster. Thus, it ensures that the loss of data reduces to 0. Conviva, Netflix, IQVIA, Lockheed Martin, and eBay are some of the companies that use Apache Spark on a daily basis. At number 3, we have another important growing data analysis tool, that is QlikView. QlikView software is a product of Qlik for business intelligence and data visualization. QlikView is a business discovery platform that provides self-service BI for all business users and organizations. With ClickView, you can analyze data and use your data discoveries to support decision making. ClickView is a leading business intelligence and analytics platform in Gartner Magic Quadrant. On the screen, you can see how the interface of ClickView looks like. Now talking about its features. ClickView provides interactive guided analytics with in-memory storage technology. During the process of data discovery and interpretation of collected data, the ClickView software helps the user by suggesting possible interpretations. ClickView uses a new patent in-memory architecture for data storage. All the data from the different sources is loaded in the RAM of the system and it is ready to be retrieved from there. It has the capability of efficient social and mobile data discovery. Social data discovery offers to share individual data insights within groups or out of it. A user can add annotations as an addition to someone else's insights on a particular data report. ClickView supports mobile data discovery within an HTML5-enabled touch feature which lets the user search the data and conduct data discovery interactively and explore other server-based applications. ClickView performs OLAP and ETL features to perform analytical operations, extract data from multiple sources, transform it for usage, and load it to a data warehouse. The companies that can help you start your career in ClickView are Mercedes-Benz, Capgemini, Citibank, Cognizant, and Accenture, to name a few. At number 2, we have Power BI. Power BI is a business analytics solution that lets you visualize your data and share insights across your organization or embed them in your app or website. It can connect to hundreds of data sources and bring your data to life with live dashboards and reports. Power BI is the collective name for a combination of cloud-based apps and services that help organizations collate, manage, and analyze data from a variety of sources through a user-friendly interface. Power BI is built on the foundation of Microsoft Excel and has several components such as Windows desktop application called Power BI Desktop and online software as a service called Power BI Service, mobile Power BI apps available on Windows phones and tablets, as well as for iOS and Android devices. Here is how the Power BI interface looks like. As you can see, there is a visually interactive sales report with different charts and graphs. Moving on to the features of Power BI. It has an easy drag and drop functionality with features that make data visually appealing. You can create reports without having the knowledge of any programming language. Power BI helps users see not only what's happened in the past and what's happening in the present, but also what might happen in the future. It offers a wide range of detailed and attractive visualizations to create reports and dashboards. You can select several charts and graphs from the visualization pane. Power BI has machine learning capabilities with which it can spot patterns in data and use those patterns to make informed predictions and run what-if scenarios. Power BI supports multiple data sources such as Excel, text CSV, Oracle, SQL Server PDF, and XML files. The platform integrates with other popular business management tools like SharePoint, Office 365, and Dynamics 365, as well as other non-Microsoft products like Spark, Hadoop, Google Analytics, SAP, Salesforce, and MailChimp. Some of the companies using Power BI are Adobe, AXA, Carlsberg, Capgemini, and Nestle. Moving on to the next tool. So any guesses as to what we have at number 1? You can comment in the chat section below. Finally, on the top of the pyramid, we have Tableau. Gartner's Magic Quadrant of 2020 classified Tableau as a leader in business intelligence and data analysis. Tableau Interactive Data Visualization Software Company was founded in Jan 2003 in Mountain View, California. Tableau is a data visualization software that is used for data science and business intelligence. It can create a wide range of different visualization to interactively present the data and showcase insights. The important products of Tableau are Tableau Desktop, Tableau Public, Tableau Server, Tableau Online, and Tableau Reader. This is how the interface of Tableau Desktop looks like. Now coming to the features of Tableau. Data analysis is very fast with Tableau, and the visualizations created are in the form of dashboards and worksheets. Tableau delivers interactive dashboards that support insights on the fly. It can translate queries to visualizations and import all ranges and sizes of data. Writing simple SQL queries can help join multiple data sets and then build reports out of it. You can create transparent filters, parameters, and highlighters. Tableau allows you to ask questions, spot trends, and identify opportunities. With the help of Tableau Online, you can connect with cloud databases, Amazon Redshift, and Google BigQuery. The companies using Tableau are Deloitte, Adobe, Cisco, LinkedIn, and the American e-commerce giant Amazon, to name a few. And there you go, those are the top 10 data analysis tools. Let's now have a question and answer session. Please feel free to post your queries in the comments section and we'll respond in the chat. Before the question and answer session, let's recap quickly. In the meanwhile, y'all can post your questions in the comment section below. So at number 10, we have Microsoft Excel. Then at number 9, we have RapidMiner. At number 8, we have Talend. At number 7, we have Nime. At number 6, we have SAS. R and Python at number 5, Apache Spark at number 4, ClickView at number 3, Power BI at number 2, and finally we have Tableau topping the list at number 1. Currently, all of us are living in an information-driven world, and organizations rely on data for various decision makings. This in turn provides a lot of job opportunities for candidates who can play with data. Out of the many job roles in the field of data science, the two popular ones are that of a data scientist and a data analyst. Haven't we all wondered at some point as to what the exact difference is between these two job roles? Or wait, are they the same? Well, they differ in various ways, and you will see how in this video. We will start off by looking at the job descriptions of both the data scientist and the data analyst. Then we will look at their responsibilities and skill set. We will also have a look at their salary structure and the various companies hiring for these professionals. So without further ado, let's get started. Let's have a look at the job description now. A data scientist is a professional who uses different statistical methods, data analysis techniques, and machine learning in order to understand and analyze data in order to arrive at business conclusions. They proactively fetch information from a plethora of sources and analyze it for better understanding about how the business performs, and they also build AI tools that automate certain processes within the company. They derive meaning out of messy and unstructured data. A data scientist is usually a senior-most member in the team. Moving to the description of data analyst, a data analyst is responsible to collect, process, and perform analysis on large data sets. They deal with data handling, data modeling, and reporting. They are sometimes the entry-level members into the data analytics team. They bring technical expertise to ensure the quality and accuracy of the data, then process, design, and present it in ways to help people, businesses, and organizations make better decisions. After a few years of experience, data analysts can move into the roles of a data engineer and a data scientist. Now that we have understood the job descriptions, let's go ahead and understand the various roles and responsibilities of a data scientist and a data analyst. Firstly, data scientists are responsible for performing cleaning, processing, and manipulation of data using several data analytics tools. They also perform ad hoc data mining and collect large sets of structured and unstructured data from a number of sources. Secondly, data scientists interpret the data using various statistical methods. They design and evaluate advanced statistical models to work on big data. Thirdly, data scientists regularly build predictive models and machine learning algorithms to work on vast volumes of data. Lastly, data scientists use visualization packages and tools to create reports and dashboards for relevant stakeholders. They also work with data analysts and data engineers to formulate the analysis results. Let's now have a look at the various responsibilities of a data analyst. The first responsibility of a data analyst is to recognize and understand the company's goal. This in turn helps in streamlining the whole analysis process. They are required to assess the available resources, comprehend the business problem, and gather the right set of data. This step is done by collaborating with different team members such as data scientists, business analysts, and programmers. They gather data from various databases and warehouses through querying. They write complex SQL queries and scripts to gather and extract information. Data analysts also filter and clean data to get the required information. They are responsible for data mining as well. Data is mined from various sources and then organized in order to obtain new information from it. Data analysts identify and analyze trends in complex data sets using various statistical tools. A data analyst is also responsible for creating summary reports for the leadership team so that they can make timely decisions. Data analysts use multiple data visualization tools for achieving this. In order to achieve all the above-mentioned responsibilities, data scientists and data analysts are required to possess a rich skill set. Let's now have a look at few of the most important skills required to back the position of a data scientist. The basic requirement to become a data scientist is that you must have a bachelor's degree in computer science or information technology. But a master's degree in the field of data science will be a lot more beneficial. You also need to have a good experience in the analytics domain. As I mentioned before, this role is a senior role, and to get here, the right amount of experience is a must. Let's have a look at the tools you need to know. Knowledge of Microsoft Excel is good. It is one of the most basic requirements. Speaking of programming languages, you should be good at Python, C++, and Java. Knowledge of Perl is a brownie point. You should also be proficient in SQL. As we discussed earlier, data scientists work on building machine learning algorithms. Hence, you need to have a good knowledge of machine learning and deep learning. Familiarity with Apache Spark, Apache Hive, and Apache Pig is necessary along with the knowledge of Hadoop. Data visualization and BI skills are necessary for creating reports and dashboards. You should also be able to communicate and present information and ideas clearly. So these are the skills required to become a data scientist. If you want to explore the role of a data analyst, then you should hold a degree in any relevant field, be it engineering and computer science, information technology, or electrical engineering. You can also be a graduate in statistics or economics. Moving on to the tools, once again, you should be familiar with Microsoft Excel. The next important skill is that you should have good hands-on experience with programming languages such as Python, R, and JavaScript. This would help you write programs to solve complex problems. You should also have a good knowledge of statistical and data analytics tools such as SAS, Miner, and SSAS. You must be able to write various SQL queries and procedures. In addition to these, you must have a strong understanding of statistics and machine learning algorithms. These include concepts such as hypothesis testing, probability distributions, and various classification and clustering techniques. Most importantly, a data analyst should be able to create visually appealing reports with the help of charts and graphs using several data visualization tools such as Power BI and Tableau. They must possess good presentation skills as well in order to convey their ideas to the clients and stakeholders in a better way. So these are the skills that are required to become a data analyst. Let's now have a look at the annual salary range of a data scientist and a data analyst both in the US and in India. In the United States, a data scientist can earn a minimum salary of $61,000 to a maximum of $136,000 per year. Meanwhile, in India, a data scientist can earn a minimum salary of 3,47,000 rupees to a maximum of 2 million rupees per annum. A data analyst in the United States can earn a minimum salary of $43,000 to a maximum of $85,000 per year. In India, you can earn anywhere between 1,98,000 rupees to 9,24,000 rupees per annum. Let's now take a look at the various companies hiring data scientists and data analysts. Here we have Amazon, the internet and search engine giant Google, Deloitte, the American multinational technology company Microsoft, then we have Apple and the American social media web and mobile application company Pinterest hiring data scientists. From the many companies hiring data analysts, here we once again have Amazon, then we have the popular retail company Walmart, Robert Half and AT&T. Next, we have social media firms Facebook and Twitter. As you might have heard of the term data never sleeps, well, it surely doesn't. And not only that, but it also brings in a number of job opportunities with it. The job growth in this domain is limitless, and data will only continue to grow. Let's have a look at a few of the stats now. Well, IBM had predicted that by this year, that is 2020, the number of job listings in the field of data science and analytics will increase by 3,64,000. And we had the US Bureau of Labor Statistics predicting that there will be a rise in the data science needs, and this in turn will create 11.5 million job openings by 2026. Now that's a big number, isn't it? And if you are aspiring to become a data scientist, then you are on the right path as there is a huge demand for this role. According to Deloitte, the United States is projected to face a shortfall of 250,000 data scientists by 2024. That's barely just in 4 more years. All these stats prove that the job demand in the field of data science and data analytics is here to stay. Professionals belonging to this domain are in high demand all across the globe. Now let's have a look at the Google search trends for data scientists and data analysts. As you see, the blue color depicts data scientists and the red data analysts. Both the search trends go hand in hand, and over time the search term data analyst is higher, but the search term of that of a data scientist is experiencing a steady rise. Let's have a look at the worldwide YouTube search trend as well. As you can see on your screens, it looks like people are more keen on exploring the job role of a data scientist, and looks like they want to learn more about the job role of a data scientist compared to that of a data analyst. Nevertheless, the search term data analyst is also right there in the competition.
We're going to look at 3 very important data-related roles in the field of data science, and then we're going to pit them against each other. So welcome to data scientist versus data analyst versus data engineer. Now let's have a look at what's in store for you. Firstly, we'll talk about the job descriptions, the skill sets required for each role, the salary, the roles and responsibilities, and the companies hiring for these positions. So now let's have a look at each of these roles in detail. First off, let's have a look at data scientist. Now, a data scientist is able to create machine learning based tools or processes within the company. Now, they use advanced data techniques such as clustering, division trees, neural networks, and so on, so that they can derive business conclusions. They are the senior most member in the team, which involves a data engineer as well as a data analyst. Now, they need to have in-depth knowledge of statistics, data handling, and machine learning. They also take inputs from data engineers as well as analysts so that they can formulate actionable insights for the business. Now, a data scientist also needs to have the same skills as a data analyst and an engineer, but needs to have a lot more in-depth knowledge and expertise with these skills. Next, Next up, we have data analyst. Now, a data analyst is someone who's able to translate numeric data into a form that everyone in the organization can understand. Now, this is an entry-level position in the data analytics team. He or she needs to have technical skills in programming languages such as Python and have knowledge of tools like Excel and understand the basics of data handling, modeling, and reporting. Now, in due time, they can move up the ranks by taking up roles of data engineer and data scientist with some experience that they can accumulate over the years. And finally, we have data engineer. Now, a data engineer is someone who's involved with preparing data, for analytical or operational purposes. Now, they are the intermediary between the data analyst and the data scientist. He or she needs to have a lot of experience when it comes to developing, constructing, and maintaining architectures. Now, they do generally work on big data and submit their reports to the data scientist so that they can be analyzed. Now let's have a look at the skill sets required for each of these roles. First off, we have data scientist. Now, since this role is a little more coding oriented, you need to know a great deal when it comes to programming languages. Programming languages such as Python, R, SQL, SAS, Java, and so on. Now, you also need to be well versed with frameworks in relations to big data such as Pig, Spark, and Hadoop. Speaking of Hadoop, if you want to learn more about how it works, I suggest you click on the top right corner and watch our video on what is Hadoop. Coming back, data scientists also need to be well versed with machine learning, deep learning, and other similar technologies. Next up, we have data analyst. Now, this role is much less technical as compared to a data scientist as well as a data engineer, considering how it's entry level. Here, knowing programming languages is a great bonus. So, an idea about programming languages such as Python, R, SQL, JavaScript, SSAS, and so on is a great benefit. At the same time, you do need to be well versed with tools such as SAS Miner, Microsoft Excel, SSAS, SPSS, and so on. And finally, we have data engineer. Now, being a data engineer requires you to be well versed with a bunch of programming languages as well as frameworks. Now, you need to know about programming languages such as Python, R, SQL, SAS, Java, and so on, while having expertise in frameworks such as Hadoop, MapReduce, Hive, Pig, Apache Spark, data streaming, NoSQL, and so on. Now, let's talk about money, or the salary each of these roles get. Firstly, we have the data scientist, who earns a whopping $137,000 per annum. Then we have the data analyst, who earns $67,000 per annum, which is a pretty high salary when you consider that it's only an entry-level job. And a data engineer, which is in the median with $116,000 per annum. Now let's talk about roles and responsibilities. Firstly, we have the data scientist. Now, a data scientist gets to work with a lot of unstructured data, so they need to mine and clean the data so that it's usable. They need to be able to design machine learning models to work on the big data. They need to infer and interpret the analysis on big data, to be able to lead an entire team to achieve the goals of the organization and deliver conclusions that have a direct business impact. Now let's have a look at the roles and responsibilities of a data analyst. They need to use queries to gather information from a database. They need to process the data and provide summary reports. They need to use basic algorithms for their work, such as linear regression, logistic regression, and so on, and have core skills in statistics, data munging, data visualization, and exploratory data analysis. And finally, we have data engineer. Now, they need to mine through the data so that they can gain insights from it. They need to convert erroneous data into a usable form so that they can be further analyzed. They need to write queries on data. They need to maintain the design as well as architecture of the data and create large data warehouses using ETL or extract transform load. Now let's have a look at some of the companies hiring for this role. Firstly, for data scientists, you have Citibank, Facebook, Schneider, Intel, Amazon, and so on. For data analysts, you have Infosys, Oracle, Visa, Capital One, Walmart, and so on. And for data engineer, you have Google, Cisco, Flowcast, Cognizant, Apple, Spotify, and much more. So if all this has inspired you to get started with data science, I suggest you take Simplilearn certification. Now, I'm choosing this certification because it acts as a great entry point for starting your career as a data analyst or a data engineer. Now, with this certification, it goes through all the important concepts when it comes to data science and has 68 hours of in-depth learning, 4 real-life industry-based projects, interactive learning with Jupyter notebooks, and dedicated mentoring sessions from our faculty of industry experts. Now, some of the concepts are you'll be going through statistical analysis and business applications, Python environment setup, mathematical computing with Python, which is NumPy, SciPy, data manipulation with Pandas, machine learning with scikit-learn, and so much more. So then you can start up on your step to becoming a data analyst, a data engineer, and then eventually a data data scientist. Now, if you're already working as a data analyst or a data engineer, you can become a certified data scientist with Simplilearn's Data Scientist Master's Program. This goes through all the important concepts that you need to know so that you can become a successful as well as certified data scientist.
We'll compare the two most popular job roles in the field of information technology, that is, business analyst versus data analyst. First, let's understand the job description of a business analyst. Business analyst is a professional who bridges the gap between the IT and the business teams in an organization. They use data analytics and modern technologies to assess processes and deliver data-driven solutions. They understand and solve a business problem and validate business requirements. A business analyst generates reports for executives and stakeholders. They are part of the business operation and work closely with the technology team to improve the quality of the services being delivered. They also assist in the integration and testing of new solutions. Now let's talk about the job description of a data analyst. With the rapid increase in data generation today, the term data analyst has found its prominence. A data analyst collects, processes, and performs analysis of large data sets. Every business generates data in several formats. This data can be in the form of customer information and feedback, log files, transaction data, marketing research, and so on. It is the duty of a data analyst to transform these business data into valuable insights. Some of the problems that can be addressed are how to improve a business, how to provide good customer experience, what would be the ideal price for a new product, how to reduce transportation costs, and so on. Data analysts deal with data handling, data modeling, and reporting. With this brief understanding of the job description for a business analyst and a data analyst, let's now shift our focus towards the various responsibilities of a business analyst. A business analyst identifies the business goals, understands the problems faced by an organization, and comes up with a cost-effective solution to tackle the issues. They thoroughly understand the requirements from the clients and assign the right resources. BAs communicate and work closely with the development team to design the solution for a problem. They ensure that the development team doesn't spend their time understanding the stakeholders' requirements and often give iterative feedback on the solution being developed. They check and validate if the project is running fine with the help of user acceptance testing. They also verify if the solution being worked on is in line with the requirements and ensure that the final product satisfies the user expectations. BAs assess the functional and non-functional requirements. A business analyst documents the project findings and results. They present the project conclusions to the stakeholders and clients along with delivering maintenance reports and building visualizations to make decisions. Now, let's take a look at the responsibilities of a data analyst. First and foremost, a data analyst must identify and understand the organization's goal and requirements. This helps to plan and streamline the analysis process. Data analysts collect data from various heterogeneous sources. They assess the available resources, comprehend the business problem, and gather the right data for analysis. They work closely with different team members like programmers, business analysts, and data scientists. Data filtering and data wrangling are vital jobs of a data analyst. The data collected is often noisy and it contains missing values. Hence, it is crucial to clean the collected data and remove invalid values to make it ready for analysis. They use a variety of analytical, statistical, and business intelligence tools to spot trends and patterns in complex data sets, discover hidden insights, and prepare summary reports for the leadership team. They also use programming languages for data mining and data manipulation. Now it's time for us to understand the difference between a business analyst and a data analyst based on the skill set they possess. First, let's look at the skills that can help you become a BA. A business analyst should have a graduation degree in any relevant field such as business, accounting, information systems, human resources, or engineering. You can apply for entry-level business analyst positions or with professional experience. Excel is a powerful analytics and reporting tool for working with data. BAs use Excel to perform various calculations, data analysis, plan an editorial calendar, and calculate customer discounts to derive meaningful insights and take decisions. BAs use SQL to retrieve, manipulate, and analyze data stored in relational databases. Critical thinking skills are important to understand customers' business needs. It allows them to distinguish between requirements that add value to the business and those that should be given a lower priority. BAs should find different ways to address each challenge. Data visualization is a key skill for BAs to build interactive dashboards and reports to convey the outcomes of a project. Knowledge of Tableau, Power BI, and ClickView is required to make different types of reports depending on the business requirements. Business analysts should have a good hands-on programming experience to solve complex tasks and perform faster analysis of data. Hence, knowledge of programming languages such as R and Python is a prerequisite. Finally, they should have good presentation skills. They should also be confident about their findings and conclusions and communicate it in front of the stakeholders and clients. Let's now understand the skills that a data analyst should possess. You must have a bachelor's degree in any relevant field or be a graduate in statistics, economics, or science. You're eligible to become a data analyst being a fresher or as an experienced professional. You should have domain knowledge in the field you are working in. Once again, knowledge of Excel is another basic requirement for a data analyst. Data analysts often work with structured data, so they should be proficient in writing SQL queries using data manipulation and data definition commands. They should know how to create stored procedures. Another crucial skill for a data analyst is to have hands-on experience with programming languages such as Python, R, SAS, and JavaScript. You can analyze and visualize large data sets and create predictive models for making business decisions. Data analysts create data visualizations using libraries such as Matplotlib, Seaborn, ggplot, and Plotly. This helps them to perform exploratory data analysis. Knowledge of Tableau and Power BI is required to create different business reports with the help of graphs and charts. Data analysts should have knowledge of machine learning algorithms to build sophisticated models and make future predictions. So they should know about linear regression, logistic regression, support vector machines, k-mean clustering, and other supervised and unsupervised learning algorithms. Finally, data analysts should also possess good communication and presentation skills. Now, let's discuss the salary structure for both of these job roles. According to PayScale, a business analyst in the United States earns an average salary of $69,000, while in India, you can earn nearly 6 lakh rupees per annum. Now, talking about the salary of a data analyst, according to PayScale, in the US, a data analyst earns an average salary of $60,710 per annum. And in India, you can earn around 4,24,000 rupees per annum. Let's now move on and look at the different companies hiring for business analyst roles. Here, we have Oracle, the search engine giant Google, the American MNC Cognizant, and e-commerce company Amazon. In addition to that, we have Ernst & Young, technology giant IBM, Dell, and Cisco hiring business analysts. Talking about the companies hiring for data analysts, we have Twitter, Google, the social media leader Facebook, and Amazon. We also have the American oil company Shell, the electric vehicle company Tesla, Apple, and the American credit reporting agency Equifax. Now, choosing the right field, that is, to become a business analyst or a data analyst, could be a challenging task. The key points that you have to keep in mind before making a decision is: first, review your background and see what qualifications you have. Check what skills you possess and the domain knowledge you have. Then, gauge your interest to see what suits you best. And finally, consider your long-term goals and see the job roles that will help you grow in your career in the long run. Now, let me tell you how Simplilearn can help you grow your career as a business analyst and a data analyst. Simplilearn offers a postgraduate program in business analysis that is in collaboration with Purdue University. The endorsed education provider is IIBA. Some of the skills that will be covered in this course are strategy analysis, wireframing, solution evaluation, dashboarding, data visualization, agile Scrum methodology, Scrum artifacts, statistical analysis using Excel and SQL database. Some of the tools covered in this course are Microsoft Excel, Tableau, Power BI, Jira, PostgreSQL, Planbox, and others. Some of the key features of this business analysis program are: you will receive Purdue Postgraduate Program Certification, masterclasses from Purdue faculty, you can enroll in Simplilearn's Job Assist where you will get IIM Jobs Pro membership for 6 months and obtain 35 IIBA PDs CDUs and 25 PMI PDUs. You will get 170 plus hours of blended learning along with capstone projects in 3 domains. To become a data analyst, you can enroll in the postgraduate program in data analytics offered by Simplilearn. This program is in collaboration with Purdue University and IBM. The skills that will be covered as a part of the course are statistical analysis using Excel, data analysis in Python and R, data visualization using Tableau and Power BI, linear and logistic regression modules, clustering using K-means, supervised learning, and others. The tools that you will learn are NumPy, Pandas, SciPy, Scikit-learn, Excel, and others. Some of the key features of this course are: you will get Purdue Postgraduate Program Certification, industry-recognized IBM certificates, enrollment in Simplilearn's Job Assist and masterclasses from Purdue faculty. You have 180 plus hours of blended learning, 14 plus hands-on projects on integrated labs, and capstone projects in 3 domains. So please go ahead and enroll for these programs if you want to grow your career as a business analyst or a data analyst.
Applications of data analytics. Now, the sky's the limit on this. In today's world, almost every business act of life, your music on your Spotify, are driven by data analytics. But some of the big players, when you go in there job hunting, are going to be your fraud analysis. If you want to go make a lot of money and you're good at it and you like dealing with numbers, go join the banks and track down the criminals who are stealing money. It's a lot of, it's a big thing to protect credit cards, protect sales purchases, bad checks, any of those things. When you can track them down is huge. Healthcare, exploding. There's everything from trying to find cures for the COVID virus or any of the viruses out there, using your cell phone to diagnose different ailments. That way you don't have to go in and see the doctor. You can actually just go in there and take a picture of the funky growth on your arm. Hopefully it's not too big. And then they send it in there and the data analytics goes in there and looks at it and says, oh, this is what this is. This is the professional you need to go see or don't need to see. And that's just one aspect of healthcare. The databases being generated by healthcare and getting the right doctors and helping the doctors analyze whether something is benign or malignant, if it's cancerous. All those things are now part of the ongoing healthcare growth in data analytics. Inventory management. Think one of those huge warehouses where they're shipping out all the goods. How do you inventory that in such a way so that you maximize the stuff that's being purchased the most near the entrance and all the other stuff towards the back, or even pre-ship it? So it's huge to be able to manage your inventory, and pretty soon they'll just have a drone come in there and start picking up some of those boxes and move them around also. Delivery logistics. Again, this goes from getting from point A to point B. You can combine it with our inventory, so you pre-ship stuff if you know a certain area is more likely to purchase it. How do you get the delivery to the most destinations the quickest in the short amount of time? And then they even pre-stack the trucks going out, and that's all done with data analytics. How do we stack all that stuff so it comes out in the right order? Targeted marketing, huge industry. Any kind of marketing, whether you're generating the right content for the marketing, who are you targeting with that marketing, researching the people, what they want, so you know what products to market out there. All those things are huge. And these are just a few examples. You can probably go way beyond this, from tracking forest fires to astrology and studying the stars. All of this is part of data analytics now and plays a huge role in all these different areas. City planning is another one. You can see a nice organized city like this one where you can get in and out of the neighborhoods if you're a fire truck. Police officers need to be able to get in and out. You want your tourists to be able to come in, yet you still want the place to look nice, and you have the right commercial development, the right industrial development, like enough residents for people to stay. All those things are part of your city planning. Again, huge in data analytics. So, sky's the limit on what you use it for. Let's take a look at types of data analytics. And this can be broken up in so many ways, but we're going to start with looking at the most basic questions that you're going to be asking in data analytics. And the first one is you want descriptive analytics. What has happened? Hindsight. How many sales per call ratio coming out of the call center? If we have 500 tourists in a forest and you have a certain temperature, how many fires were started? How many times did the police have to show up to certain houses? All that's descriptive. The next one is predictive. Predictive analytics is what will happen next. We want to predict. This is great if you have an ice cream store and you want to predict how many people to work at the ice cream store on a certain day based on the temperature coming up and the time of the year. And then one of the biggest growing and most important parts of the industry is now prescriptive analytics. And you can think of that as combining the first two. We have descriptive and we have predictive, and then you get prescriptive analytics. How can we make it happen? Foresight. What can we change to make this work better? In all the industries we looked at before, we can start asking questions, especially in city development. There's a good one. If we want to have our city generate more income, and we want that income to be commercial based, what kind of commercial buildings do we need to build in that area that are going to bring people over? Do we need huge warehouse sales, Costco sales buildings, or do we need little mom and pop joints that are going to bring in people from the country to come shop there? Or do you want an industrial setup? What do you need to bring that industry in there? Is there a car industry available in that area? If it's not a car industry, what other industries are in that area? All those things are prescriptive. We're guessing. We're guessing what can we do to fix it? What can we do to fix crime in an area with education? What kind of education are we going to use to help people understand what's going on so that we lower the rate of crime and we help our communities grow better? That's all prescriptive. It's all guessing. We want foresight into how can we make it happen? How can we make this better? And we really can't not go into enough detail on these three, because a lot of people stumble on this when they come in and are doing analytics. Whether you're the manager, shareholder, or the data scientist coming in, you really need to understand the descriptive analytics, where you're studying the total units of furniture sold and the profit that was made in the past. Here we go into predictive analytics, predicting the total units that would sell and the profit we can expect in the future, gear up for how many employees we need, how much money we're going to make, and prescriptive analytics, finding ways to improve the sales and the profit so we can sell maybe a different kind of furniture. We're going to guess at what the area is looking for and how that marketing is going to change. Data analytics process steps. So let's take a look at some of the basic processing and what that looks like when you're working with this data. So there's 5 basic steps. The 5 steps of processing, and this changes, and then there's a lot of things that go on when they talk about agile programming. The whole concept of agile is you take some kind of framework like this and then you build on it depending on what your business needs. So the first step is data collection. And usually with a large company you might have somebody who is responsible for the database management. You might have another one where they're pulling APIs and they're pulling data off of maybe the Census Bureau, maybe something very, very specific, domain specific. So if you're analyzing cancerous growths and how to understand them, then the data collection is going to be those measurements they take from the MRI. Or it might be even the MRI images. They've used those also. So there's a lot of things with data collection and how to control that and make sure it has what you need and is clean and you don't have misinformation coming in. Once you have the data collected, there's a data preparation. So stage 2 is we take that data and we format it into something we can use. Probably one of the biggest formats that you see is when you're processing text. How do you process text? Well, you use what they call a one-hot encoder, and each word is represented by a yes-no kind of setup. So it'd be like a long array of bits. That's one way to prepare it. And so, bit number 1 is the. Bit number 2 is has, or whatever it is. Other preparations might be if you're using neural networks, you might be taking integers or float numbers and converting them to a value between 0 and 1. That way you don't have one of them creating a bias in there. So there's a lot of different things that go into data preparation. That is 80% of data science. So when we talk about the data analytics, which is a little bit more on the math side, and they usually talk about a data scientist kind of being the overall preparer of this stuff, you're going to spend 80% of your data preparation. Data exploration, that's the fun part. This is where you're exploring things. And it is maybe 10 to 15% of what you do with the data you spend with the data exploration. It is probably the most important step, because this is where you got to start asking questions. If you ask your questions wrong, you're going to get some wrong information. If you're working with a company and they want to know the marketing values, then you really got to focus on, hey, how do we generate money for this company? Or fraud, how do we lower the fraud rate? while still generating a profit. 4, data modeling. This is where we start actually getting into the data code, which model to use that predicts what's going to happen. And then result interpretation. We want to be able to interpret those results. You usually see that in your Matplot library, where you create nice, beautiful images so that it shows up on their dashboard for the marketing manager or for the CEO, so they can take a quick look and say, hey, I can see what's going on there. You want to reduce it to something they can easily read. They don't want to hear the scientific terms. They want to see something they can use. And we'll talk about that a little bit more when we start looking at some of this in a demo.
Let's look at one more interesting feature of Excel, and that's your conditional formatting. Now, as you see on the screen, conditional formatting has different rules which can be applied on your data, and that allows you to basically differentiate or easily identify data values which are based on certain criteria or rules. So when you talk about conditional formatting, you have different options, such as you can highlight cell rules, you can get top and bottom values, you can apply different rules, apply different color scales, and you can easily manage these rules. So conditional formatting is very useful for people who would want to work on huge amount of data and easily perform some data analysis. It's easy to use as it is shown here, and with your conditional formatting, you can format cells based on a preset condition. You can perform conditional formatting to identify cells. You can highlight a few significant cells, and you can easily perform conditional formatting as shown on the left side. Now, how do we work with conditional formatting? Let's have a quick look. So say, for example, we have our Excel sheet, and if you see here, I am highlighting the salesperson who have generated revenue greater than 10,000. So we can be looking at the values where the revenue generated by a particular salesperson is greater than 10,000. It has a particular color. And how do we get here? So for example, let's select this data, and what I could do is I could go into conditional formatting. Now I could basically highlight cell rules, and we could just say greater than. That's an easier way. I could also go ahead and create a new rule, but then I can use one of this option. I can say greater than, and let's give some value. Might be we would be interested in looking at any value greater than 12,000. So let's choose 12,000. And here it says what color would you want to select. So for example, I would say something like yellow filled with dark yellow text, and let's say okay. So right now what I'm doing is I have all the values where the revenue generated was greater than 10,000, but then I have also selected all the sales people who have made or who have generated revenue greater than 12,000. So I can just do a Control Z to see the previous result. Now here I had the values which were greater than 10,000, and the one which we did just now basically highlighted the values which are greater than 12,000. So this is one simple example. Now we can look at some other examples. Say for example, you want to format cells using 3-color scale. So if you look at the values here, I have a 3-color scale mainly in green, yellow, and red. And how do you do this? So for example, I can go in here and I can go to conditional formatting. So I would want to go for color scales, and here you can create different rules. So we can set up a 2-color scale. So we can say format only values that are above and below average. I can format only cells that contain something. I can get the top and bottom value. So these are different ways in which I can have a 3-color based scale. Now what I will do is I will select this, and let me show you the rule which I have. So for example, I can go into manage rules, and if you see here, there are certain rules which have been specified. Now what does that mean? So you would want to specify a 3-grade scale. So for example, if I would want to look at my first rule, it tells me that I'm choosing 3-color scale. I can choose lowest value, percentile, and highest value, and that basically will select the cells based on their values. So what we could have done is I can basically use one of these values. I can delete these rules which I have created. So for example, I have all these rules, but you should always carefully remember that the rules will be applied in the order shown. So for example, if I just delete these rules and then say apply and say okay, my data is back. Now it does not have any highlighting. Now I can go in here, I can say conditional formatting. I could go for color scales, or I could basically go into new rule. So I would want the cells to be using 3-color scale. So let's choose 3-color scale. Now when you say 3-color scale, it says what will be the color of lowest value, and we could choose, might be any one of this. Let's choose red. I can say midpoint is percentile 50, and then the highest value is green, and if that looks good, let's say okay. And now if you see, the lowest values have been highlighted as red, you have mid values, and then you have the positive value. So this is a 3-color scale, and that easily helps me in identifying the data based on the cell values. Now in conditional formatting, what you can also do is you can basically color the cells based on their values. So what we are seeing here is if the revenue generated is greater than average, then that shows in green, and if the revenue generated is lesser than average, that shows in orange. Now how do we do that? So we can basically again manage some rules. So I can basically create a new rule. Now here I can select one of the options which says format only values that are above or below average, and that's the option I would want to select. Now I can select this, and it says format values that are above average. So in our case, we had it in green. So for example, I'll say above average, and then here I can go for a particular color. So you can go for a particular size. So let's go and look into the formatting. So for example, let's choose yellow. Say okay. Now I'm saying wherever the cell values are above average, it would be yellow instead of green. And let's go in here. Let's go and look into manage rules. So this is basically the rule which we are applying. Now we can also add a new rule, and I need to select the values. So for example, I will say here, so we had gone for above, now we'll go for below. We'll go for format, we will choose red, we'll say okay, we'll say now these are basically the rules which we have created, and here it says applies to your data. So right now it has not been applied. So for example, if I select this, and then I could basically choose my area, just hit on enter, and similarly you can go in here and then select your area, hit on enter, and say apply, say okay. And now if you see, I have really chosen bright colors, but then I have said wherever my revenue generated is above average, it should be in yellow, and below average should be in red. So we wanted above average to be in green and below average to be in orange. So that's what we have here, right? So you can always color code your cell values based on some rules which you are setting up. Now similarly, you can also find the top 10 and bottom 10 values, and that's pretty easy. So you can just select this, and then you can go into conditional formatting. You can go for top and bottom values, top 10 items, bottom 10 items, or you can go in for more rules. So you can say format only top or bottom ranked values. So you have top 10. Now you can choose the color, and for example I'll go for blue, and I'll say okay. So now if you see, my top 10 values are blue. Now similarly I can add one more rule. So I can say new rule, and I can say let's go for top or bottom. Let's go for bottom. Let's go for format. Let's say orange. Say okay, and that's it. So now you have your values which are top or bottom 10 values. So you are using conditional formatting where you are basically highlighting your cell values based on different colors, and here easy conditional formatting based on different rules helps us to do that. Now similarly, you can also have the values which is basically showing you how the values are increasing. So what we can do is we can select our columns. Either you could apply this to all the columns. Now here I have applied this only to Jan and April. Now I could apply this for June. So let's say June. So you can go for gradient fill, you can go for solid fill, you can obviously just select the color, and that takes care of the things. You can say, for example, select this, and now this is selected. What I would want to might be format this. So I can go in here, I can go into manage rules. Now that will tell me what rule has been applied in the order. So I can just do a edit rule, and that basically says this is a solid fill, which is color, you have no border, this is basically color is black. Now I can go for something like gradient fill, and I can say okay. And now if I say apply and okay, so this basically is like your first column. So you can use conditional formatting for various use cases, and you can highlight the values. So anyone who would look at the value would automatically notice which are the higher values, which are lower values. Might be here the revenue is getting generated or was getting generated but did not grow beyond a particular value, and so on. Now similarly, you can also go in for different options. Say for example, here we would want to see if the revenue was dropping, or if the revenue decreased, or say for example if the revenue was going up for this particular salesperson. So here we are looking at Carol. So in Jan the revenue generation by sales was very high, then in Feb it was falling down, in March it was kind of stable, then in April it went way below. So we can obviously work on this, wherein we can grade our cell values. So what we can do is we can go in for highlighting the cell values. Now you can go for color scales, you can go for icon sets, and this is where you can choose your different shapes. So you could choose one of these shapes. So for example, I would be interested in looking at the indicators like directional. I could go using this 3 arrows. I can go in for this color, I can choose directional, and then my values are automatically using directional. Now what we can also do is we can then go into manage rules, and that basically tells me what rules have been applied. So for example, the latest one is the icon set, which I have chosen. It shows the selected columns. I can obviously do a edit rule, and then I can choose. So I'm saying the format style is icon sets, I'm not using a data bar. I'm not using color scale. Now here I have chosen the style of icons, and then here you can basically give some values. So you have icon which is green when the value is greater than or equal to 67%. When I say hyphen or minus, it is less than 67. It's way below 33%, then you give this value. So you can obviously edit and easily highlight your cell values based on this icon set. So I can apply this, and that's how I use conditional formatting. So conditional formatting can be very useful if you would want to use icon set, if you want to use your data bars, if you would want to highlight particular values, if you would want to color code based on some calculation, if you would want to use a 3-color or a 2-color scale, or if you would want to just find out values based on some simple calculation. So conditional formatting is used extensively by data analysts or people who are working in business intelligence teams, or people who would want to use Excel to easily identify the data, easily identify the cells which contain particular value, or finding out less significant or more significant cells to then pull out values and carry out your computations, calculations, or analysis. Let's learn one more feature of Excel, and that's basically your data validation. Now, this can be very useful when you would want to work on validating the data which is being fed in the cells. So you could limit it to basically a number between a particular value. You could also add some messages to it if you would want, or you could even circle invalid data or clear validation circles. So data validation really helps us in validating the data which is being fed in to particular fields. Now, it's a feature in Excel which is mainly used to control what a user can fill in a cell. You can decide what type of values must be entered. You can also restrict user to enter only valid data, and if any invalid data is entered, an error message will be displayed. Now that's where you can use your data validations. So let's see how that can be done. So for data validation, let's see some exercises here. So for example, you have a name column and you would want to restrict that the name should accept only 15 characters. Now, how do you do that? So you can basically select the cells, or you can just select a particular cell and then we can later drag the property to other fields. Now here, once the cell is selected, so for example, let's try this out and let's see if that works. So for example, I will say Peter Johnson, okay, and that is basically 5 and 9 and 12 characters. So let's say junior, and if I do this, it says input length is greater than 15. Do you want to continue? If I say yes, right? So basically it is allowing me to add the value here, but then it has basically violated the rule. Now this is giving a message to the user that the username should be entered less than 15 characters. Now how do we do that? So for this, we can basically select the column and then we can search for data tab and get into data validation. So this is where you can create or select different kind of rules. So for example, I can go into data validation, I can go into settings, and I can say the text length, and that should be less than 15. Now this is the maximum I'm giving, and it says apply these changes to all other cells within the same settings. So I can do this, or I can just drag and drop. So I can basically apply this formula, and now you can in fact randomly check in any particular cell, is the rule applied. So it says text length less than 15. So we can basically control data validation in this particular column, and that will allow only 15 characters. It will pop up a message if the user really wants to go beyond the particular limit. Now you also have similarly date of birth. So the restriction is date of birth should be between 10 Jan 1990 to 30 December 1998. So this is what we want to restrict. How do we do that? So we can select the field, we can click on data validation, and if you see here, I have selected date, and then date is between, and then obviously you can give a range, that is 10 Jan date 1990, 12/30, 1998. So that's the start and the end filter which has been applied. And once this is done, you can also check your input messages, which says when cell is selected, show this input message, enter a valid date. So if you see here on the left, there is a pop-up which is coming up which says enter a valid date. Now I can also say when user enters invalid data, show this error alert. So I can say stop. I can say invalid entered, and this is how I have set a rule. So for example, if I just do something like this, and that says invalid date entered, I can do a retry. It will take me back here, but unless and until I do not give the right format, the date will not be accepted. And again, the same thing applies to all the cells. Similarly, email. So we are saying the email should have @ present in the value provided. Now for this, we can use a formula, and we can select, well, I would want to apply this rule to all these rows starting from C2 to C14. So let's get into data validation. Let's look in settings, and here we are choosing custom. Now within custom, I'm choosing what is the formula. So I'm saying is number, and then I'm saying find @ for the rows C2 to C14. So the only thing we are concerned about here is the value should have an email icon. You can input a particular message. You can say what has to be done for error alert. So for example, we can basically go in here and we can say invalid email. That's the title I'm giving. And we can say email should contain @. So if I do this and if I say OK, now you can test it. So you can say A, B, C, D, and that says email should contain @, and basically that will not allow me to add the values. So now you have the field called salary. It says salary should be greater than 50,000. Now we can limit the values by choosing a whole number. So for example, for salary, I can go into data validation. I can go into settings. So here I can say something like decimal, or I can go for whole number. So both of the things are fine. It depends on what kind of values get into this particular field. So if I say whole number, and if I say it has to be greater than 50,000, so I'm saying the minimum is 50,000. Or I could have given a decimal, and then I can say greater than, less than, equal, or anything, or even between. So I can select greater than, and then I can just say OK. Now for rank, the rule is rank should be between 100 and 200. So again, we can use a whole number. So ranks will generally not be decimal. So this would be whole number. Salary can be a whole number, or it could be decimals. So we have chosen decimal here. And in rank, if you click on data validation, I have chosen whole number. I've set data between 100 and 200. Input message, nothing. Error alert, nothing. But that depends. I can give this. So this is how you can just do a simple data validation and control the values which land in the cell. Okay, so now let's also understand how we can restrict the values in a particular cell, which might be based on a list of items. Now, for example, here, if you see, I have two columns. So one column basically has the values of city names, and then you have places within that particular city. So if I would want to implement a data validation based on this, so for example, if you see here city, and that basically shows me only the 4 values which can be entered. And if I go to place, then it tells me for Maharashtra I can only enter Pune, Mumbai, Nasik. Now how do I do this? So say for example you take an empty field and you want to restrict the values of city names. So I could select data validation. I could basically select list, and then it tells me you need to enter the list values, that is the source. So you click here, and then I can just select these fields. Now if I do this and if I say okay, it has implemented a data validation, but if you look into this, it will show me the same thing, but then it shows me some empty cells which did not have any value. So this is fine, but it would be better if we do it in a different way. So I can select this, and I've already given my city names here. So I can just do a data validation, and here in the source, let me get rid of this. Now I can just have my cursor here. I can select these values, and then if I say OK, so now if you see, my city names have been restricted to these values. And that's how you can implement your data validation. So I have this data validation here, but I will get rid of this one by just doing a Control Z. Now I'll come here and say, for example, I would want to implement the same data validation. Now the easiest way would be in doing this for all my 4 cities. Now if you see here, I have data validation. I could choose Bangalore. And if you come and check here, there is no data validation, but we have implemented data validation here. Now, how is that done? So I could select this, or for example, I can go in here. I can select data validation. I can select list, and then here in the source, I will say for Bangalore, the values should be these. And then if I basically say OK, now if we see, these are the values which are fed into Bangalore. So we could do this, or like what we have done here. So if you can check the data validation rule, I have used list, and then I have said indirect F2. So basically I'm giving in a formula which relates to the value which is in for the city Maharashtra. So we could do this, or in a simpler way we could do this and then just drag and drop here. So we could check for Maharashtra what are the values. Let's choose a different city. So for example, Kolkata, and here I will choose. Now since we did a drag and drop, it has basically taken the values of Bangalore, so that's not right. So we select this, we go into data validation, and here I can either feed in the values, that is such as Bangalore. I could basically say something like this, Kolkata, and I could say OK. So now if you see, it shows me the places in Kolkata. Now here we have, let's choose a different city. So for example, let's go for Delhi, and here I can go to data validation and I can just say Delhi. So this is an easier way of doing it. Or if you remember the formula, then what you can do is you can just give in indirect and then basically give the value of the cell for which you would want to keep in the values. So this is how you can do list validation. So you can provide a list of values, and then you can restrict the values in a cell which should be belonging to a particular list. So this is how you do a simple data validation by restricting the data in the form of a list.
Excel is a really powerful tool for data analytics and reporting, and pivot tables are one of the features that Excel offers for creating tabular reports to summarize our data. Let's begin by understanding what is a pivot table. A pivot table is a tool that summarizes and reorganizes selected columns and rows of data in a spreadsheet to obtain a desired report. It does not actually change the spreadsheet data, it simply pivots or turns the data to view it in different perspectives. Pivot tables are especially useful with large amounts of data that would be time consuming to calculate manually. Now, let's understand the different components of a pivot table. So there are four main components. First we have rows. When a field is chosen for the row area, it populates as the first column in the pivot table. Similar to the columns, all row labels are unique values and duplicates are removed. Columns is the second component. When a field is chosen for the column area, only the unique values of the field are listed across the top. Then we have values. Each value is kept in a pivot table cell and displays the summarized information. The most common values are sum, average, minimum, and maximum. Finally, we have filters. Filters apply a calculation or restriction to the entire table. So let's jump over to Microsoft Excel and let me show you the dataset that we will use in this demo. So with India being ready for its 16th census in 2021, that is next year, it is a good time for us to analyze India's last census data from 2011 and see where different states and cities across India stood in terms of population, literacy, and other socio-economic factors. We will analyze this data by creating different pivot tables in Excel and explore some of its features. So let's begin. First, I'll show you one of the features that Excel offers us. So suppose I click on any cell and hit Ctrl plus Q, you can see our entire table is selected, and at the right bottom there's an option of quick analysis. Now you can see by default Excel has prompted certain features such as formatting, we have charts, totals, and there's one more called tables. Now Excel by default has created some pivot tables for us. Now the first one you see is sum of district code by state names. Next we have sum of sex ratio by state name. Then we have sum of child sex ratio, sum of male graduates, and sum of female graduates by state name, and there are others. Before creating our pivot table, so let's have a final look at our data set. So first column you see is the city column. So there are different cities from different parts of India. Then we have the state code, we have the state name, district code, we have the total population followed by male and female population. Next you can see we have the total literates from each city. Then we have the male and female literates. Next we have the sex ratio. Then we have the child sex ratio. Next we have total number of graduates. And finally you can see we have male and female graduates. So using this table, we'll create several pivot tables. Now first of all, let's create a pivot table to find the total population for each state and sort it in descending order. So you can see here we have the problem statement. So our first pivot table will have the total population for each of the states in descending order. So to create a pivot table, you can click any cell in your data, go to the Insert tab, and here left you can see we have the option to create a pivot table. So let me select pivot table. Now my range is already selected, the entire table, and here I'll choose existing worksheet because I want to place my pivot table in the same worksheet, and I'll give my location, I'll point to cell Q5. Now let me click OK. You can see the pivot table fields appears here on the right. Now since we want to find the total population for each state, so what I'll do is I'll drag my state name onto rows. So here in our pivot table you can see we have the different state names listed. Now we want the total population for each of these states. So in the field list I'll search for total population, which is this one, and drag it under values. You can see we have a sum of total population for each of these states. By default, Excel will sum any numeric column. You can always change it to average, minimum, maximum, anything you want. Now we want to sort this column in descending order. So I right click, go to sort option and choose Z to A, that is largest to smallest. You can see here in 2011 Maharashtra had the highest number of population, or the total population in Maharashtra was the highest. Then it was Uttar Pradesh, we had Andhra Pradesh, and if I come down we have Nagaland and Andaman and Nicobar Islands towards the end. So this is a simple pivot table that we created. Now the next problem we have is we want to find the total sum of literates in each city belonging to a certain state. So let's see how to do it. I'll click on any cell, go to insert, and here I can click on pivot table. My range is selected. I'll choose existing worksheet and give my location, which is Q5. I click on OK. Now here we want to find the total sum of literates. So what I'll do is, first let me drag total literates column to values. You have the total sum of literates from all the states. Next, I want to see the sum of total literates based on states and cities. So let me first drag state name onto rows, and then we'll drag city onto rows. You can see here we have our pivot table ready. To the left of the pivot table, you can see we have the state names and the cities per state, and on the right you can see the total number of literates from each city. If I scroll down, we have Assam, then you can see we have Bihar, and if I keep scrolling, we have all the states: Haryana, Himachal Pradesh, there's Jammu and Kashmir, which has now become a union territory. We have Jharkhand, Karnataka, and other states as well. Moving on. Okay, so the next thing we want to see is what is the average sex ratio and the child sex ratio for each state. With that, we also want to find the states that had the highest and lowest sex ratio in 2011. So let's create a pivot table for this. I'll click on any cell, go to insert, choose pivot table, click on existing worksheet. I'll select cell Q5 and click on OK. Now, since we want the average sex ratio and the child sex ratio, so first I'll drag those columns. Either you can manually scroll and drag it, or here you have the option to search for it. So if I look for child, you can see we have the same column listed. You can just drag it from there. Let me delete this. And I also want the sex ratio, so I'll place it on top of child sex ratio. Next, we want to see it based on different states. So what I'll do is I'll take state name and put it under rows. So here you can see we have our pivot table ready. On the left you can see we have the different state names listed, and on the right we have the values. Now we want to find the average. Now by default Excel will sum the numeric columns. You can see it tells you sum of sex ratio and child sex ratio. So what you can do, you can click on this drop down and go to value field settings, and here summarize values by, you can choose average. You can see the custom name, it says average of sex ratio. Click on OK. Our entire column is now giving us the average sex ratio. Similarly for this column, let me convert it into average. I'll again click on the drop down, go to value field settings, click on average and click OK. And you can see here we have the average of child sex ratio for each of the states. Now the next question says which states had the highest and lowest sex ratio. So we'll consider this column. So we'll sort it in any order you want. You can do it either ascending or descending. Let me sort it in descending order. You can see we have our column sorted now. So in 2011 Kerala had the highest sex ratio, and if I scroll down to the bottom you can see Himachal Pradesh had the lowest, which is around 818. Up next, let's explore one more feature of pivot table. So suppose you want to see the top or bottom few rows of a pivot table, you can do that as well. So here we have a question at hand. We want to find the top 3 cities with the highest number of female graduates. So let's see from the entire pivot table how we can filter the top 3 cities. So I'll go to Insert, click on the pivot table option, go to existing worksheet, click on Q5 and hit OK. Now since we want to find the top 3 cities, I'll drag city column onto rows, and then we want the female graduates. So in the search bar I'll look for female and I'll choose this column, that is female graduates, and drag it here onto values. So I have the sum of female graduates for each of the cities. Now since we want to find the highest number of female graduates in the top 3 cities, so let me first sort this column. I'll sort it in descending order. Now we have it sorted. Now from this you can say that Delhi, Greater Mumbai and Bangalore are the top 3 cities, but it's displaying all the cities for us. So let's filter only the top 3. So what you can do is right click and go to filter. Under filter you have the option of top 10. I'll select this. Here I only want the top 3. So either you can go down like this, or you can directly type 3. Your column is already selected. Let me just click on OK. There you go. We have the required pivot table ready, and it only displays us the top 3 cities with the highest number of female graduates. Now the next thing we want to see is how to use a slicer in a pivot table. So we have a question here. What's the total population for all the cities in Rajasthan and Karnataka? So let's create a pivot table for this and see how you can use a slicer to filter the table. Click on existing. I'll click on a location, this time Q6. Click OK. Now since I want the total population, so I'll drag total population onto values, and then I'll select the city onto rows and then the state name also. I'll place it on top of city. So you have in the pivot table all the states and their cities, and on the right you can see the total population for each of these cities. But our question is, we want to find only for Rajasthan and Karnataka. Now for that, what you can do is go to Insert and create a slicer. Either you can create from this option, or you can go to Pivot Table Analyze option, and here you have the option to create or insert a slicer. I'll click on this, and since we want to slice the table based on state, that is Rajasthan and Karnataka, I'll choose state name as my slicer field. You can see this is my slicer here. Now you only want the data for Rajasthan and Karnataka, so I'll search for these two. So here we have Karnataka, so let me select Karnataka first, and I also want for Rajasthan, so let me select Rajasthan also. You can see in our pivot table we only have data for Rajasthan and Karnataka. So this pivot table shows you different cities from Karnataka and the total sum of population from each of the cities, and similarly we also have for Rajasthan. Moving ahead, now we will see another very interesting feature of pivot, that is how you can create percentage contribution of a table. For example, we have a question here. What's the percentage contribution of male and female literates from each state? Now we want to see in terms of percentage and not as sum or average. Let's do that. I'll create my pivot table, click on existing, and I'll select an empty cell. Okay. Now here, since we want to find the percentage contribution of male and female literates, so first I'll drag male literates onto values, followed by female literates onto values. By default it has summed up the male literates and female literates value. And also I want to drag state column to rows. So here you can see the sum of male literates and female literates per state. I want to convert this as percentage contribution. So what we can do is I'll select any cell and I'll right click and I'll go to show value as, and here I have the option to select percentage of grand total. So I'll select this. You can see we have the percentage contribution of male literates to the total. Now if I sort this, you will get to know which state contributed or has the highest percentage contribution. So we have Maharashtra for male literates, then we had Uttar Pradesh in 2011. If I come down, we had Meghalaya, Nagaland and Andaman and Nicobar Islands as those states which had little or minimal contribution to male literates. Similarly, let's do it for female literates. I'll go to show value as and select percentage of grand total. So you can see here also Maharashtra, Uttar Pradesh, then Gujarat and all had the highest percentage contribution to female literates. So this is another good feature to convert your data and see it in terms of percentage. Now moving ahead, let's say we want to find the bottom 3 cities from each state that had the lowest female graduates. We can do that as well. I'll go to insert, click on pivot, go to existing worksheet, select an empty worksheet and click on OK. Now since I want to see based on states as well as cities, so let me drag the state name first onto rows and let's drag the city column onto rows. Next we want female graduates, so let me look for female graduates in the field list. I'll drag it onto values. Now we have the list of states and their respective cities, and to the right of the pivot table you can see the sum of female graduates from each city. Now first I'll sort this column. I'll right click, go to sort and click on shortest to largest. Now we have sorted our female graduates from shortest or smallest to largest. Now since I want to find the bottom 3 cities from each state, I'll come to this cell, right click, go to filter and select top 10. Now I'll replace top 10 with bottom and I want the bottom 3 cities from each state. I have my column selected, that is sum of female graduates. If I click on OK, you can see here some of the states don't have 3 cities. So you can see Andaman and Nicobar Islands has only 1 city, that is Port Blair, while the remaining you can find the bottom 3 cities with the lowest number of female graduates. So Andhra Pradesh had these 3, in Assam we had Nagaon, then there was Dibrugarh and Silchar. Similarly, if I come down in Haryana we have Palwal, Kathal and Zind. If I come further, here you can see for Karnataka there's Gangavati, there's Rani Benur and there's Kolar. Similarly you can see for Kerala as well. Now moving ahead, now in the next example I'll tell you how you can create a calculated field or a calculated column in Excel with the help of a pivot table. So in a pivot table you can create or use custom formulas to create calculated fields or items. Calculated fields are formulas that can refer to other fields in the pivot table. Calculated fields appear with other value fields in the pivot table. Like other value fields, a calculated field's name may precede with sum of followed by the field name. So here we have a sales table that has columns like the items, which has different fruits and vegetables, and those have been categorized as fruits and vegetables. We have the price per kg, and this is in terms of rupees, and we have the quantity that was sold. Now let's see, if you want to find the sales for each item in the table, you can create a calculated field. So your sales column is going to be the product of price per kg and quantity. So let me show you how you can do that with the help of a pivot table. I'll create a pivot table first. Click on an empty cell, hit OK. Now, if you see on the top, under pivot table analyze and under calculations, we have the option fields, items and sets. If I click on this drop down, I get the option to create a calculated field or insert a calculated field. I click on this. I'll give my field name as sales and I'll select my formula. I'll first click on price per kg and hit insert field. I'll give a space, hit shift 8 to give the product symbol, and then I'll double click on quantity. Now this is my formula for sales, that is price per kg multiplied by quantity. I'll click on add and I click on OK. If you see here, there's a calculated field that is present in the pivot table fields, which is sales, but it did not add it to our original table. Our original table is the same, but here we have added a calculated field which is present only in the pivot table list. Now we can use this. It has already taken it under values. Now let's say I want to find the sum of sales for each item under each category. You can see it here. We have our category fruit and we have our category vegetable, and under that we have different items like apple, apricot, banana. Similarly, in vegetables we have broccoli, the carrots, corn, eggplant and others. So this is how you can create a calculated field in a pivot table. Now there's one more good feature that Excel offers us in pivot table is to create a pivot chart. So you can use your pivot table and create different charts. So I'll show you how to do that. If I go to insert, here I have the option of recommended charts. If I click on this, Excel gives me some default charts which you can use. Let's say I'll select this. Let me drag it a bit to the right. Here you can see I'll close this pivot field list. This is a nice bar chart that Excel has created. This is called a pivot chart. Now here you can see the category fruits and vegetables and the different fruits and vegetables or the items. In the y-axis you can see the total sales. If you see from the graph, guava made the highest amount of sales. Now if I sort this, let's sort this first. You can see it here, fruit guava made the highest amount of sales. Now since I sorted and changed my pivot table, the pivot chart also automatically gets updated. Similarly, there are other charts also that you can create. Let's go to the insert tab and let's click on recommended charts again. Let's look for a pie chart. So this is a pie chart that you can create. Let me click on OK. So here is our pie chart, and each pie represents a certain item, and the pie that has the highest area represents it had the highest amount of sales. In this case you can see it is guava, and similarly we have other items as well. This is fruit banana, that's corn, and we have spinach and others. Let's explore a few other charts. So first I'll click on my pivot table, go to insert, and under recommended charts let's now select a line chart. If I hit OK, move it to the right. So this is a line chart. You can see it starts from guava, which had the highest amount of sales, then it drops, and in the x-axis you can see the different items. Similarly, when it starts with the vegetables, broccoli made the highest amount of sales with 2,800 rupees, and our lowest was eggplant at 900 rupees. For fruits, papaya sold the least at 700 rupees. Let's take another chart. I'll go to insert. Under recommended charts, let's see, this time we'll see a bar chart. Now this is a horizontal bar chart and not a vertical one. We just saw a vertical column chart like this. This is an horizontal bar chart. Now you can always increase and decrease the size of these charts. Let's explore a last chart. Let's take the area chart for now. So this is an area chart. Again, it looks similar to the line chart. It starts with guava, which had the highest amount of sales. Similarly, papaya under fruits had the lowest amount of sales. Under vegetables it was broccoli, and finally eggplant made the lowest amount of sales under vegetable. Now let's go to our first sheet and summarize what we have done in this demo for pivot tables in Excel. So we had our data. This is 2011 census data from India. We had the different cities, the state names, and we had the total population, total literates, female literates, male literates. We had the sex ratio, total graduates, and other information. So we began by understanding how to create a simple pivot table where we calculated the total population for each state and sorted it in descending order. We found that Maharashtra, Uttar Pradesh had the total population in 2011. Then we saw another pivot table where we calculated the total sum of literates in each city belonging to a certain state. So you can see we had the different state names and the cities under each state. Then we saw another feature where you could calculate the average of a certain numerical column. So here we calculated the average sex ratio and the child sex ratio for each state and found out which one had the highest and lowest sex ratio. After that, we saw how you could find or filter tables. We saw how to find the top 3 cities with the highest number of female graduates. We found out that Delhi, Greater Mumbai and Bangalore were the top cities with highest number of female graduates. Next, we saw how to use slicer in a pivot table. So we sliced our table based on Rajasthan and Karnataka state and saw the total population for all the cities in Rajasthan and Karnataka. In the next sheet, we explored another feature that was to find the percentage contribution of male and female literates from each state. Then here we saw how to find out the bottom 3 cities for each state having lowest female graduates. Now one thing marked that some of the states did not have 3 cities. For example, Andaman had only 1 city, that was Port Blair, but the others we found out the bottom 3 cities that had the lowest female graduates. Finally, we looked at how to create a calculated field in a pivot table. So we saw how to create a calculated field called sales, and then we explored how to create different charts and graphs. So this was an area chart that we saw. There's a column chart. We also saw or looked at a bar chart that was a horizontal bar chart. Similarly, we saw how to create a pie chart as well.
In this video, we'll be creating 2 dashboards using a sample sales dataset. So if you want to get the data and the dashboard file that we'll be creating in this demo, then please put your email IDs in the comment section of the video. Our team will share the files via email. Now, let's begin by understanding what is a dashboard in Excel. A dashboard is a visual interface that provides an overview of key measures relevant to a particular objective with the help of charts and graphs. Dashboard reports allow managers to get a high-level overview of the business and help them make quick decisions. There are different types of dashboards such as strategic dashboards, analytical dashboards, and operational dashboards. An advantage of dashboards is the quick detection of outliers and correlations. With comprehensive data visualization, it is time-saving as compared to running multiple reports. With this understanding, let's jump into our demo. For creating our dashboards, we'll be using a sample sales dataset. Let me show you the dataset first. So here is the sales dataset that we'll be using for our demo. So this dataset was actually generated using a simulator and is completely random. It was not validated, though we have applied certain transformations to the data using Power Query features. So this data, as you can see, has 1000 rows. So using the simulator, we had generated 1000 rows of data. Similarly, if I go on top, you can see this dataset has 17 columns. Now let me give you a brief about each of the columns. So first we have the region column. So we have Middle East and North Africa, there's North America, Asia, Sub-Saharan Africa, and others. Similarly, we have the country names from which the item was ordered. The third column is the item type, so we have different items: cosmetics, vegetables, there's baby food, cereal, fruits, etc. Then we have the representative's name, or you can say this as the customer name who ordered the product. Then we have a sales channel column, so there are basically two channels, whether the item was sold offline or online. Next we have the order priority column. Now here C stands for critical, then we have H, which is for high priority orders, then we have M for medium priority orders, and finally we have L, which is for low priority orders. You can see the order date column, then we have the order ID, the ship date. Next we have units sold, which is basically the total number of units sold for each item. Then we have the unit price column. This is the price at which each product was sold. Then we have the unit cost column, which is basically the production cost for each of the items. Next we have the total revenue. The total revenue is actually the product of units sold and unit price. Then we have the total cost column. Now the total cost column is actually the product of units sold and the unit cost. Similarly, we have the total profit column. So total profit is the difference between total revenue and the total cost. And finally, we have created two more columns, that is order year and then we have order month. Now these two columns were actually generated using the Power Query features. So we used the order date column, which is this column, and extracted order year and order month. So first, we are going to create a revenue dashboard where we'll focus on generating reports for revenue by order year, revenue by year and region, revenue by order priority, and much more. We'll create separate pivot tables and pivot charts and format them to make them look more interesting and presentable. We'll add slices and timeline to our dashboards in order to filter it based on specific fields. Now let's create our first report to see the total revenue generated each year. So we need to create a pivot table for this. I'll click on a cell in my dataset and then I'll go to the Insert tab. Here we have the option to select the pivot table. I click on this. You can see my table range is selected. Next, I want to place my pivot table in a new worksheet, and let's just click on OK. There you go. So we have a new sheet where I can place my pivot table. So first, I need to find the total revenue generated by each year. So what I'll do is, I'll drag my order year column under rows, and then I'll select the total revenue column under values. You can see I have my pivot chart ready. Now if you want, you can sort this. So from the data, you can see we have order year from 2010 to 2017. Now based on this data, let's create our pivot chart. So I'll click on any cell, go to Insert, and here you have the option to select recommended charts. I click on this. Now actually I want a line chart, so I'll click on line here and select OK. There you go. So we have successfully created our first pivot chart. Now let me show you how you can format this chart to make it more readable. So first, let me delete these. So I'll right click and select hide all field buttons on the chart. So this will delete the buttons present on the chart. Now let me go ahead and edit the chart title. So the title I want is total revenue. I'll type it down by year. Alright. Next, let's do a few more transformations. So if I click on this plus sign, which is actually for chart elements, we have some options like to add axis, axis titles, chart title, data labels, this grid lines, legend, and others. Okay, so let's remove the legend now. You can see the total legend is gone. Now let me add axis titles. So we'll label our x-axis and y-axis. So here under x-axis, I can write it as year. Similarly, on the y-axis, I'll put revenue. Okay, now you can move a bit. Alright, now let me select this chart style option and go to colors first. Here I'll select yellow color. Okay, and then let me go back to style. Let's select a new style from this list. I want this style. Okay, now you can also add data labels. So I'll just click on data labels. You can see we have the revenue for each of the years. Now this is not readable at all, so we'll format this a bit. If I click on this arrow, here I have more options. If I scroll down, you can see we have something called as number here. I'll expand this, and under category I'll select custom. Now here we'll give a format code which is a bit different. So this is actually a kind of a formula. So I'll write if my revenue value is greater than, let's say, 9,99,000. Let me make sure there are 6 nines here. So 1, 2, 3, 4, 5 and 6. Okay, we are good to go. I'll close the bracket. I'll give a hash, give 2 commas. So if the revenue is greater than 9,99,000, I'll put it in the format of millions. So within double quotes I'll write M. I'll give a semicolon followed by another hash, and if the value is less than the desired number, it should be 0 million. Let me click on add. Alright, you can see how nicely we have formatted our data, and you see here we have added the new format which is in millions. Alright, now if you want, you can go ahead and adjust the boxes. Let me move this a bit up. I'll delete this. Now if you notice this line chart, you can make a few conclusions. For example, if you see here in 2010, the total revenue generated was nearly 175 million. Now this came down to 150 million in 2011. Then the revenue constantly grew from 2011 till 2014. It reached 195 million. And after 2014, it again came down to 180 million, and the revenue dropped significantly between 2016 and 2017. In 2017, the revenue was just 96 million. Now before moving ahead to my next chart, let me just rename this sheet. So I'll write it as revenue by year. Alright. Now let's analyze the revenue generated each year in different regions. So for this, we'll create another pivot table. Let me close this. I'll click on any cell, go to insert and select pivot table. I'll just click OK so that my pivot table is placed on a new sheet. Alright. Now this time we want the revenue by each year and region. So first of all, let's drag region to columns. Then let's drag the order year column under rows, and then I'll select total revenue onto values. So here you can see we have the pivot table ready. So for 2010, you can see in Asia, this was the revenue generated. Similarly, if you see for 2013, this was the total revenue generated in Europe, and we have for other years as well. Now let's create a line chart based on this pivot table. So I'll select any cell in the pivot table. I'll go to insert and I'll click on recommended charts. From this list, I'll select my line chart and click on OK. There you go. So we have our next pivot chart ready. So on the right you see the different regions that are present in different colors. Let me just expand it so that you can see all the regions we have. So in total we have 7 regions, and each of the regions have been represented in different colors. So if you notice this graph, for the sub-Saharan African region in 2012, sub-Saharan Africa made the highest amount of sales. Now from the sample data you can also tell that the revenue for North America has been significantly low compared to other regions. Similarly, if you see for Europe, this was the revenue trend between 2010 and 2017. So if you see here in 2011 the sales were at this level, then it significantly dropped in 2012, then in 2013 there was a huge spike, and then again came down in 2015, and so on. So you can make your own conclusions by looking at these line charts. Now let's format this chart. So first of all, let's delete the field buttons present on the chart, and we'll also delete the legend. Alright, now let me just reduce the size of the chart. Next, we'll add a chart title. So we'll give the title as revenue by year and region. Okay. You can also format the y-axis in terms of millions. So I'll right click on this axis and I'll select format axis. I'll scroll down and here we have the number drop down. Let me scroll again. Under category I'll select custom and we'll use this format that we created for our previous chart. There you go. You can see our axis labels have been changed in terms of millions now. So let's close this and let me save it. Now you can reduce the font size or increase the font size. Let me just show you. Suppose you want to increase the font size of the chart title, so you just select it, and from here you can either reduce or you can increase. You can see now it's 12. If you want, you can make it 16. Similarly, you can also edit the axis labels also. By selecting the chart title, you can also move it to left or right, or you can place it in the center as well. For the time being, let me just keep it to the left. Alright. Now we'll see the revenue and total cost by each region, and we'll create a combo chart for this. So let me show you how to do it. I'll go to my data sheet. I have my cell selected. I'll go to insert and click on pivot table. Let me just click on OK. Alright. So for this, I'll select my region onto rows, and then I'll have two columns under values. The first one is going to be total revenue, and the next column will be the total cost column. Alright. So here we have the pivot table ready. Now based on this pivot table, let's create our pivot chart. So I'll go to recommended charts, and if you see below at the bottom we have combo chart. So this is the preview of the combo chart. Alright. Now let me just click on OK. There you go. So we have a nice combo chart ready here. Now the way to look at it is, the bars represent the total revenue, which is this column. Now the line represents the total cost. So let me go ahead and edit this chart a bit. So first of all, let's delete the field buttons. Alright. And let's also remove the legend from here. Next, we'll add data labels. So I'll click on data labels here. Okay. So these are the data labels for the bars or the revenue column. Now let's format the data labels in terms of millions. So I'll click on this arrow, go to more options. If I scroll down, I have number. From here I'll select custom and I'll choose my type, that is in millions. Alright, so you can see we have formatted our data. Next thing, we'll add a chart title. So here I'll write as revenue by region. It's actually revenue and total cost by region. Before moving ahead, let me rename the sheets as well. I'll write revenue and total cost. Similarly, sheet 3 also I'm going to rename it as revenue by year and region. So this makes your sheet more readable. Alright, now moving ahead, next we are interested to get the revenue generated by order priority, and for this we are going to create a pie chart. So let's go to the data sheet and create our pivot table first. I click on OK. Now I'll select order priority under rows, and under values I'll select total revenue. So this is a very simple pivot table. So you have your order priority. So C is for critical, H is for high, L is for low, and M is for medium. Now based on this, let's create a pie chart. So I'll go to recommended charts, and here you have pie chart. I want to select this 3D type of pie chart and I'll click on OK. Alright, so we have our pie chart ready. Let me just resize it, and from here I'll remove the field buttons, and I also don't need the legend, so I'll delete this as well. Alright, now let's give a chart title. So this is going to be revenue by order priority. Now let's add our data labels. I'll check this option. Okay, now let's again format this in terms of millions. So here I'll click on the last option, I'll go to numbers. Under category I'll select custom, and my type is going to be in terms of millions. There you go. Let me close this. I'll just move this to the center. Alright, now if you want, you can change the color of the text as well. So let's have it in white color and see how it looks. Okay, so this looks pretty decent. Cool. Now moving to our next report. So this time we are going to find the total revenue by countries. So we have multiple countries present in our data set. We want to visualize the revenue generated in each country. So for this we are going to create a horizontal bar chart. So let me show you how to do it. But before moving ahead, let me just rename this sheet. So I'll write revenue by, I'll just put OP, which stands for order priority. Alright, now let's create our horizontal bar chart. I'll go to insert, click on pivot table and select OK. So I want my revenue based on different countries. So I'll select country and put it under rows, and then I'll choose total revenue and place it under values. So here you have the different country names. We have Afghanistan, there's Albania. Let me scroll down. You have Bangladesh. There are a number of countries. You have Czech Republic, there's Estonia, France, Gabon. Similarly, if you scroll down, we have India, there's Jamaica, Italy, and all the way to the bottom if you go, we have New Zealand, there's Netherlands, Philippines, Portugal. We also have Singapore, lots and lots of countries. We have the UAE, United States of America, Zimbabwe, and others. Alright, let me go up. So based on this pivot table, let's create our pivot chart. So I'll go to Insert and select Recommended Charts. From here, I'm going to select the column chart. You can see the preview here, and let me click on OK. Alright, so here you can see the different country names at the bottom and the revenue for each of the countries. Let's go ahead and edit this chart. So first of all, I'll delete the field buttons. Okay, and let me also remove the legend. Here I'll write revenue by countries. This is going to be my chart title. Okay, let's format this chart a little more. So I'll click on this option and we'll select a new style. Let's say I'll select style 6. Okay, and let me now go under colors and we'll select the color of the bars. So let's choose this color. Okay, so you have a horizontal column chart ready, and at the bottom you can see the different country names and we have the revenue. Cool. Now let me go ahead and rename this sheet. So I'll write revenue by countries and hit enter. Okay, and finally we'll create another report which is going to be part of our revenue dashboard, and this is revenue by items. So we'll visualize our revenue for different items present in the table. So if you see this, we have cosmetics, vegetables, cereal, fruits, there's clothes, snacks, households, and other products as well. So let's check the revenue for each of these items. So we'll continue the same drill. I'll create my pivot table on a new worksheet, and this time I'm going to drag item type under rows and we'll have the total revenue under values. So here on the left of the table you can see we have the different item names and then we have the total revenue. So let me just sort this total revenue from largest to smallest. So you can see here office supplies made the highest amount of revenue, followed by household, then cosmetics, and fruits made the lowest amount of revenue. I'll click on this, go to insert and select recommended charts. This time I'm going to create a bar chart. So this is how my bar chart is going to look like. I'll select OK. Alright, now let's format this chart a bit. I'll delete the field buttons and I'll delete the legend as well. And let's edit the chart title. So this is going to be revenue by items. Cool. We also want to change the color of the bars. So I've selected all the bars. I'll go to my home tab and here let's say I want to select green color. Alright, I've edited my chart a bit. Now let's make it 14 and I'll remove the bold. Okay, here if you want you can change the font also. Let's keep it in blue color. Alright, finally let's rename this sheet. So I'll write revenue by items. Cool. Finally, now it's time for us to merge all the charts that we have created to our dashboard. So let me show you how you can create the dashboard. I'll create a new sheet, and first thing I'm going to do is I'll click on the View tab and uncheck grid lines, so this will remove the grid lines present in the worksheet. Next, I'm going to insert an image, so we'll have a background image on our dashboard. So the way to do is I'll go to the Insert tab, and under Illustrations I have the option to select Pictures or Insert Pictures. So I'm going to insert picture present on the device, that is my computer. I'll go to Desktop, and here I have a folder called Excel Dashboard Files, and I'll select this dashboard background and hit Insert. So this is going to insert an image. Now let me just drag this image so it covers a fair enough portion. So I'll hit Shift and I'll drag it. Alright. So you can see I have successfully added a background image. If you want, you can still expand this background image a bit to the right. Cool. Now the next thing is going to be the title of the dashboard. So I'll click on Insert, and here I have the option to select a text box. So I'll click on a text box, and I'm going to place a text box in the middle, and I'm going to name this text box as Excel Revenue Dashboard. On sales. I'll centerline it. Let's do some more formatting. So I'll select this text box. On the top you can see shape format. Here I'm going to expand this shape fill, and I'll select no fill. So my text box is transparent now, and I'll also remove the outline. Alright. Now let me just double click on the title of my dashboard, and I'm going to select a font. You can select whichever font you want. Let me stick to Britannica Bold, and I'll increase the size to, let's say, 30. Alright, I'll just drag the text box. I'll make the text as white instead of black. Alright, so we have our title of the dashboard ready. Now if you want, you can also insert some icons to this dashboard. So I'll go to Insert, and I'll click on Illustrations again and select Pictures. I'm going to add this two pictures, which is of a store and a cart, to make it look visually appealing. So I'll place the icons here, and similarly let me just copy it, and I'll place the cart and the store to the right as well. Alright. Next, the idea is to bring in all the charts that we have created and place it on the dashboard. So let me copy each of the charts and place it on the dashboard. So I'll hit Ctrl V to paste it, and we'll resize this as well. Alright. Similarly, let me bring in all the other charts as well. Alright, so now you can see I have added all my charts and graphs to this dashboard. So you can see here we have our line charts, our column charts, the combo charts, the pie chart, and others. Now let me go ahead and format these charts a little more. So you can see this looks a bit cluttered. So let's adjust the labels. Let me bring this down. Similarly, I'll bring 190 million a little below. Alright, this looks fine now. One more thing we are going to do is we'll remove the white background from each of the charts and make it transparent. So let me show you how to do it. So I'll select this chart, then I'll right click and go to Format Chart area. Here on the right you see we have an option called No Fill. So if I select No Fill, you can see the white background is gone now. Similarly, let me also remove the grid lines. So I'll select the grid lines and hit delete. So I've also removed the grid lines from here. Now let's also remove the white outline that we have. So I'll select this chart, go to Format, and here I'll go to Shape Outline and I'll select No Outline. You see this? So we have our total revenue by year, which is a line chart, and this is completely transparent now. Now what I'm going to do is I'll place this chart over a box. So I'll go to Insert, and in Insert we have the option to create a shape. So I'll click on Illustrations, and here I'll choose a shape, and let me select a rectangle. So I'll just create a rectangle here. Alright, and now what I'll do is I'll select this and bring this to front. I'll right click and choose Bring to Front, and I'll place this shape below it. Alright, now the next thing is to edit the shape. So first I'll change the color of this box. So let me select this blue color, and let me increase the transparency. So I'll right click and go to Format Shape. Here I'll increase the transparency. Let's keep it to 25%, or let's say 20%. Alright, next thing, we'll just convert all the font to white color, including the axis labels, the chart title. We'll also convert all the axis labels to white color so it looks better. Now we'll just adjust our chart over here. Next thing, let's just remove the outline. So I'll go to Shape Outline and I'll select No Outline. You see, we have now formatted our chart. Let's just pull this a little up. Alright, now we'll add this blue background to all the other charts. So we'll first add the background, make it transparent, and then we'll convert the font text to white color to make it more readable and visible. So for the time being, I'll just pause the video and come back again. Alright, so now you can see on your screens we have nicely formatted our dashboard. So I've added a few logos for each of the charts. You can see the logos here. So for revenue by countries, we have a globe. Then if you see here, this is kind of a map or a location. Similarly, we have all formatted the color of the bars. Then we have also formatted the labels in terms of millions. If you look on the y-axis, even the revenue for year and region are all formatted in terms of millions. If you want this, you can also format the total year by revenue in terms of millions. So the way to do is, you can select this graph, right click and go to Format Axis. Here if I scroll down, you have numbers, and under category I'll select custom. Then I'll select my type as this format, which is in millions, and you see here we have successfully formatted our y-axis labels. Alright, so the next thing is to add slicers and timelines to our dashboard. Now slicers are used to format your data based on a particular column. Suppose if you want to see revenue by certain items, you can add item as a slicer and you can view the entire dashboard. Similarly, for timelines, you can add date columns. So if you want to see what was the amount of sales or revenue generated on a particular year or a particular month, you can do that using a timeline. So I'll select one of the charts, and then either you can go to the insert tab, and here you can see under filters we have slices and timeline, or if you go to the pivot chart analyze tab, here also you have insert slicer and timeline option. So I'll select insert slicer here first. Now it's giving me the list of fields present in the dataset. So I'll select country, region, and let's say we want to know by item type and sales channel. So these are going to be my 4 slicers. I'll click on OK. You can see it here. We have our 4 slicers here, and these are the list of values. Under region we have Asia, this Europe, North America, and others. Similarly, we have the different country names for country slicers, and then for item type also we have all the items that were present in our data set. Now moving ahead, we need to connect all the slicers to a dashboard. So what I'll do is I'll right click on this option and I'll go to report connections. Okay, so under report connections you have all the pivot tables that we created. You currently see only one of the pivot table is selected, so we need to select all the pivot tables. So let me check all the pivot tables present in this workbook and click on OK. Alright, now that we have connected one of our slicers, we'll now connect the other remaining slicers. So I'll right click on this, go to report connections, and I'll check all the pivot tables present in this worksheet. Click on OK. Similarly, let's do it for the country slicer. I'll go to report connections and let me select all the pivot tables. And finally, we have the item type. So I'll right click, go to report connections, and then I'll select all my pivot tables. And let's hit OK. Alright, now let me just organize this a bit. So I'll place my pivot tables to the right. I'll just reduce the size. Let me scroll down. Now I'll add my region slicer here. Similarly, I'll add my final slicer, that is sales channel. Now in our next dashboard, which is going to be the profit dashboard, I'll show you how to add a timeline. Alright, now I have arranged all my slicers. So let's say you want to find the revenue that was generated for an item type, let's say beverages. So you can just select beverages here, and all your charts show the respective revenues. So you have the total revenue by year for beverages only. Similarly, here you can see the revenue by year and region only for beverages item type. If I scroll down, now this chart represents the revenue that was generated in each of the countries only for item type beverages. Let me just uncheck it. Alright, let's say you want to see the revenue generated for a country like India. So I have selected India here, and now you can see my graph has changed only for country India. You can see here it is showing only for India now. Now similarly, you can also filter your revenues based on the different regions. Let's say you want to know the revenue generated based on sales channel. So we have two sales channel, that is offline and online. Suppose you want to know the revenue generated offline, so I'll just select offline. You can see the values have changed. So these were the revenues generated for each of the items only for offline. If you see here, now these were all the offline sales for the different regions. So this is our entire Excel revenue dashboard on sales. We created multiple charts and graphs, then we applied different formatting, we added different icons, then we formatted the labels also. Next we added slicers, and finally we saw how we could filter our data based on these slicers. Likewise, now we are going to create a profit dashboard based on the same data. So before moving ahead, let me rename this sheet as revenue dashboard. I'll write REV dashboard. Okay. Now we'll move to our data sheet and start creating our pivot tables and pivot charts for the profit dashboard. Alright, so let me go ahead and create my first pivot table. So I'll create a new worksheet. This time I'm going to create a line chart to visualize the profit for each year. So I'll drag my total profit column to values and my order year to rows. So here you can see we have our pivot table ready. Now you can sort this data to get an idea as to which year had the highest profit and which year had the lowest profit. So from this pivot table you can see, since I've sorted this data in descending order, so 2014 had the maximum amount of profit and 2017 had the least amount of profit. I'll just do Ctrl Z to undo it. Alright, now based on this pivot table, let me go ahead and create my pivot chart. So I'll go to recommended charts and click on a line chart. So this is the preview of the chart. I'll click on OK. Let me close this. Similarly, we are going to edit this chart now. So first I'll hide all the field buttons present on the chart, and I'll rename the chart title as total profit by year. Next, I'm going to remove the legend, so I'll delete this. Let's do some more formatting. So I'll go to style, and this time I'm going to select my style type. Okay, and if you want, you can choose the colors as well. For the time being, let's have this yellow color. Next, let me add the data labels. So again, if you see here, this is not formatted properly. So let's go ahead and format the data labels. So I'll click on number and I'll select custom here, and the type I'm going to select is in millions, and I'll click on close. So here you can see we have our line chart ready, which shows total profit by year. Let's rename this sheet as profit by year. Alright, now let's move back to our data sheet again. Next, we are going to show the total profit by countries. For this, I'm going to create a map. So let me first create my pivot table. So I'll go to insert and I'll click on pivot table. Let me click on OK. Since I want the country names, so I'll select country under rows, and then I have my total profit under values. The next thing I'm going to do is I'll just rename the row labels as countries, and then I'm going to delete the grand total, which you can see at the bottom. So here we have the grand total. Let me just delete the grand total. So I'm going to select this pivot table, go to the design tab. Here we have subtotals and grand totals. I'll switch off the grand total. Let me just verify it again. I'll scroll down. You see the grand total has gone now. Alright, now we want to create a map out of this. The way to do is I'm going to select my data, copy it, I'll go on top and I'll paste it here. Using this data I can create my field map now. So I'll go to insert. Here we have the option to create a field map. There you go. You can see we have our map ready. I can expand this. Now as you can see, our map has a color scale which comes from light gray color to dark blue color. So the countries that are in gray, or you can say light blue, have the lowest amount of profit, while the regions or the countries that have been shaded in dark color or dark blue color have highest amount of profit. I will go ahead and delete this scale. Okay. Next, we need to connect this map to the original data source. So what I'll do is I'll right click on this map and I'll go to select data. Here instead of the previous range, I'll give my new range now. So my new range will be my original pivot table that I had created. I'll go on top and click on OK. So we have our map ready now. Now if you want, you can change the color of the shade. So I'll just go to colors and let's say we'll keep green color. So the countries that are shaded in dark green have the highest amount of profit, while those which are highlighted in light green color are the countries that made least amount of profit. Okay, now moving on. Next, we want to create a pivot table that will show us the profit by year and sales channel. So for this we are going to create another line chart. So I'll go to insert and click on pivot table. So I'll select new worksheet. Here, since I want to know the profit by year, first of all I'll drag my order year column to rows, and then I'll choose my total profit column under values. Next, I'm going to select my sales channel under columns. There you go. So we have our pivot table here. Now based on this pivot table, let me create my pivot chart. So I'll go to recommended charts and I'm going to create a line chart. I close this. You see here, based on this chart, you can tell the profit generated with online sales were actually lower than that of offline. So here the blue line represents offline profit and the orange line represents online profit. If you mark clearly, in year 2012 the online profit was actually higher than the offline profit. So let me go ahead and edit this chart a bit. So we'll delete the field buttons. I'll also delete the legend for now. Let me go ahead and add a chart title. So I'll write profit by year and sales channel. Okay, so this is my second report. Before moving ahead, let me just rename this sheet. So I'll write profit by countries. Similarly, let me rename this sheet as profit by year and let's say SC for sales channel. Okay, moving ahead, now I want to create a pie chart based on a pivot table that will show the profit by sales channel only. So this is going to be a simple pie chart. So I'll first go to insert, click on pivot table and click on OK. So I'll drag my sales channel under rows and then we'll have the total profit column under values. So this is my simple pivot table. Now let's create our pivot chart, which is going to be a pie chart. Let me explore the other types of pie charts we have. Okay, so I'm going to select a donut chart here. I click on OK. Let's edit this chart. I'll remove the field buttons. Let me now remove the legend as well. I'll just resize it, and this is going to be profit by sales channel. Okay. Let's also add data labels, and here again I'm going to format this label. I'll select the category as custom and my type will be in millions. Okay, let me just move this to the left and this to the right. Okay, let's also delete the lines. Cool. Now let me just rename this sheet. So I'll write profit by, let's say SC, which stands for sales channel. Cool. Finally, I'm going to create a report that will show the revenue and profit by items. So I'll go ahead and create my pivot table first. This time I'll choose my total profit under values, and we'll also have the revenue column. So I'll put my revenue at the top. Then I'm going to select item type under rows. So here is my pivot table. Based on this pivot table, let me now create a combo chart. So you can see the preview of the chart. The blue bars represent the total revenue and the orange line represents the total profit. I'll click on OK. Let me close this. First, let's remove the field buttons. Let's also remove the legend here. Then we'll add a chart title. I'll name it as revenue and profit by items. Okay. If you want, you can also go ahead and change the color of the bars. So let me just select one of these colors. Okay. Alright. So we have our 5 reports ready that we are going to use for our profit dashboard. Next, let's create a new sheet and we'll get started with building our dashboard. So I'll click on a new sheet. Let me just rename this as profit dashboard. Alright. We'll continue with the previous drill. So first of all, let's go to the view tab and remove the grid lines. Now we'll insert a background image like we did for our revenue dashboard. So I'll go to insert. Under illustrations, I'll click on pictures and select this device. I'm going to have the same background. I'll click on insert. Alright, so you can see we have a picture of a company, or you can say an organization. Let's just drag this a bit to the right. We'll adjust the size also. Alright. Now let's copy the title of my profit dashboard. So here you can see I have brought my revenue dashboard, and I'll copy the title and the logos that we used for the revenue dashboard. I'll paste it on my new dashboard. Let's just align it in the center. Alright, the next step, let me now go ahead and edit the title. So this is actually going to be Excel profit dashboard instead of revenue. Now we'll copy each of the charts that we just created. For example, the revenue and profit by items, then we had profit by sales channel. All this we are going to copy one by one and put it on the profit dashboard. So let me just copy a few now. I'll paste it here, and later on we can make the adjustment. I'll copy this as well. Similarly, I'll bring the other 3 charts onto my sales dashboard. Okay, so here on my profit dashboard, I have added all the charts and I have aligned and reshaped it so that it looks good. I have also made some formatting. For example, I have reduced the size of the chart title. Now let me go ahead and show you a few more formatting that we also did for the revenue dashboard. First, let's remove the white background from all the charts. So I'll select the first chart, I'll right click and I'll click on format chart area. Here under fill, I'll select no fill. Next, I'm going to remove the grid lines, so I'll just delete it. Let me close this. Now we also have a outline, so I'll go to design, actually format, and I'll remove the outline. Next, I'm going to add a blue box at the back like how we did for the revenue dashboard. So let me select a blue box from here and I'm going to paste it here. Okay, now let me just select the chart and I'll bring this to front and I'll move this to the back. Next, I'm going to change the font color all to white so that it's clearly visible and it's more readable. I'll do it for the x-axis as well. Okay, so here I have my first chart ready. The same I'm going to do for the rest of the charts. Okay, so now you can see here I have formatted all my charts. I've also added a blue background. You see here I have also formatted the Y labels in terms of millions, which is actually the profit. Similarly, here I have added the data labels. This is for revenue. Some of the charts also have the data legends. So here you can see the blue color represents offline and the red represents online. Similarly, here you have the legends. I've also formatted the map as well. Okay, now the next thing is to make this dashboard more interactive. So we'll add our slicers as well as timeline. First, let me show you how to add a timeline. So I'll select one of the charts and I'll go to insert. Under insert, I have the option to create a timeline. So I'll just click on timelines. So timeline is actually based on date columns. So since in our dataset we only have 2 date columns, one is order date and one is ship date. So Excel has only shown us 2 columns. So I'm going to create my timeline based on order date. So I'll select my order date column and I'll click on OK. You can see here this is called a timeline. I can expand this. Now this timeline is based on months now. Now if I scroll this timeline, you can see here I have my order year 2010 and I have all the 12 months. Similarly, we have for 2011, then we have for 2012 all the way till 2017. Now you can filter this in terms of years, quarters, months or days. Let me just select year now. So I have years from 2010 till 2017. Let me just squeeze this and I'll place it somewhere here on the right. Now let me go ahead and create a few slicers for my profit dashboard. So I have selected one of the charts. Under insert, I'll click on slicer. You can see it gives me the list of columns from which I want to create slicers. So I'll create a region. Let me also select country. Let's say I want the representative's name or the customer's name and I'll click on OK. So here I have created 3 slicers. Let me first resize it and I'll place it on the right. Similarly, I'll place the country column also. Then we have the region slicer. I'll resize this and I'll bring it here. Okay. The next thing we need to do is I have to connect all the slicers and the timeline to the pivot tables for the profit dashboard. So I'm going to click on the multiple select option and go to report connections. Here I'm going to select all the pivot tables that are related to profit. So here I have selected 4 and I need one more, which is pivot table number 10. I click on OK. Similarly, let's create or connect my region filter to all the pivot tables. So I right click, go to report connections. Here I'll choose all my pivot tables which are based on profit. I'll click on OK. Let's do it for the country slicer as well. I click on OK, and similarly I'll connect my timeline as well. I'll go to report connections and I'll select all the pivot tables related to profit. Then I'll click on OK. Let me now go ahead and create another slicer based on sales channel. So I'm selecting one of the pivot charts. I'll go to insert, click on slicer, and I'll select sales channel and hit OK. So I have my sales channel slicer. Now let me connect it to all the respective pivot tables that are based on profit. Click on OK. Now let me just bring it here. Alright. The next thing I want to show is how are we going to use the timeline first. So you see we have all the years here from 2010 till 2017. Now suppose you want to know the profit that was generated in the year 2012. So I'll just click on this range, and now you can see our charts only show information for 2012. So this dot represents there was 51 million profit in the year 2012. Similarly, you can see here the profit by sales channel for 2012. From the map you can see the different countries and the profit each of these countries made in 2012. If I scroll down, you can see the revenue and profit by items. Now if I select another year, let's say 2013, I can just drag this to the right, and now you can see our profit by year and sales channel for offline and online. You can see the map or the line chart for total profit by year. So in 2012 it was 51 million, and then it went up to 54 million in 2013. Similarly, our map has also changed. Now this is a sort of an information that we have. You can click on this and check the information that Excel has prompted. Alright, so this is how you can use a timeline. Now as I said, we checked by years. You can also see it for months and quarters as well. Let me just uncheck it. I'll send it back to the place where it was, and I'll reduce the size. Okay. Now suppose you want to check the profit made by different representatives. You can select them one by one. Let's say Adam Churchill. This is the profit generated by Adam Churchill. Similarly, you can select multiple persons as well. Now suppose you want to see the profit by different countries, so you can use the country slicer. Let me just bring this to the middle, and let's expand our chart a bit. Okay, so here you have the profit by different countries chart. I'll just bring this to the front so that you can see it clearly. Okay, now here suppose you want to see the profit generated in, let's say, United Kingdom. You can select United Kingdom. So this is the map of United Kingdom, and it tells you the total profit that was generated in United Kingdom, and below you can see the revenue and profit for all the items that was sold in United Kingdom. So you had beverages, clothes, household, office supplies, So you can see clearly office supplies item made the highest amount of profit in United Kingdom. Now you can also select multiple countries. Let's say I want to know for France as well. So my map will change accordingly. So now I have United Kingdom and France selected, and the other charts present in my dashboard change accordingly. Now I have my country selected as India. You can see the map of India here, and these were the respective profit values. Now one thing to note here is this is actually not millions, that should be in K, that is thousands. So please mark this as 1000 and not in millions. Even for this is actually K and not million. Alright, so we have successfully created our second dashboard, that is on profit. Let me just resize this a bit and we'll place it where it was earlier. Cool. So we saw how to create different pivot tables and pivot charts, and then we formatted our pivot charts based on our requirement. We saw how to edit the colors. Now let me show you one more thing. You can also change the look and feel of the dashboard by going to the page layout tab. Under page layout you have themes. So here you can select different themes. Currently we are with the office theme. Now let me just select another theme, let's say Facet. You see the colors have changed and it looks really beautiful. Similarly, let me try out another theme, let's say organic. You see our chart has changed. Let me just delete this. Okay. So now once you change the theme, the text also change a bit. You can see the slicers are in a different font. Let me explore one more theme. Let's say this time I'm going to choose depth, and this is more of a green type of color. You can play around and select whatever theme suits the best. Alright. Now let me just move back to my revenue dashboard and see how it looks. There you go. So since we changed our theme, even our revenue dashboard is also impacted. So this is how it looks now. You can always go ahead and play with different themes, colors, fonts and effects. Alright, so in this demo we saw how to create a revenue dashboard. So we created line charts, this combo chart, pie chart, horizontal and vertical bar charts, and then we learned how to add slicers and connect it to different pivot tables, and we filtered our data to see revenue as well as profit by items, by countries, by different regions, sales channel. We learned how to create a map and lots more.
Let's quickly see some more examples of doing data analysis using Excel, and for that we can use some inbuilt add-ins which can be added to our Excel sheet. So for example, if you would want to do a descriptive analytics or descriptive analysis on your data, say for example getting your descriptive statistics such as your mean, median, mode and so on, so we can do that and we can use Excel for it. So for example, you can, if you are given some data, say I have temperature, price of ice cream, units sold, and I would want to have descriptive statistics on this, what I can do is I can click on file, and here in file you can click on options, and within options click on add-ins. Now within add-ins you have Excel add-ins which is selected here. So click on say go for example, and that shows what add-ins are available and you can choose which ones are you interested in. So for example, I have chosen analysis tool pack and solver add-in and click on OK. Now that basically should add more options to your Excel. So if you click on data, so here you see data analysis and solver. And this is what we would want to use to get our descriptive statistics for these three columns. So for example, let's say temperature, or you can even give the names later once you get your descriptive statistics. So for example, let's go for data analysis. And here it says, what are you interested in? There is a two-factor with replication. You have correlation, covariance, descriptive statistics. You have histogram. So let's click on descriptive statistics. Click on OK. Now this one basically asks your input range. So while your cursor is blinking here, also it is said grouped by. So let's give it a range. So for example, I will say temperature. Now if I do this and I have selected the heading, just look at that. And now you need an output range. So let's just select this, and then you can have your cursor blinking in here. Let's select, say, fields here, and this is where I would want the output. Now it also said what options do you want. So it has output range. We can then select summary statistics, confidence level. So I will say summary statistics is what I'm interested in. Say OK. And this says input range contains non-numeric data. Now why is that? Because we chose temperature, the heading also. So click on OK, and here we will alter the range. So this one is, our range should be only the values, numeric values on which we would want the descriptive statistics. We have output range already selected. We have summary statistics. And now you can click on OK. And that basically gives your descriptive statistics for temperature. So here I could basically given a value for this. So I can say temperature, and that's my descriptive statistics for temperature. Might be I can just do some formatting, and that's it. So that gives me descriptive statistics for the values here. Now similarly, we can do it for price of ice cream. So what we need is, we need to basically go for data analysis, descriptive statistics, say OK. Now you need to give a range. So here I will change my range to these values. Output range is already selected. Now we are interested in summary statistics. Click on OK. And this says output range will overwrite existing data. Press OK to overwrite data in range. I will say cancel. No, that's not what we want to do. We need to give a new range. So let's select our new range, which is here, and now click on OK. So now we get the values, which is for your price of ice cream. So again, we can basically select this and say price of ice cream, and we got our descriptive statistics for price of ice cream. And like we did earlier, I can select this. I can basically do a merge and center, and that gives me descriptive statistics for price of ice cream. So we could also basically change this. Now I can go into data, and I can go into data analysis, descriptive statistics. So we know that we had selected this B2 to B8, and this one, which is H6 to H19, we would want to shift it, might be 2 columns up. So might be I can just say H5, and I can manually change it to H17, and let's say OK. And we will basically get this, and I can get rid of this. So I can have it in the same range. So similarly, so this one will have to be renamed, and I can basically say price of ice cream, and that's basically my descriptive statistics for my price of ice cream. And similarly, we can do it for the third column, which is units sold. So we would want to have this. Now let's see, we can click on data, we can click on data analysis, descriptive statistics. So we need to give the range correctly. So this time our range changes to units sold. Now we can also say labels in first row, okay, if we were selecting the heading. So let's do it in this way. So in my range, let me empty this. I can basically select this, which we know has non-numeric data in the first row. Say for example, I'll say labels in first row. I'm interested in summary statistics, and this range will now have to be changed from H to basically something like J. So let's say J, and let's select these values. So that should take care of things. And now you see you have your units sold. You did not have to manually rename it, and you have basically got the descriptive statistics. So this is how you can simply perform analysis using data analysis here. You can basically get your descriptive statistics for your columns, and then you can do whatever needed formatting you need to basically make your data look in a good way. Now let's look at one more example of data analysis where we may want to look at the frequency of values or frequency of values occurring in a range of values. So for example, if you have been given temperatures, you have been given some bins where you would want to identify how many values fall into the range of 0 to 20, 20 to 30, 30 to 40, 40 to 50, and the easiest way to do that would be creating histogram. Now histogram is usually used for data analysis where you would want to look at different variables or say features. For example, temperature is one such feature. There might be one more variable or feature such as sale of ice cream, and you would want to see if the increase or decrease in temperature affects the increase or decrease in sale of ice cream. Might be sale of ice cream is a response based on temperature, so it depends. So sometimes you may want to find a relationship between two variables, whether they are positively or negatively related, or you would want to do different kind of analysis. And in certain cases we may want to first do analysis on one single variable, look at the frequency of values, might be also look at the defects, and for which we can use something like Pareto chart. So we can go for histogram, and that basically gives us the frequency of values. Now how do we do that? So we have already added the add-in, which is data analysis, earlier, so we can just use the same thing again. Here we would want to create a histogram, so let's say okay. Now I have already selected input range, so if you see here, my input range is temperature, which is also with the headings, and I have bin range, which is basically the range of values. So for example, I can select this, and that's my bin range. I am selecting or the option labels because I'm using the first row which has the heading such as temperature and bins. Now we need to give an output range. So for example, let's say I would want my data here, and that becomes my output range. So you can have a sorted histogram or basically a Pareto chart. So if that's what you're interested in, looking at the frequencies for your different ranges, and here I'm also selecting chart output because I would want to have a visual histogram which gives us the frequency. And it's as simple as this. Just click on OK, and now you get your bins. So it basically tells you frequency of values, which is basically 20, but that does not mean it is only talking about the values 20. It is basically talking as a range of 0 to 20. So we have 0 to 20, that is 2. So we can basically say there is 120 here, with the 20 being the maximum value, and then there is one more 20. So that's your 0 to 20. Then you have 20 to 30, which shows 3 values. So might be in that case I can say 26 is one thing. Then I can say 30, that's the second one. And then basically I can look at 22. So Basically, this one does not select 20 as the lower range, but it basically selects 30 as the higher range. So I do see 20 to 30, there are 3 entries. Similarly, we can see values for 40 and 50. And since we have selected Pareto or sorted histogram that shows in a descending order, what is the highest frequency of values within a particular range. So that shows me highest frequency is 5, and then you have 3 and 3 and then 2. So this is how we can create a histogram and we can perform analysis on a single variable. Now, as discussed earlier, as I said, sometimes we may be interested in finding out the correlation between different variables, such as, say, here we have temperature, price of ice cream, and units sold, and we may want to find out the correlation between one variable to another variable, or we would want to find out the relationship between variables. Are they linearly related? Are they positively related, negatively related, and so on? And for that, we can use the correlation of your data analysis add-in. So for example, you want to find out correlation of temperature and units sold. And what we can do is we can find out that using a formula. So for example, if I search for something like correlation, and let's search. So there is a function called correlation which we can use, and we can use this to calculate the correlation of temperature and units sold. So for example, let's select this, and that's the function. So it says give me an first array and a second array. So we are interested in finding out correlation of temperature and units sold. So let's select the range of values for temperature, and then I'm interested in finding out the correlation of temperature and units sold. So let's select this, and that basically gives me a range of values. It gives me the correlation value, which is 0.2859. Say OK, and that's your value. So similarly, we can do it for temperature and price ice cream. So let's go for correlation. So that's the function we are interested in. You need to give a range of values. So here we are interested in temperature and price of ice cream. So let's select temperature. And then the second array or list of values is price of ice cream. Let's select that. Let's close our bracket. And here we have the correlation value of temperature and the price of ice cream. Similarly, you may be interested in finding out temperature and units sold, like what we have done earlier. So we can do the same thing based on function. So this is same as correlation of temperature and units sold. So I can get rid of this one. Now, how do I do it using the data analysis add-in? So for that, what we need is we need to go into data. We need to go click on data analysis, and here you have the option called correlation. Let's select this. Now that basically needs an input range. So we need the range. Now I might be interested in finding out the correlation between temperature and price of ice cream and units sold. So I've selected all the columns here. We will say group by columns. Obviously we need to select labels in first row, because that is basically taking care of the first row as heading. Now output range, you can just give one simple cell, and that's where your data will start from, or you can give a new workbook. So click on OK, and that basically gives your correlation of your different variables and what are the values. And we can check these values based on the values what we have here. So we have basically temperature and price of ice cream, and that basically shows me 0.96149. You have temperature and units sold, so you have 0.2859. Now you can also look at units sold and say, for example, price of ice cream. You can look at these particular values. So if I would be interested in finding out what is the relationship between these variables, I can easily find using correlation. So I could be basically writing in a formula here and selecting what are the cells. So here we were selecting A2 and see here we were selecting A and B. Now might be I'm interested in price of ice cream and units sold, and if that's what I'm interested in, then I will give a range of B2 to B8, C2 to C8, and similarly you can get your analysis or correlation values. So it's very simple in Excel, and you can use either the data analysis tab and get your correlation, or you can use formulas and do that. Now, one more important part of data analysis is doing your sampling. Now, sampling could be periodic sampling or random sampling. So sometimes you may want to look at a variable and you may want to get some values based on periodic data. That means might be I'm interested in range of values. I'm interested in seeing a sample of values for a particular period, which could be basically uh, a range of values, or you could just do a random sampling. So for example, if I go for periodic sampling, so out of these values which I see here, might be I want to see, say, periodic sampling, that is a frequency of 2 values, how many times we have these values occurring here. Or I would go for random sampling. So basically randomly I would want to pick up, say, 3 temperature values. Now how do I do it? So for example, here I have 7 values. Now if I go for periodic sampling, the sample or periodic sample value which I need to give has to be lesser than the total input values. So for example, we can do this. Let's go in here and let's go for data analysis. So we can go for sampling here, click on OK, and that needs a range of values. So we will select A2 to A8. Now I could have selected all the values for this one, temperature, and in that case I can give labels, which is going to take care of the first row. Now here we can go for number of samples which we are interested in, or giving a period. So let's go for period and say, for example, I have 7 values. So what if I select 5? So for example, if I say 5, that means I could just get one value. So basically when I'm saying 5 out of 7, so that's just giving me out of 5 I want one value. So I can then just give an output range. So here I can basically select this cell, I'll say OK, and now you see it just shows me one value. So out of the first range, that is, I've said 5, it has given me the 5th value. That's your periodic sampling. So for example, we want more values. So let's reduce this period to might be 2, which basically gives me every second value. So I can basically say, for example, 2 and say OK, and then say OK. So that shows me 26, then you have 35, then you have 40, and then, well, this one does not have any more values. So that's your periodic sampling. Now if you go for random sampling, that's basically randomly picking up values, and you can choose how many values you want. So go for data analysis, go for sampling. I'll go for number of samples, how many you want. So for example, out of 7 values, randomly I want 3 values, and I can just give this, say OK, and then we will do a cancel because we need to change the range. So let's select this and say OK, and that gives me random 3 values from this values of temperature. So we can use Excel to do a simple sampling, and we can choose whether we would want to go for periodic sampling or random sampling.
Since this is data analysis with Python, we got to ask the question, why Python for data analytics? I mean, there's C++, there's Java, there's .NET from Microsoft. Why do people go to Python for it? So the number of reasons. One, it's easy to learn with simple syntax. You don't have a very high typeset like you do in Java and other coding, so it allows you to kind of be a little lazy in your programming. That doesn't mean that it can't be set that way and that you don't have to be careful. It just means you can spin up a code much quicker in Python. The same amount of code to do something in Python a lot of times is 1, 2, or 3 or 4 lines, where when I did the same thing, say in Java, I found myself with 10, 12, 13, 20 lines, depending on what it was. It's very scalable and flexible. So there's our flexibility because you can do a lot with it, and you can easily scale it up. You can go from something on your machine to using PySpark into the Spark environment and spread that across hundreds, if not thousands of servers across terabytes of data or petabytes of data. So it's very scalable. There's a huge collection of libraries. This one's always interesting because Java has a huge collection of libraries. C has a huge collection of libraries. .NET does, and they're always in competition to get those libraries out. Scala for your Spark. All those have huge collections of libraries. This is always changing, but because Python's open source, you almost always have easy to access libraries that anybody can use. You don't have to go check your licensing and have special licensing like you do in some packages. Graphics and visualization, they have a really powerful package for that, so it makes it easy to create nice displays for people to read. And community support. Because Python is open source, it has a huge community that supports it. You can do a quick Google and probably find a solution for almost anything you're working on. Python libraries. Let's bring it together. We have data analytics and we have Python. So when we're talking data analytics, we're talking Python libraries for data analytics. And the big 5 players are NumPy, Pandas, Matplot library, SciPy, which is going to be in the background, so we're not going to talk too much about the scientific formulas in SciPy, and scikit. So NumPy supports n-dimensional arrays, provides numerical computing tools useful for linear algebra and Fourier transform. And you can think of this as just a grid of numbers. And you can even have a grid inside a grid, or data. It's not even numbers because you can also put words and characters and just about anything into that array. But you can think of a grid, and then you can have a grid inside a grid, and you end up with a nice 3-dimensional array. If you want to talk 3-dimensional array, you can think of images. You have your 3 channels of color, 4 if you have an alpha, and then you have your XY coordinates for the image we're looking at. So you can go X, Y, and then what are the 3 channels to generate that color. And NumPy isn't restricted to 3 dimensions. You could imagine watching a movie. Well, now you have your movie clips, and they each have their X number of frames, and each of those frames have X number of XY coordinates for the pictures in each frame, and then you have your 3 dimensions for the colors. So NumPy is just a great way to work with n-dimensional arrays. Now closely with NumPy is Pandas, useful for handling missing data, perform mathematical operations, provides functions to manipulate data. Pandas is becoming huge because it is basically a data frame. And if you're working with big data and you're working in Spark or any of the other major packages out there, you realize that the data frame is very central to a lot of that. And you can look at it as an Excel spreadsheet. You have your columns, you have your rows or indexes, and you can do all kinds of different manipulations of the data within, including filling in missing data, which is a big thing when you're dealing with large pools or lakes of data where they might be collected differently from different locations. And Matplot library. We did kick over the SciPy, which is a lot of mathematical computations, which usually runs in the background of NumPy and Pandas. Although you do use them, they're useful for a lot of other things in there. But the Matplot library, that's the final part. That's what you want to show people. And this is your plotting library in Python. Several toolkits extend Matplot library functionality. There's like 100 different toolkits to extend Matplot library, which range from how to properly display star constellations from astronomy. There's a very specific one built just for that, all the way to some very generic ones. We'll actually add Seaborn in when we do the labs in a minute. Several toolkits extend Matplot library functionality, and it creates interactive visualization. So there's all kinds of cool things you can do as far as just displaying graphs, and there's even some that you can create interactive graphs. We won't do the interactive graphs, but you'll see, you'll get a pretty good grasp of some of the different things you can do in Matplot library.
Pandas really is a core Python module you need for doing data science and data processing. there's so many other modules that come off of it. There actually sits kind of on NumPy, so if you've already had our NumPy array, hopefully you've already gone through the NumPy tutorial 1 and 2. So today we're going to cover what is pandas. We'll discuss series. We'll discuss basic operations on series. And then we'll get into a data frame itself, basic operations on the data frame, file-related operations on a data frame, visualization, and then some practice examples. Roll up our sleeves and get some coding underneath there. And let's start with just some real general, what is pandas? Pandas is a tool for data processing which helps in data analysis. It provides functions and methods to efficiently manipulate large data sets. Now, this is a step down from, say, using Spark or Hadoop in big data. So we're not talking about big data here, but we are talking about pandas, and there is some connections. There's like an interface going on with that, so there is availability, but you really should know your pandas, because if you're working in big data, you'll know there's data frames. Well, pandas is a data frame primarily. It has a couple different pieces we'll look at here. And if you've never worked with data frames before, a data frame is basically like an Excel spreadsheet. You have rows and columns. You can access your data either by the row or the column, and you have an index and that kind of setup. And we'll dig more into that as we get deeper into pandas. But think of it as like a giant Excel spreadsheet that's optimized to run on larger data on your computer. And then I said it that it's a data frame. So the data structures in pandas are series, one-dimensional arrays, and then we have data frame, two-dimensional array. And it really centers around the data frame. The series just happens to be part of that data frame. And here's a closer look at a pandas series. Series is a one-dimensional array with labels. It can contain any data type, including integers, strings, floats, Python objects, and more. So it's very diverse. If you remember from NumPy we studied, they had to be all uniform. Not in pandas. In pandas we can do a lot more. And pandas actually kind of sits on NumPy, so you really need to know both of those if you haven't done the NumPy tutorials. And you can see here we have our index 1, 2, 3, 4, 5, and then our data A, B, C, D, and E. Very straightforward. It's just two columns, and we have a nice index label and a column label for the data. And then a data frame is a two-dimensional data structure with labels. We can use labels to locate data. And you can see here we had, if we go back one, we had our index 1, 2, 3, 4, 5. So in each one of these series, they would share the same index over there, the row index. So you have your row index df.index, and then you have a column index df.columns. And this should look, like I said, this would be really familiar if you've done any work with spreadsheets, Excel. So it kind of resembles that. This does make it a lot easier to manipulate data and add columns, delete columns, move them around. Same thing with the rows, so you have a lot of control over all of this. Now, we're of course going to do this in our Jupyter Notebook. You can use any of your Python editors, but I highly suggest if you haven't installed Jupyter and haven't worked with it, it is probably one of the best ways for easily displaying a project you're working on. I skip between a lot of different user interfaces or IDEs for editing my Python, and it's just simply jupyter.org, jupyter.org. And then I always let mine sit on Anaconda, anaconda.com, and just real quick we'll open that up for you. Oops, offline mode. Don't show me that again. But you can see here that I have different tools that I can actually install in my Anaconda, including the Jupyter Notebook, which comes by default. And then I have access to the environments. And again, that's anaconda.com, named after the very large, one of the world's largest snakes, and then Jupyter Notebook, in this case jupyter.org. And when we're in I'm going to go in here to our Jupyter Notebook, and we're going to go ahead and just do new and a Python 3. And this will open up a Python 3 untitled folder. So diving right in, let's go ahead and give this a title, Pandas Tutorial. And we'll go up to cell, and we'll change the cell type to Markdown so it doesn't execute it as actual code. One of those wonderful tools when you have Jupyter Notebook so you can do demos with this. And let's go ahead and import pandas, and usually people just call it PD. That has become such a standard in the industry. So we'll go ahead and run that. Now we have our pandas has been imported into our Jupyter Notebook. And then, we can go ahead and let me do the Control Plus. Since it's Internet Explorer, I can enlarge it very easily so you have a nice pretty view. Whoops, too big. There we go. And whenever you're working with a new module, it's good to check your version of the module. In pandas, you just use in this case, pd.__version__. That's actually pretty common in most of our Python modules. There's different ways to look up the version, but that's one of the more common ones. And we'll go ahead and run that. We get 0.23.4. And if we go to the Pandas site, we see 0.23.4 is the latest release. And of course, a reminder that if you're going to your environment, you need to install it. So you'll need to do pip install pandas if you're using the pip installer. We'll go ahead and close out of that. And the first thing we want to do is we're going to work with series. A lot of the stuff you do in series you can then do on the whole data set. We need to do what? Create one. We need to manipulate it, take pieces of it, so query it, delete, so you can delete different parts of it. So we want to do all those things with the series. And we'll start with the series, and then almost all the code, in fact all the code does transfer right into the actual data table. So we go from a series of a single list of one column, and then we'll take that and we'll transfer that over to the whole table. And we'll start by creating, let's put a, there we go, creating a series from list. And let's just call this ARR equals, and we'll do 0, 1, 2, 3, 4. If you remember from our last one, we could easily do R equals range of 5, which would be 0 to 4. But we'll do R equals 0 to 4, and we'll call this S1, and we'll go PD, and series is capitalized. This one always throws me, is which letters do you capitalize on these modules? They're getting more and more uniform, but you got to watch that with Python. And we're just going to go ahead and do ARR. So we're just going to take this Python list and we're going to turn it into a series. And then because we're in Jupyter, we don't have to put the print statement. We can just put S1 and it'll print out this series for us. And let's go ahead and run that and take a look. And you'll see we have 2 rows of numbers. So the first one is the index. Now it automatically creates the index starting with 0 unless you tell it to do differently. So we get 0, index row 0 is 0, 1, 1, 2, 2, 3, 3, 4, 4. And because it's a series, it doesn't need a title for the column. There's only one column, so why title it? And this also lets you know that it's a data type of integer 64. So we print this out. This is our series, our basic series we've just created. And let's do a second series, PD, and we'll use the same data list. And let's go ahead and do order. We'll give it an order equals, let's do it this way. Let's go index equals order. And it helps if we actually give it an order. So we'll do order equals, and let's do 1, 2, 3, 4, 5. So instead of starting with 0, we're going to give it an order starting with 1. We're going to run that, and we'll go ahead and print it out down here, S2. And we'll see that we now have an index of 1, 2, 3, 4, 5, and that represents 0, 1, 2, 3, 4 in the series. And we're still data type integer 64. And very common as you're messing with NumPy arrays is we can import our NumPy as NP. Remember that from our NumPy tutorials. We can go ahead and create a NumPy out of random with the random numbers of 5. And let's just see what that n looks like, so we can see what our NumPy looks like. So we have some nice random float values here, 2.33, so on. And that's from our last tutorial, the NumPy tutorial 1 and 2. And instead of calling it order, let's call it index. And we're going to set our index equal to A, B, C, D, and E. I want to show you that the index doesn't have to be an integer, so it can be something very different here. And then let's go ahead and create our, we'll just use S2 again. And here's our NP for NumPy, series, capital S, and N is our NP for NumPy. PD for pandas, there we go, switching my anachronisms. So we have pd.series of n, and we want to do our index equals our index we just created. And then let's go ahead and see what that looks like. S2 to print it, and let's run that. And we can see here we have a nice series going on. A, B, C, D, and E for our indexes. So instead of it being 0, 1, 2, 3, or 4, we can make this index whatever we want. And you can see the numbers here going down that we randomly generated from the NumPy array. So we used NumPy to create our Pandas series right here. And so continuing on with creating our series, this one I use so often, we create a series from a dictionary. So we have our dictionary. In this case, we went ahead and did A of 1, B is 2, C of 3, D 4, E of 5. So each one of those is a key and then a value. And then we're going to use, let's use S3 equals PD for pandas, series, and then we want to go ahead and just do D in here. print out S3 here, and let's go ahead and run this. And you can see we got A is 1, B is 2, C is 3, D is 4, E is 5. And it's still of integers 64 because the actual data is 1, 2, 3, 4, 5, and it's all integers 64, type 64. And the last thing we want to do in the creating section of our series is to go ahead and modify the index, because we're going to start modifying all this data. So let's start with modifying the index of the series. And if you remember, let's do a print this time, S1. I'll go ahead and run this. And the reason I did print is because it only prints out the last variable. So if I put S1 up here and we're going to do another variable back down lower, it won't print the first one, just the last one. And we're going to go ahead and take S1, the index, and we're just going to set it equal to a new index. And obviously, the number of objects in our index has to equal the number of objects in our data. And then because it's the last variable, we can go ahead and just do an S1. And let's run that, and you can see how we went from 0 to 0, 0, 1, 2, 3, 4 as our index. We've now altered it to A, B, C, D, and E. So this would be much more readable or might be representational of a larger database you're working with. So cool tools. We've covered creating a database based on a basic array, Python array. We've showed you how to reset the index. Then we showed you how to use a NumPy array. So you can put a NumPy array in there. It's all the same, pd.series, a NumPy array, and then we can set the index on there. And the same thing with the dictionary. So it's very versatile how it pulls in data. And you can pull in data from different sources and different setups and create a new series very easily in the pandas. And then we looked on changing your index. So now we have a new index on here. And then we want to go ahead and do some selection. Let's do some basic slicing, most common thing you'll probably do on here. And we'll just do S1. This notation should start to look really familiar. Again, this is going to put an output, so it doesn't change S1. This just selects it. So we might do A equals S1 and then print A. And you'll see that it just looks at the first three, 0, 1, 2. And we can do the same thing by not having the A in there. I'll go ahead and take that out, but it's just a reminder that it's not actually changing S1. It's just viewing S1. So simple slicing on here. And we can likewise do an append. Oops, before we do append, let's just do a quick kind of fun one. We'll do to -1. And you'll see it covers everything but the E. Of course, you can do -2 on this side. So another way to select it is to go how far from the end. And likewise, we can do a 2 here, a CDE to the end. So it starts at the second one. And another way we can do this is we can do a -2 over here. And that looks at just the last 2 in the slice. So you can see how easy it is to slice the data. And of course, there's no reason to do this, but you could select all of them if you wanted to view all of them on there. Oops, 32. There's not 32, so it's just going to show the first 3. There we go. And then we can also append. So I can take and, let's create another series and append one to it. And if you remember, we had S3. There's our S3. And we have our S1. We'll go ahead and do S1. And let's go ahead and do, let's call it S4 equals S1 append S3. So we're just going to combine those two into S4. And if we go ahead and print S4 on here, you'll now see that we have A, B, C, D, E, A, B, C, D, E, 0, 1, 2, 3, 1, 2, 3, 4, 5, because we started the data at 1. So very easy to append one series to the next. And if we're going to append one series to the next, we need to go ahead and drop or delete one. And drop is the key word for that. And let's just do E, or index E. And so if I run this, you'll see that it'll print it out, and A, B, C, D, there's no E. And remember, all these changes, if I type in S4 again, you'll see that S4 still has E in it. So this change does not affect the series unless you tell it to. So I'd have to do like S4 equals S4.drop E. And there's another way to do that, which we'll show you later on. Let me just cut this one out. There we go. All right, so we've covered all kinds of cool tools here. We have appending, we have slicing, we did all the creating stuff earlier. So you can see here on the setup how easy it is to manipulate the series. So next, what we want to get into is we want to get into operations that happen on the series. Let me go ahead and change this cell to Markdown. There we go, and run that. So series operations, what can we do with a series? And let's start by creating a couple arrays. We'll call it array 1, and we'll do 0 through 7, and array 2, 6 through 6, 7, 8, 9, 5. I don't know why we threw the 5 on the end. Let's go ahead and run those so those load up into Jupyter. And we'll do this a little backwards. We're going to do S5 equals a Panda series of array 2. So I'm doing this in reverse. And then when we do S5, you'll see that we have 0 to 4. It automatically assigned the index. 6, 7, 8, 9, 5 for our series. And let's go ahead and do the same, and we'll call this S6, and we'll set this equal to PD series for our first array. And if we do an S6 down here to print it out, we'll see something similar. I got 0 through 6, 0, 1, 2, 3, 4, 5, 7 for the data. So those are two series we just created, series 6, 5, and 6. And one of the first things we can do is we can add one series to the next. So I can do S5.add S6. And let's see what that generates. And just a quick thing, if you've never used pandas, what do you think is going to happen with the fact that this only has 5 different values in it, and this one has 7 values? So let's see what that does. And we end up with 6, 8, 10, 12, 9, and it goes, oh, I can't add this. There's nothing there. So it gives us a null return. Very different than the NumPy that would have given you an error. This instead tells you there's no value here because we couldn't generate one. So we can easily add S5.add S6, and likewise we can do S5.sub for subtract S6, and we'll run that. And on the add, the subtract, and you guessed it, we're going to do multiply and divide next. Again, you can see there's the null values where it can't subtract the two because there's no values there to subtract. We can also do S5 multiply, MUL. They're all 3 letters on these. That's one of the ways to remember how they figured out the code for this. So remember, these are all 3 letters, mul. We'll go ahead and run this, and you can see how they're multiplied together. And then we can also do the S5 div, 3 letters again, S6, and run that. And you'll see here, this goes to infinity because we have 0 in the wrong position. So it actually gives you a whole different answer here. That's important to notice. And then in the null values, because there's no data and it can't actually produce an answer off of missing data. And since we're in data science, let's do S6 median. So let's look up the median data, which is simply median. Sorry for those who are following the 3 letters, because median is not 3 letters. And you can see in S6 is 3.0. And let's do a print here. And we'll do median or average. S6. And let's print max, comma S6. And just like median, there's max value. And if we're going to have a max value, we should also have a minimum value. So let's pop in minimum. We'll go ahead and run this. And you're starting to see something that would be generated like, say, in R, where you're starting to get your different statistics. We have a median value of 3, max value of 7, and a minimum value of 0. And what it does when it hits these null values, if there is null values in there, because we could still do that, we could actually, you know what, let's go up here and do, let's pick this one where we multiplied. Let's go S7 equals, I'll go ahead and print the S7 just so I keep it nice and uniform, so I still have my S7 down there and run it. And then I want to take the S7, because S7 now has null values and an infinity value, and let's see what happens. This is going to be interesting, because I want to see what it does with infinity. And we end up with a median of 6, maximum of 27, and minimum of 0, which is correct. It drops those values. So when it gets to there and it doesn't know what to do with them, it just drops those values and then it computes it on the remaining data on there. So that's important to know when you're making these computations, you're looking at min and max and median, you're not going to know that there's null values unless you double check your data for the null values. That's a very important thing to note on there. So just a real quick review on there. We've created our PD series, and we've gone ahead and done addition, subtraction, multiplication, division. All of those are 3 letters, so sub, min, div, add. And then we looked at median, maximum, and minimum. So we're going to go ahead and jump into the next big topic, which is to create a data frame. So now we're going to go from series, and we're going to create a number of series and bundle them together to make a data frame. There we go, cell type, markdown. And we go Go ahead and run that. So we have a nice title on there. It's always good to have a good title. Alright, so our first data frame, we'll jump in with some stuff that looks a little complicated, but we'll break it down. First, I'm going to create some dates. And you know what? Let's just go ahead and do this. I want you to see what that looks like, what I'm creating here. I've created a series of dates, PD date range, and we're going to use these for the index. Okay, so when you look at this, you'll see that it's just, basically it comes out kind of like a basic Python list or a NumPy array, however you want to look at it, with our different dates going down. And we've generated 6 of them. And it's going to have whatever time it is right now on the thing for the date for the time. That's that time stamp right there. And then you'll see we have 11/19, 2008, 11/20, 11/19, and looking into the future there. So that's all this is generating a series of dates that we're going to use as our index. And this is a pandas command, so we have a date range, which is nice. That's one of the tools hidden in there in the pandas that you can use. And next we're going to use NumPy to go ahead and generate some random numbers. In this case we'll do the np.random.random in 6,4. You can look at this as rows and columns as we move it into the pandas. And of course you could reshape this if you had those backwards on your data. But we want the 6 to match the rows, and we have 6 periods, so our indexes should match along with the rows on there. And then, you know what, before we do the next one, let's go ahead and just print out our NumPy array so you can see what that looks like. Here we have it, 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6. 4 by 6. So it's a nice little setup on there. And since working with data frames can be very visual, let's give our columns, we have 4 columns, and we're going to give them names, A, B, C, and D. So now we have columns on there also. And then let's put this all together in a data frame, and we can actually, you know what, let's do this. Since I did it with everything else, let's go ahead and do columns, and you can see there's our columns on there. And we'll go ahead and do df1 equals pandas dot data frame. And note that the D and the F are capitalized. Series, it was just the S, and I always highlight this because you don't know how many times these things get retyped when you forget what's capitalized on there. It's a minor thing. You'll pick it up right away if you do a lot of it. And the first thing we want to do is we want to go ahead and take our NumPy array, because that's what we're going to create our data frame off of, is the NumPy array. And then we want our index equal to our dates. So there's our index in there. And then we also have columns equals columns. And then finally, let's see what that looks like. Now remember, we had all that different data that just looks like a jumble of data. We have our column names and everything else. Our NumPy array, kind of just a jumble array over there, 4 by 6. You could sort of read it. But look how nice this looks. I mean, this is, you come into a board meeting, you're working with your shareholders. This is pretty readable. This is, this is our date. This is our A, B, C, D, whatever it is. Maybe each one of these dates has your leads, closures, lost leads, total dollar made, whatever it is, if it's in a business. Maybe it's measurements on some scientific equipment, weather searching material, where this is like high of the temperature, low of the day, humidity of the day, whatever it is. So you can see that we can really create a nice clear chart, and it looks just like a spreadsheet. We have our rows, and we have our columns, and we have our data in there. Now this one I use all the time. If we're going to create, we can create it like you saw here with our NumPy array. Very easy to do that and reshape it. You can also create it with a dictionary array. So here we have some data, and let me just go down a notch so you can see all the data on there. We have an animal, in this case cat, cat, snake, dog, dog, cat, snake, cat, dog. We have the age, so we have an array of ages. We have the number of visits and the priority. Was it a high priority? Yes, no. And then we're going to take that, we're going to create some labels. We have A, B, C, D, E, F, G, H, I. And what I want you to notice on this is we have a title, animal, and then we have basically a Python list. And these lists, they don't necessarily have to be equal because we can have non-data, np.nan, NumPy array, null value. But we want to go ahead and create labels that are equal to the number in the list. So A, the first cat, B, the second cat, C, the snake, D, the dog, and so on. So we'll go ahead and create our labels, which we're going to use as an index. And we'll call this df, let's do it this way. We'll call this df2 equals PD for pandas, data frame, and then we have our data, just like we did before, and then we have our index equals labels. And if we're going to go from there, let's go ahead and print it out so we can see what that looks like, df2. So let's go ahead and run that. Again, you have a nice, very clean chart to look at. We've gone from this mess of data here to what looks like a very organized spreadsheet, very visual and easy to read. Animal, age, visits, priority, and then A through J, cats and all your different animals, so on and so on. And then when you do programming, a lot of times it's important to know what the data types are. So we can simply do df2 d types. And if we run that, we can see that our animal is an object, because it's just a string, but it comes in as an object. Age is a float 64, integer 64, and then priority again is just an object. And exploring this one's very popular. Let's go df2 head, and if we print that out, the df2 head returns the first 5. And we can change this. You don't have to do 5. You might want to just look at the top 2. Maybe you want to look at, let's see, let's do 6. So maybe we want to look at just the top 6 in the database, in your data frame. And you can actually, this creates another data frame. So I could have a df3 equal to df2, and this now takes the df2 and just the first 6 values. So if we do df3, run, get the same answer. And if we do the head of the data, we can also do the tail. It's the same thing. df_tail, you can look at the last, we'll just do the tail, which by default does 5, the last 5. And of course you can just look at the last 3 of those real quick just to see what's at the end of the data. And this is, the tail, I love doing the tail of 1 because I'll have like the index or something like that, and it will just show me the last, whatever the last entry was. Looking at stock values, and I might want to look at just the last 5 days of the stock values. I can do that with the data frame tail. And some other key things to look up are the index. So we can do df2.index. And I want you to notice that this isn't a call function. So if I put the brackets on the end, it'll give me an error because index is not callable. It's just an object in there. So we do df2.index. There's also columns. So we can go ahead and let's print this. Remember, the first one's not going to show unless I print it, and then df2 columns. So now we can see that we have our indexes and we have our columns listed here, df2.columns, animal, age, visits, priority. It tells you what kind of object it is, or what kind of data type it is, and they're both object. And then finally df2.values. And again, there's no brackets on the end of df2.values. Because this is an actual object, it's not a callable function. So we'll go ahead and run that, and it just displays a nice array. A very easy way to convert this back to a NumPy array, basically. So before I go into the next section, let's just take a quick look at what we covered so far with the data frame. We came up here, we created our data frame. We did it from a NumPy array first, setting the columns and the index. The index setting it up is the same as when we set up the series, so that should look very familiar. So is the whole format, the NumPy array, the index dates, and the columns. And remember, in our NumPy array, we're looking at row, comma, column. So 6 rows, 4 columns is how that reads in the data frame. And we went ahead and also did that from a dictionary. In this case, animal was the column name with all the data underneath that column, and then age with that data, visits that data, priority that data. And then, of course, we added our labels in there for our index. So there's no difference in there, but it automatically pulled the column names. Important to know when you're dealing with a data frame and importing a data frame this way. And then we did looking up D-type. We looked at head and tail, looking at your data really quick. We also did index and columns and values. And note, these don't have the brackets on the end. So the next thing we want to do is go ahead, since we're dealing with data science, is we want to go ahead and describe the data. So we have df2.describe to do that, and we're going to manipulate it in just a minute, but let's just see what this generates. And you can see right here we have age and visits. So looking at our data from up above, let me just go all the way up here. Animal, age, visits, priority. And it does a nice job generating your age versus visits, which has all the data. You have your count, your means, your standard deviation, your minimum value. 25% are in this group, 50%, 75, and your maximum value. So this will look familiar as a data science setup with your describe for a quick look at your data frame data. So let's start manipulating this data frame and moving stuff around, and we'll start with transposing. and it is simply capital T for transpose. And when we run that, it flips the columns and the indexes. So now the indexes are all column names and the columns are all indexes, animal, age, visits, priority. So if we had come in here with our data shaped wrong, up above where we had a 4 by 6, we can quickly just swap it if we had it backwards. Not a big deal. And we can also sort our data, something that you can't do, which is more difficult to do with a lot of other packages. In the data frame, it's really easy to do. Take our data frame df2, and we're going to sort underscore values by equals age. And so when we run this, you'll see the default is ascending. So we have 0.52, 2.53, and everything else is organized. So if you look at your indexes, they've been moved around because each index, it moves the whole row, not just the one piece of data is not being sorted. So a very quick way to sort by age our different data in the data frame. And in addition to sorting it, we can also slice the data frame. So I could do df2, and this should look familiar from earlier. We'll just do 1 to 3. So we're going to pull out, oops, it does help if I use the df instead of just d. And we're going to pull up just between 1 and 3. So we have not 0, which is A, but we have B, which is 2, or B, which is 1, and C, which is 2. So 1, 2, and then it does not include 3, which is the standard in Python. And we can even do something like this. We can combine them, which is always fun, because remember this returns a data frame. So if I take df2 dot sort values, and we'll do by equals age. This is just kind of fun. And then I'm going to slice it. There we go. Double check my typing and run it. And now you should see FA, because FA are now 1 and 2 on there. So you can very quickly create a whole string on here which narrows it, that you can sort it, then slice it, and do all kinds of fun things with your data frame. We'll just go back to the original one. Run. There we go. And if we can slice it by row, we can also query the data frame. So we can do df2. And this is a little different because I'm going to create an array within an array. And in this case, we're going to look at, let's do age, comma, visits. So look at the different format in here. We have 1 to 3. So we've done this by slicing by an integer value. And then on here, I've done df2 age, comma, visits in an array. And when I run this, you can see that we get just these 2 columns on here. We get age and visits. So it's a quick way to select just 2 columns or select number of columns you're working with. And if you saw up there, we did the slicing. Almost identical to slice is iLocation, which uses the integer location 1, 3. There's a push in Pandas to move to this particular setup instead of doing just a regular slice. And that's because this can be confusing when we slice 1 to 3 and then we select age and visits. So there is a push to go ahead and move to an iLocation, which does the same thing. You can see here BC, it's the same as up above. There's also a copy command, so we can do df3 equals df2 copy. We're just going to create a straight copy of it. And of course, if we do df3, it'll be the same as a df2 on there. So df3 equals df2.copy. And then let's do df3.isNull. So we're looking for null values. And this will return a nice map, and you'll see that everything is false, except when you go up here under the cat or H, they had a null there. And so if we go to have a couple up here also underneath of, let's see, the dog. Okay, there's a bunch of nulls in here. There's D up here. So let's look at D down here, and you'll see false, true. There it is. There's our null value. So we can create a quick chart of null values. You can use this to do other things. We can leverage that null value to maybe take an average or something and fill those null spaces with data. And we can also modify the location. So here's our df3 location. And notice this is location, not iLocation. iLocation has I for integer. Location uses the, in this case, the variables on the left. And what we can do on here, and we'll go ahead and just set this equal to 1.5, and then let's pick a spot. Let's go back up here where we had, let's do F age, let's see, what was we looking at? Oh, here we go. Let's do F and age. And up here, F is set to age of 2.0. And we find out that that's incorrect data, so we go ahead and switch to df3 equal, and then we go ahead and print out our df3. And if we go to f and age, it is now 1.5. So we're just changing the value in the df3. And this is changing the actual data frame. Remember, a lot of our stuff we do a slice, and like it returns another data frame. This changes the actual data frame and that value in the data frame. So we've covered location, and iLocation is null. Making a copy, here's our iLocation, which is equivalent of a slice, and also selecting columns. So now we want to just take a little detour here, and let's look at df3 means. And this is kind of nice because you can do this. You can either do this you can select a single column here, by the way. You can just add the column selection right here like we did before. So we could have age, look up the mean, that just creates a series. If I run that, there's our age. But if I take that out, instead of selecting it, we can do the whole setup, and it has age and visits. So why doesn't it have priority or animal? Well, those are not integers, so it's really hard. They're non-numerical values. So what is the average? I guess you could do a histogram, which probably we'll look at that later on. But the only two things we can really look at is age and visits, and we have the average or the mean on the age is 3.375, and the mean on visits is 1.9. And let's do df3 visits. We'll go ahead and still the visits again. And you remember all those different functions we looked at for a series? Well, we can do those here. We can do the sum. So if we run that, we'll see that these sum up to 19. We could also look up minimum. If you remember that from before, the minimum is 1, max. So all that functionality is here. I'll just go back to summing it up and adding it all together. So real quick, we've shown you how to take the series operations and put them into the data frame. And then we can actually, this is an interesting one, we can just do df3 sum, run, and you'll see the different summations on there. It just combines them. I like the way it just combines the strings on there for priority and animal. We've looked at is null. We've also looked at copying, along with the different slices which we talked about earlier. So let's talk about strings. Let's dive into the string setup on there. And let's go ahead and create a string series. String equals PD series. And we just put it right in there. We have A, C, D, A, B, A, C, A. Popped in a null value. Cow and owl. I don't know why they picked cow and owl in the background. Someone must like those animals. And of course we can just do string. If we run that, you'll see, leave the R out, we'll get an error. But if we put it in there, you'll see that we have a simple series. 0A, 1C, 2D. And it automatically indexes it 0 to 8. And then we can go string dot lower. So when we're talking about our data frame, in this case, or our data series string, in this case, we're going to use the string function, str, and we're going to make it lower. And if we go ahead and put the brackets on there, and you'll see that we've gone from capital A, capital C, so on to ABC. And baka, CBA, cow, owl, they were all lowercase already. And of course, if you want to go lower, you can also do upper. And we'll go ahead and run that. And you can see we now have ACD, AAA, baka. Everything's capitalized except for the null value, which is still null. Alright, so we looked at a few basic string. You can see that string functions upper and lower. We're going to jump into a very important topic. I'm even going to give it its own header on here because it's such an important topic. What do you do with missing values? Panda has some great tools for that, so we'll dive into those. We'll work with df4, and if you remember the df copy from above, we're just going to make a copy of df3. And let's just take a quick look at the data we're working with. Oops, df3, forgot the 3 on there. There we go. So here we have our cats, snakes, and dogs. Hopefully not all in the same container, because that would be just probably mean to all of them. So we made a copy. We're going to be working with df4. And the reason we made a copy is we want to go ahead and fill the data. And we just simply do fill NA, and then we're going to give it the value we want to put in there. We'll give it the value 4. So I can run in here, and you'll see now that df4 now has where the NA was. It's filled with the value of 4. Same thing down here. A lot of times we'll compute the mean first. So I might do a mean age equals df4, and then we want to go ahead and do age and dot mean, and then I'll do something like this, df4. I only want to select the age, and I want to fill that with the mean age. And I run in there, and you'll see that our DF4 age now has the means in there. Just a quick way of showing you how you can combine these. Let me go back to our original one. There we go. And run that. And keeping with good practices, df5 equals df3.copy. And then we'll print our df5, which should be the original one. And then on the df5, we can now drop our missing data. I'm going to simply drop NA, and we're going to use how equals any. So I'm going to drop any row that has missing data in it. And you'll see we had D here with missing data and H. And then let's go ahead and see what DF5 looks like when we do that. There we go. And there it is. D is gone and so is H. So we create a new data frame off of this, missing those values. Now, if you have a lot of data, dropping values is a good way to take care of it because you don't miss some data. If you have not a whole lot of data, you're working with like the IRIS data set or something like that, or something small, you want to start trying to find a way to fill that data in so you don't lose your computational power of the data you got. So just a quick look at processing null values or missing values. You can fill them, usually with the means. Some people use medium or the mode. There's different ways you can fill it. One way is means. And we can also just drop those rows. Those are the two main things we do with missing data. Here we go. We're going to cover next. I so love data frames for this. File operations. It saved me so much time because they have so many different tools for bringing data in and saving data. So when we're looking at the data frame file operations, it's really streamlined. I don't know how many times I'll go on to different data downloads and they'll have Panda download standard on there just because it's so widely used. So let's start with the most common file is a CSV. So we have df3 to CSV or animal. And let me just show you the folders going into. Right now I have some untitled and a few things in here, but nothing labeled animal. So we go ahead and run this, and this has now saved the animal to my hard drive. And you can now see the animal folder up here, and if I, let's do edit with a notepad. Oh, let's open it up with just a regular notepad. There we go. Or WordPad. If I open that up, you can see it's comma separated. Our titles, they don't have an index on the categories on the top. And the index, comma, and then all the different data is separated by commas. Standard CSV file on there. And if we're going to send it to CSV, and notice the format is .to_CSV. And it's just the name of the file we're sending it to. You can also put the complete path. By default, it's going to go whatever the active directory this program's running on. That's why those other folders are in there. So we have our df3 to CSV, and then if we're going to put it in there, we want to also get it back out. And we'll call this one df_animal equals pd read_CSV. I always have to remember it's to_CSV and read_CSV. I always want to do like a capital in there and not the underscore. We're going in here again, it's the active directory. So if I now do print out my df animal, and let's just do the head. We only want to look at the first 3 lines. So if I go ahead and run this, we'll see the first 3 lines and they should match up here what we saved to our CSV. So very easy to save and import from our CSV files on here. And it turns out df3 also has a to Excel. They actually have a lot of different formats, but old school Excel was real popular for so long, still is. We can go ahead and save it as animal.xlsx. We're going to call the sheet named sheet1, and then I can also do df, we'll call it animal2, and this one's going to come from, and the same format on here. There we go. So we still have our animal xlsx, the sheet1, that's where it's coming from. Index columns equals none. So we're going to suppress the indexing on the columns. NA values, and it'll just assign it's 0 on up on your indexes. So if it says index columns equals none, that's what it does. And then we've added null values because there's null values in here, and we want to just make sure that they're marked as NA. And we'll go ahead and just print out the animal2. There we go. And let's run that. Let's make this. No, let's just do the whole thing. So we'll go ahead and run that. And it probably doesn't help that I completely forgot the read. So animal2 equals pd.read Excel. There we go, Excel. So now we go ahead and run it. And what we expect is happening here. We have the same data frame on here. And if I flick back to my folder, you can now see that we have the animal. One of these is in Excel and one of these is a CSV on here. And so there's our two file types on there. And they have other formats. These are just the two most common ones used, and I don't know how many times I've had stuff from Excel I need to pull out. If you've ever played with Excel, it's a nightmare in the back end because of the way they do the indexing. So this just makes it quick and easy to pull in an Excel spreadsheet. So we looked at two different ways to bring data in and save it to files. We've looked at all kinds of different ways of manipulating our data set and slicing it and creating it for our data frame. Let's get in there for your visualization. Always the big thing at the end, because one, it lets you check to see what you did, make sure it looks right. And then also, if you're going to show somebody else, it makes it very clear what's going on if they see something visual. So this is where a really important part of data science is. So let's go ahead and bring in our tools. We're going to do import numpy as np. We want to make sure we have our ampersand matplot library in line. This just lets Jupyter know that we're going to print it on this page. If you're using a different IDE, you don't really necessarily need that, but this does help it displays correctly in Jupyter Notebook. And if you remember for earlier, we could create a, we're going to call it TS. We're going to create a pandas, which are cute, cuddly creatures, versus pandem, short for pandemonium? No. So we have TS equals PD series, and we're just going to create a random setup of 50. We'll do an index. We'll set it equal to the pandas date range today. Periods equals 50, so the 50 should match. And I want you to notice something here. I did not import the matplot library. Why? Because it's already in there. Pandas already has its built-in connection and interface with matplot library, so you don't have to import it. And we'll go ahead and do TS equals TS dot cumulative sum. We're going to do the cumulative sum. So a little reformatting there, and we'll go ahead and plot it. And let's take a look at what that looks like. So we have a nice graph here. We have the dates on the bottom. We've set this up so we have a nice range between, in this case, -4 to, looks like about 2 maybe, or 1, -4 and 1. So what we've done here, we plotted a basic series, just a single row of data, and we've set indexes on there. But we can also do the whole data frame on there, and let's see what that looks like. So first, let's go ahead and create the data frame. We have here random numbers, so we're going to do 50 by 4. And then we'll go ahead and create columns A, B, X, and Y, just because we can. Index is the ts.index on there, so we're going to use the same index as before, just to keep it nice and uniform. We've already generated the dates to go with it. And then we can do, just like we did with the series, we can also do with the data frame, df equals df cumulative sum. So we're going to sum the whole data frame. And then we'll do simply df plot. And let's push that in, and let's go ahead and run this. And look how easy and quick that was to generate a nice graph with all the different data on there. So we have our shared index, we have the shared columns, and then we have the different data from each one that we can easily look at and compare. So very quick way of displaying data. You can imagine if you were working in, I think I mentioned stock earlier because I've been doing some analysis of stock lately. So you'd have your date down here, and then you would have stock A, stock B, stock XY, whatever it is. And you can put them all on one chart and see how what they look like next to each other. And this isn't too far off from what some of those graphs look like, and this is just randomly generated. So stock has a lot of randomness in it, which is one of the reasons I actually play with it for doing some of my models for testing them out. Now, there are a lot of features in pandas. So we're going to show you one more thing on here. There's some of the things, like I didn't go too deep. We looked at the top two for importing data from a CSV and from an Excel spreadsheet. Showed you how to quickly plot the data. There's more settings in there you can do. We're going to do one more thing down here, and this is kind of a fun one. Change this to a markdown and run that. So how would you remove repeated data using pandas? And this is where you have a data set that comes in, and maybe it's feeding from one location, and instead of noting that it's repeated the date, like, let's go back to stocks. That's a good visual. We have the stocks from the 23rd. And it adds another row, and it's the same row. It's importing the 23rd again and again. So now you have that data repeated 3 times, and you need to go back and figure out how to get rid of it. How do you track that down? So let's start by creating a quick database, or data frame. Not a database. I keep saying database. It's a data frame. And we'll just make this data frame using our dictionary going in. This data frame only has one data series in it, which is fine. So if we do df to print it out, you'll see A1, 2, 2, 2, 2, 4, 4, 4, 5, 6, 7, and so on. And so how would you remove that? Well, there is a neat feature in data frames called shift, along with another feature that lets us select just certain information. And we'll go with the location function. Put that in brackets. Remember that from above, location. And then in the location, let me just spread this out a little bit so it's real easy to read. In fact, I'm going to go upscale on that since we're doing a little bit more complicated here. What you can see on this, on the location, is I have dfa.shift. So this is going to shift up 1 by default. You can actually change this to 2 or 3. You can even do a -1 and it shifts the other way. But it's going to shift up by 1 by default. And it's going to say if that does not equal df of a, then we want that. And if you look down here, we had 1, 2, 2, 2, 2, 2. When we run this logic on here and we do the shift, it now gets rid of all the duplicates. So we went from 1, 2, 2, 2, 2, 4, 4, 5, whatever it was. Here it is, 1, 2, 2, 2, 4, 4, 4, 5, 5, 5, 6, 6, 6, to 1, 2, 4, 5, 6, 7, 8. And you'll see on the index, it just deletes them out of there so the index stays the same. Obviously, you don't want the dates to change if you're working with an index dated setup. So it just deletes those duplicates out of there. This is just a quick way to introduce you to, 1, the fact that you can add logic gates into here. And 2, the iLocation allows you to use shift. So there's the shift function, and then the iLocation selects that based on true or false. Wow, so we've actually covered a lot today in Pandas. We've really covered into the basics of selecting your different series out of your column, out of your data frame, how to index rows, how to slice, how to plot. Hopefully you'll take this beyond that and start combining these different things, and you can create long strings and really explore your data, generate some nice graphs. If you're in Jupyter Notebook, it's a great demo to show others. And I didn't know this about Jupyter Notebook. You can do this in Jupyter Notebook, and then you can download, and I never really looked too closely at all the downloads, but you can download it as an HTML and post it to your blog. So it's got a neat feature in there. But any of this is a really powerful tool. All of this is really powerful tools for doing your data science.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Today we're going to study the matplotlib library and the Python code. So what's in it for you? What is matplotlib library? Types of plots, plotting graphs and subgraphs, adding a graph inside a graph, graph parameters, title, label, legend, line graphs, line types, color and transparency, canvas grid and axis range, 2D plots, scatter, step, bar, fill between, radar chart, histogram, contour image, 3D surface image, and then we'll hit a practice example pie chart. So let's start with what is matplotlib library. Matplotlib library is an open source drawing library which supports rich drawing types. It is used to draw 2D and 3D graphics. And there are so many packages in the matplotlib library, we're going to cover the basics. And there are so many packages that sit on top of the matplotlib library that we can't even cover them all today. But we'll hit the main ones so that you have a good understanding of what the matplotlib library is and what the basics can do. You can understand your data easily by visualizing it with the help of matplotlib library. You can generate plots, histograms, bar charts, and many other charts with just a few lines of code. And here we have some basic types of plots that you can see here that we'll go into. We have the bar chart, the histogram. Boy, I use a lot of histograms in my stuff. A scatter plot, line chart, pie chart, and area graph. Let's start plotting them. And to do this, I'm going to be using Jupyter Notebook. You can use any of your Python interfaces for programming or scripting and running it. Of course, we here really like the Jupyter Notebook for doing a lot of basic stuff because it's so visual. And in our Jupyter Notebook, which opens up in this case, I'm using Google Chrome, you can go up here to New, and we'll create a new Python 3 and set that up. If you're not familiar with Jupyter Notebook, we do have a tutorial that covers some of the basics of that. And you'll look at any of our tutorials. I usually cover a number of them showing how to set up Jupyter and Anaconda. I myself use Jupyter through Anaconda. In fact, let's go ahead and open that up and just take a look at that, see what that looks like. You can see your Anaconda navigator. If you install it, it will automatically install the Jupyter Notebook. And that also installs a lot of other things. I know some people like the Qt console for doing Python or Spider. I've never used them. I actually use Notepad++ as one of my editors. And then I use the Jupyter Notebook a lot because it's so easy to have a visual while I'm programming. And even simple script in Python, I'll take it from the Jupyter Notebook and then do a save as. You can always go under File, and you can download as a Python program. So that will download it as an actual Python versus the IPython that this saves it as. So let's go ahead and dive in and see what we got going here. And let's go ahead and put Matplotlib tutorial. And I'm going to turn this cell into a markdown so it doesn't actually run it. But you can see it has a nice little title there. That's all Jupyter Notebook. And then from Matplotlib, let's import PyLab. Put that back one. And then let's go ahead and just print. We'll go PyLab and the version. Let's go ahead and run this. So we're going to import our PyLab module from the Matplotlib. And we find out that we're in version 1.15.1. Always important to note the version you're in. Probably I was reading an article that said the number one thing that Python programmers struggle with is remembering what version they're working in and making sure that they're going from one platform to the other with the same version. And if we're going to graph things, I think we need some data to graph. So we're going to import NumPy as NP. Now, if you're not familiar with NumPy, definitely go back and check out our NumPy tutorial. There's so many different things you can do with it, dealing with reshaping the data and creating the data. We're just going to use it to create some data for us. And there is a lot of ways to create data, but we're going to use the np.linespace. So we're going to create a NumPy array. And the way you read this is we're going to create numbers between 0 and 10. And we're going to create 25 of these numbers. So we're just going to divide that equally up between 0 and 10. And if we have x coordinates, we should probably have some y coordinates. And we'll do something simple like x times x plus 2. And let's just take a look. We're going to print x and print y. Let me go ahead and run this. And let's see what we got going on here. So we have our x coordinates, which is 0, 0.4, 0.83, etc. And you can look at this as an xy plot. So where we have 0, we have 2. Where we have 0.416, we have 2.17. And just as a quick reminder, we're going to do print np array x comma y dot reshape 25 comma 2. And the reason I want to do this is I want to show you something here. A lot of times a program returns x comma y, and it's an array of x comma y, x comma y, x comma y. And so when you're working with the pyplot, you have to separate it out and reshape it. So if I start off with pairs like this, I can reshape them. If I know there's 25 pairs in there, I can switch the 2 and the 25. And this is kind of goofy, but we'll do it anyways. Reshape. So I'm going to reshape my 25 by 2 back to 2 by 25. And if I run that, you'll see I end up with the same output as the XY, the two different arrays in here. And this is important that we want X and Y separate. Again, that's all NumPy stuff, but it's important to understand that this is a format that Matplotlib works with. It works with an array of X's, and they should match your array of Y's. So each one has 25 different entities in it. And then for our basic plotting of this data, it only takes one command to draw a graph of this data. And so we use our, from up here where we imported PyLab, we take our PyLab, and the key under there is plot for plotting a line. And then we want our x coordinates and our y coordinates. And we'll throw in R. And the R simply means red. So we're going to draw the line in red. Let me go ahead and run that. You can actually switch this around if you wanted to do different. There's B for blue. We have a lot of fun. Yellow. Hard to see yellow. There we go. But we'll go ahead and stick with red. Run. And when you're doing presentations with these, try to be consistent. You know, if the business and the shareholders send you a spreadsheet and they have losses in red, use red for losses in your graph. Try to be consistent. Use green for profit, for money. You don't have to necessarily use green, but it's whatever they're using, whatever the company's using. Try to mirror that. That way, people aren't going to be confused if you switch your data around and every time one graph has red for loss and one graph has blue for loss. It gets really confusing, so make sure you're consistent in your graphs and your coloring. And something to know, because we're going to cover this in a minute, this is your canvas size. So we have a canvas here, and what we're going to do next is we're going to look at subgraphs. Okay? So let's take our PyLab and create a subplot. And one of the things also to know when we're working with the Matplot library, I'm not setting, when I do this, this is my drawing canvas, the PyLab. So once I've imported the PyLab, I'm drawing my images on there. Very important to know. And with the subplot, we're going to give it some different values. And we're going to represent by rows, columns, and indexes. And let's do 1, 2, 1. So it's going to be the first row, second column, and the index is like you can stack your graphs and things like that. We don't worry too much about indexes, but rows and columns. We want to go ahead and use row 1 and column 2. And if we're going to have one object, we should probably have two, but before we do that, we have to plot data onto the subplot. So the order is very important, and we'll go ahead and stick with our x comma y, and let's do this. We're going to add in a third parameter here. Remember we did red? We're going to add shorthand dash dash for dashed lines. So this plots the data into row 1, column 2. And if we're going to do that, let's do another one, pylab.subplot. And if we're going to do row 1, let's do column 2 and index 2. And this time we're going to add G for green, and this denotes a style. And if we're going to set up our pylab subplot, there we go, pylab, we got to go ahead and plot that, pylab plot. And instead of xy, we want y comma x. Whoops, I messed up. This is in the wrong spot. There we go. We'll move that down here real quick because that goes in the plot part. So the subplot tells it the row, column, and index, and the pyplot tells it what data. In this case, we switch them, and the color, and then the style shorthand. Now let's go ahead and run that. And you'll see it takes this canvas, splits it in two, and now we have two different graphs. And we have the red one with dashed lines, and we have the green one, which has the little stars going up. And if we take this, and let's just for fun, let's change this and run that with an index of 1. It puts them both on the same index. It also gives me a warning because it's a strange way of doing two subplots. It's depreciated. There's another way to do it. But most people just ignore that warning because it's not going to go away anytime soon. Now that's using the same setup. What happens if we do, instead of this, let's change the column on here and find out what happens. And if we do the column, it didn't really like that on the setup, it just disappears. So let's keep our column as 2, and let's change the row on the second one to 2, and run that. And you'll see again it kind of squishes everything together and causes some issues. So let's take the index. So they each need a unique index. And you can see here where I made some changes. I said row 2, and look what happens when I change to column 2. So I now have row 2, column 2, index 2. It squished it up here, so you could put another graph underneath is what that does. And there's all kinds of different things. You really have to just play with these numbers till you get a handle on them, because you have to repeat it 164 times according to Cambridge University if it's completely new to you. And you can see right here where, there we go, 3, run. There we go. But you can see it takes a little bit sometimes to play with these and get the numbers right. Oops, I hit the wrong one, that's why. Let's go 3 there, run. There we go. Now it's overlapping, so I have this doubled over here on the right. For now, we'll just go ahead and leave this with the where we have column and row 2 and the two different indexes so they appear nice and neatly side by side. And then, as we just saw, as we were flashing through them, we can put them on top of each other. And let me just highlight that and copy it down here. Paste it down there. And here we have 1, 2, 1. And then we'll do 1, 2, 1 also for this one, and that puts the two subplots directly on top of each other. It gives us that warning, and you can see we now have two different sets of data graphed on top of each other. And you can also see how it did the indexes. Since one of them is from 0 to 10, that's the green one on the x-axis, and the other one is from 0 to 10 on the y-axis. So it took the greatest value of either one and then used those as a shared value. So let's next look at operator description. And we'll go ahead and turn this cell into a markdown and run that so it looks nice. So Fig, and you remember I talked about the canvas earlier. I briefly mentioned it. We're going to look a little bit more at the canvas later on. But that's what the figure is. Fig, we're going to add axes. So we're going to initialize a subplot, add the subplot, in rows, in columns, and all kinds of different things with this that you can do. Let's look at that code and see exactly what's going on. And I want you to notice that there's Fig, which is the actual canvas in the Matplot library, and AX is commonly used to refer to the subplots. So when we're creating subplots, you'll see AX equals PLT subplot. Earlier, we did the PyLab. So let's go ahead and import PyPlot from Matplot library, and we're going to do it as PLT. You'll see that a lot. That's really the standard in the industry, is to call it PLT, just like Pandas is PD and NumPyArray is NP. Certainly you could import it as whatever you want, but I would stick to the standards. And we're going to do the same graph as we did above with the PyLab, but with the PLT. So if it looks familiar, there's a reason we're doing this, because we want to show you how the figure part works and working with the canvas goes. But we're going to do the same plot as we did before, and we'll call it Fig, and we're going to set that equal to plot figure. So there's our figure or our canvas on there. And let's create a variable called axes, and we're going to set that equal to fig.add axes. And in this, we're going to control the left, right, the width, the height of the canvas from 0 to 1. And so we can go ahead and I'm just going to put some stuff in there. I got 0.5, 0.1, 0.8, 0.8. So when you're looking at this, this is a 0 to 1, or you could say 50%, 10%, 80, 80%. But it's a control. It's going to control your left and your right, along with the width and the height. So the width and the height, we're going to use 80%, and we're going to have like a little indent on the left and the right. And this should look familiar from above, axes.plot, x comma y, and then let's give it a color. How about red? Since we're recreating the same graph, let's keep it uniform. Oops, and it helps if I use AXIS instead of AXES. I don't know where that came from. But this looks identical to the one we had up above. So here's our axes plot, x comma y of red. Same graph, same setup, but this time we've added a variable equal to the figure.addAxes. So our plot figure is our canvas, our axes is what we're working in, and then our axes.plot x comma y. And again, we can draw subgraphs. We put that down here. Just like we did before. And a little different notation here. We're going to have fig comma axes equal plt.subplots. And in here it's going to be the number of rows. We're going to do one row, and columns equals 2. So if you remember before, that's what we did. We had one row with 2 different graphs on it. We're going to do the same thing, but note how we did this. Here's our figure, or our canvas, and our axes. We're going to create actually 2 different axes. We're going to create row 1, column 2. And so axes is an array of information. So we can simply do let's do ax in axes. And this will now look familiar, ax.plot. We're going to do x comma y. We'll go ahead and make it red. Keep everything looking the same. Remember, nice uniform graph, so everything looks the same. And if we go ahead and run this, you'll see we get 2 nice side-by-side graphs. So just as we had before, the same look, the same setup. And just for fun, let's change in columns to 3. We'll run that, and now you'll see we'll have 3 on there. And let's see if we make it a little bit more interesting. We'll do in rows equals to 2. And you can see down here we're going to get an attribute error because it's trying to scrunch everything together. So it does have a limit how much stuff you can put in one small space. That's important to know. You can fix that by changing the canvas size, which we'll look at in just a minute. And there's other ways to change it on here. But here we go. We can do in rows 2 and columns equals 1. You can see 2 nice images right above each other. We'll go back to the original. 1 row, 2 columns, side by side, left to right. And we can also draw a picture or graph inside another graph. And that's kind of a fun thing to do. It's important to note that we can layer our stuff on top of each other, which makes for a really nice presentation. So let's start by fig. We'll create another figure. So we're going to start over again with our canvas. We set that equal to plt.figure. So there's our new canvas. And let's do axes. We'll call it axes 1 and 2. Axes 1 equals fig.add axes. Remember this from earlier? And this here, similar numbers we used before, saying how big this axis is, this figure in the axes is. So this is going to be the big axes. And let's do axes 2 equals another figure add axes, and then 0.2, 0.5, 0.4, 0.3. And if we're going to do this, they need data on them. So let's go ahead and plot some data on our axes. So axes1.plot. And we'll make this simply x comma y comma, make it red. And then let's go axes 2 dot plot, and let's reverse them. Y comma X comma green. There we go. Doing what I told you not to do. You shouldn't be swapping axes around and plotting your data in 5 different directions because it's confusing. But let's go ahead and run this and see what this looks like. And then let's talk a little bit about this. We talked about the 0.2, 0.5, 0.4, 0.3. And let me just grab the annotation for that. That's left, right, width, and height. So we have in here that this is going to be left, right. So here's our left is 0.1n, 0.5. And you know what? Let's just play with this a little bit. What happens when I change this to 0.1? Moves it way over to the left. So there's our 0.1. So we can make this 0.4. Run that. There we go. So you can see how you can move it around the branches on here. 0.2. 0.5 is the left, so that's our right. So let's see what happens when we do let's make this 0.1. And that actually is, they had it down as left, right. I thought this was wrong. It's actually how far from the bottom. Let me switch that on here. Bottom. There we go. So we had here on this. We can go ahead and put that back to 0.5 and run that. And this is 0.3. Let's make this 0.3 also. And that is the width. And then, of course, there's the height. We can make that really tiny. Actually, let's do 0.2. And let's run that. And you can see it changes the height on there. We can make it even smaller, 0.2 by 0.2, and as you can see, you can get stuck playing with this to make it look just right. It can sometimes take a little bit. Certainly, once you have the settings, if you're doing a presentation, you try to keep it uniform, unless it doesn't make sense for the graph you're working on. Try to keep the same colors, the same position, and the same look and feel. And I mentioned earlier we can adjust the canvas size. So this is from earlier, I just copied it down below. We're going to replot the same data we've been looking at. And what we can do is we can change the figure size to 16 by 9. And let me run that and show you what that looks like. So it fills the whole screen. And then if you are, normally when you're working on the screen, you don't worry too much about this. But we can set the DPI to 300. Run that. There it goes. This is your dots per inch. And if you are doing an output of this and you're printing a hard copy, you want the higher quality. I would suggest nothing under 300 if it's a professional print. You might get a little less than that, but whenever I'm doing professional graphics and printing them out on something, 300 dots per inch is kind of the minimal on there. You can go a lot higher too, but keep in mind the higher you get, the more memory it takes and the more lag time and the more resources you use. So usually 300 is a good solid number to use in your dots per inch. And you can see it draws a nice large canvas here, which is 16 by 9, and then the DPI is 300 on here, so it's a little higher quality. And just out of curiosity, I wonder how long it takes to draw something double that size, 600. And you can see here where at 600 DPI, it's going to take a while. There it goes, just because it's utilizing a lot more graphics on there. And let me just go back to the 300. Now let's do a 100. You're not going to see a difference on this because it is web-based graphics are pretty low. And up here you saw I did this with the plot figure. This works the same if I do figure axes subplot, figure size, and then we'll go ahead and do axes plot x comma y comma, we'll stick to red. Let's go ahead and run this. And you should get almost the same thing here. Here's our axes on the subplot on here with the fixed size and the DPI. Let me take this all out. Let me just remove all that real quick. Run it again. There we go. Now we're back to our original figure. And let's look at some of the other things you can do with this. One of the things we can do is we can set a title for the axes. So axes set title. You'll see right here, since I put this on the axes, it's the main title for the whole graph. And if you're going to have a title, you should also label. So we can label our X label, and we can set our Y label. In this case, we're just going to call it X and Y. Keep it nice and uniform, and if we run this, you'll see that we've added a nice X label and Y label. Whoops, where'd they go? And it turns out in this environment that you have to put it before the title. So let me go ahead and put it before the title. And there's our X, Y, and let me run that. And of course, we can also do up our size a little bit so you can see what's going on a little better. So here we have X label X. If you come down here, you'll see our X label and our Y label. We can, of course, change this to X label. You can change this to Y. It can be whatever you want on here, of course. And our title graph. There we go. Run. So here we have our title graph, our Y label, and our X label all set up on our nice little plot. And then before we move on to the next section, let's do one more thing on here. We have a thing called the legend. And we're going to set our AX legend, label 1, label 2 up here. That's the format for it, but let's go down here and actually use it. I'm going to do two different plots. We're going to have axes plot x by x times x squared and x cubed. And if I run this, you'll see it puts two nice graphs on the setup on there. But it's nice to have a legend telling you what's going on. So for the legend, we can actually do axes, since we have the two plots, legend. And on here, we've created an array. And we have y equals x squared, y equals x cubed. You can actually put this as whatever you want. Those are just strings. And then location 2. And let's go ahead and run this and see what that looks like. And you can see it puts a nice legend on the upper left-hand corner. Location 2. We can do location 3 and run it. And it drops it down to the bottom. Location 1. I can't remember where that's at. There we go, upper right. So each one of these is a number that refers to the different locations on the screen. 0, kind of have to play with them or look them up to remember where they're at, but they do work. It just kind of moves around depending on where you want your legend at on there. So on this section we cover the title of the graph, the Y labels, and legends. We're getting into starting to look really fancy here. So we now have something we can actually put out. You'll see the title of the graph looks a little fuzzy. So I might, in a web setup, put the DPI up a couple notches. Maybe put it at 200. 100 might work fine. Just so you know, that's something to notice on here when you're playing with these different things. We had our subplots DPI equals, let's do 200 to see what that looks like. So you can see it now is a lot clearer. It's also larger, so it's a nice little feature you can throw in there with your DPI dots per inch. So the next section is, let's look at some graph features. We're going to look at line color, transparency, size, and a few more things on here. And, oops, I forgot the main title. So we have our figure and our axes equals our plot and subplots. And I'm going to go ahead and do a DPI equals 150 so the graph comes out nice and large and easy for you to see. And let's go ahead and do 3 plots on here. We'll do x by x plus 1, so it's just going to be a straight line. Plot x plus 2, and axes dot plot x plus 3. This looks like we're doing nearest neighbor setup, or showing how it located data and putting your lines on there between the nearest neighbors. There we go. So it draws a nice little graph with 3 lines on it. One of the things we can do is we can control the alpha on this. Oops, and you can actually see when they did these lines, it automatically pulls in different colors for your setup. So there's some automatic things going on in there. And a lot of times we do that comma R, where we're going to do color equals red, another notation on here. Let's go ahead and run this. Now we have a bright red line down there. And with the Matplot library, you're not limited to red. You can also use one of the many different color references, as you see here, with the # 1155DD, which is just blue. And we can do the same thing with another color on here, which turns out to be green. And I can just as easily do this. Green, blue, oops, there we go, blue, and run that. And you'll see here we have red, blue, and green. And what I want to do is I want to make this, we're going to set what's called the alpha on this. And we're going to set this equal to 0.5. So this is halfway see-through when I run this. And it's almost going to look pink because you can see through it. And let's change this just a little bit, just to make this kind of fun. Let's square it. There we go, run it. So now we have this nice square that comes up. And you can see when it crosses it, because I plotted these 2 lines after it and they have no alpha, the red is behind those lines, or in this case pink, because we did the alpha halfway through. So let's go ahead and do this. Alpha equals 0.5. And, oh, you know what? Instead of squaring it, let's take it to the 0.5 power. That'll be kind of interesting to see what that does. We'll just go to keep it squared. There we go. And run that. And let's go back and look at this where it crosses over. And the first thing you'll see right here is on the blue, it's kind of light blue now. You can see how the 2 colors add together. You get almost a purple on there. So I can clearly see where the red crosses the blue line. And then the green just blanks it over because I didn't do any opaqueness, no alpha on there. So this is great if you have lots of data that crosses over and you need to be able to track those lines better. And we'll go ahead and do this 0.5 and we'll run that. Oops, I did equals 0.5. Let me go ahead and run that. And so you can see right here now you can easily see the red line, how it crosses the green and the blue down here. And if we want to, we can do this as the default is 1, is solid. So we can change this all to 0.8. Let me just do that. Oops, 58.8. There we go. Run. Oops, I must have hit a wrong button there. Let me try that again. I accidentally got rid of a bracket. And let's go ahead and run that. And we come down here and look at this. You can still see where it passes behind them, but the green dominates and the blue dominates because we're now at 80% instead of 50%. And you can do less. That's kind of fun, although at some point the lanes kind of fade. So 0.5 is usually the best setting on there. We have a nice pastel here at 0.3, and you can easily see where they cross over. And just like you can play with the colors, we can play with line width. And let's try DPI 100 and see what that looks like on my screen. Equals 100. And we'll go ahead and just take our AX plot. Let's do 4 of these lines just so you can see how they look next to each other. Real quick here. There we go. And if I run this, they should all appear the same. It automatically does different colors on there. So let's do color equals blue. Forgot my quotation marks. There we go. And we'll go ahead and just make these all blue, just for purposes of being nice and uniform. And then what I want to do is I want to do the line width. Line width equals 0.25. And let's just copy and paste that down here. Let's do equals 1, about 1.5, and let's do just make this equal to 2. Let's see what that looks like. And when we do that, you can see it goes from a very thin line, a 0.5, a 1, our 1.5, and 2, which is twice the width of the 1. And if we're going to do different sizes, we had different colors, we had our alpha scheme. Let's take this whole thing here, let's paste it down here and do another one. But instead of line width, let's look at styles. And something to note here, you can actually abbreviate this with LW. So line width can also be let's just do everything 0.2. And let's set up a line style. We'll do the first one dashes. And let me just paste that down here, so I'm not doing a lot of extra typing. There we go. Take this out. So we have our dashed. We can do a dash dot. Oops, let's do the dash dot here. And a colon here. There we go. And there's a lot of different options. We'll look at a few more as we go down for different ways of highlighting data. But when you look at this, we have everything as a line width of 2, and now we have a straight line, we have a dash line, or a dot dash, and a dot 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 line. And then another thing we can add on here is we're going to do, here's our X plot, and we did X, let's do X plus 4, so it goes right on the top. We're going to do color black, line width 1.5, so it's a smaller line. And we're going to take the line and we're going to set dashes. So look how I've changed some of the notation here for my line and my ax plot. So I can set my line comma equal to ax plot. And then I can change the line settings this way. And when I run this, run that on here, you'll see the 5, 10, 15, 10 creates a series of dashes that are varied in length. In this case, they alternate between a short dash and a long dash. We can play with these numbers. Curiosity always has me what happens when you play with the numbers. Just to see what they look like, let's do this. Let's paste this down here. I'll do 2 of these just because they're kind of fun to play with. And let's change this from 10 to 3. And we're going to change this one from 15 to 4. And let's run that. And you can see the differences in the lines. Oops, a little bit confusing on there, because I forgot to change the lines are all on top of each other. So let me change that really quick here. And let's run that. And now you can see here's our original dash line alternating. When I change these numbers on the second one, the very end value to 3, you can see now we have dashes of 5. Let's see, I'm going to guess this is a dashes of 5, skip 10, dashes of 15, skip 3, and then it goes back to the beginning. Dashes, 5 dashes, skip 10, 15 dashes, skip 3. And of course the last one we just switched up a little bit. It looks a lot more uniform because I'm using 2 sets of 10. Or if I did something like this and changed it to 30, it really becomes pronounced as far as the distances between them. And instead of 4, let's put 30 here also. 30 by 30, there we go. Really pronounced on that one. And let's look at one more important group for plotting our data. And in this, here's our plot we started with the x plus 1, x plus 2, x plus 3, and did it in blue on this one, 3 or 4 different blue lines. And this property, we want to add the actual plots, so you can see where the plots are on the graph. And for that, we might have marker equals O. And if we run this, You'll see it puts a dot for each of these, and there's 25 dots because we have 25 x values. So we actually have 0, and each of the different values of x, y are then plotted here with the dots. And we don't want to just limit ourselves to dots. We can also do plus sign. That's another option. Dots is most common. I actually like the dots the best. If we do the plus sign, you can see it puts a nice crosshairs or plus sign on there. And we can do a marker. There's a number of different markers you can use. And I think this one was it. S is another one, which is a nice square. And that's actually a good one, S for square. O for period. Okay, that's just kind of weird. So you can see that probably on these markers, another one is number 1. So if we run that, you'll see we now have these little hatch marks. And let's just go with the O on this one. By the way, this works with square really nicely. Some of the stuff we're going to do here on just a second. Let's do marker size equals 2. And change that to 5 and run that. And you can see here it puts a nice little tiny dot versus this size dot here. And this is interesting because it said 2. I thought it would be bigger. But if you do 0.5, it gets even smaller. And let's just do 10 to see what that looks like. Run. That looks huge. So marker size, a lot of these are dependent on the DPI and the setups. There's things that switch around as far as the way the size shows up. You got to be a little careful when you change one setting, it can change all the other markers. And then let's take our square on here, and we had marker size, so we also have marker face. We'll set that equal to red. Of course, I may change so it's up 1 notch. We'll run that. Whoops, must have mistyped something on here. And I did, it's marker face color equals red. And so when I run that, you can now see I have the squares on there with the marker face color. Of course, we can mix and match these. Come down here and we'll make this, let's make this plus 7. And we'll make this size 15. Marker face color equals, and we'll do green, just because. There we go, run. Very hard to actually see what's going on there. Still 25 dots, they kind of overlap. As you can see, they print them over each other. And of course, if we really wanted to make it look horrible, we could just make that really huge. Generally though, you want something a little bit smaller and cuter. We'll just try doing it this way. There we go. That's too small to even see the face. So 4, you can start to see the face on there around 4, and maybe on 8. 8 might be a good number for this. There we go, 8. Again, that all just depends on what you're trying to show and display. So we've covered a lot of stuff here as far as our lines. We've covered opaque with our alpha setting on there. Give us some nice pastels. You can see how they overlap and how they cross over. We covered the line width, different size on there, different formats for the line itself. And these are all, you can combine all these. So you can have our line width equals 2, line style equals dash. You can bring this down here also to the markers. And then we added markers in, just standard circle, a plus sign, the square, a little tick, which uses a 1. Then we add a marker size and a marker color face, and we combine those. You see we get a nice different series of representations. We also briefly mentioned color, where you didn't have to use, like in here we used color black. Someplace up here, I'd have to find it, we use the actual number for the color, as opposed to, I changed them to red and blue. So you can get very precise on the color if you have a very specific color set that you need to match your website or whatever you're working on. All of those are tools in the Matplot library. So we have one more piece to formatting the graph, so we want to show you, and then we have 2 big sections. We're going to go over the different graphs that they have along with a challenge problem. So let's go in the last section we're going to look at is limits. We're going to limit our data. So this first part I'm just going to paste in there. We're going to create our subplots 1, 2. So 1 row, 2 columns. We're going to do a figure size of 10, 5. This should all look familiar now since we've done a number of them. And we're going to go ahead and plot, and this is an interesting notation you should notice here. Our axes 0, so 1 we've used, instead of, you can just iterate through them, but they're just an array, so it's an array of 0 is still the axes of the first axes out of 2. And we're going to plot x, x squared, x cubed, line width 2. So we're going to go ahead and just plot 2 graphs right on top of each other without doing multiple plots on here. And we'll set the grid equal to true on here. Let's go ahead and run that. And you can see here are 2 plots with the x value going across. And I'm going to do something similar. And by the way, so you can just, if you look at it, you can see the grid on there. That's all that is. easier to spot the data going across. We're going to take the same data for axis 1. So we have our plot of x, x squared, x, and x cubed, line width 2. And this time we're going to take our axis 1 and do y limit. It's actually set underscore y limit. This is the y-axis, so it's going to be an array of two values. And we'll do 0, 60. I'm just making these numbers up. The guys in the back actually made them up. I'm just using their numbers. And we're going to set the x limit. And we'll set the x limit as, don't forget our brackets there, 2, 5. So it's the same data going in, but we're setting a limit on it. And let's go ahead and run that. And let's see what it comes out of. And here we have the y limit 0 to 60. So we're looking at just the lower part of this curve here up to here. And we have the x limit 2 to 5. So that starts right here at 2, and you can see very different graphs. This is kind of nice because you could actually put one of these on top of the other if you wanted to draw focus to one part of a graph. Remember how we did that earlier, one inside the other? But just a quick note, you can easily limit your graph and kind of reshape the way it looks quite easily. And we can also add that grid down there if you want a grid. We'll run that and add the grid in there. Whoops, I guess you have to do the grid beforehand. Switch that. There we go. Sometimes the order on this is really important, so you may double check your order when you're printing these things out. It also helps if I change it to 1. So in this case it might not be the order. I wonder if we'll go back here as 1. There we go. So it doesn't matter the order on grid. But you can set the grid for easy viewing here. Nice setup on there. But you can see how we can limit the data. So let's start looking at some other 2D graphs and make this cell a markdown. So when we run it, it has a nice pretty title to it. And let's go ahead and create some data with an NP array. We'll do 0 to 5 on here. There we go. And let's look at 4 common graphs. We'll put them side by side. So we'll do a figure. Our axes equals plot, subplots, 1, 4 columns, and then figure size. Hopefully it'll fit nicely on here. It seems to do pretty good on here. And I'll go ahead and just run that since we're in there. Run. You'll see I have 4 blank plots on here. And we'll start with axes of 0. Let's set title. And we want this to be a scatter plot. A scatter plot just means it has a bunch of dots on it. So here's our axes of 0 dot scatter. Easy to remember. Scatter a bunch of plots on there. We'll do our n, or we can do x or n. There we go. And let's go ahead and do axes set title scatter. Oh, already did that. We're just going to do scatter. That's how you do it on there. That is how you create a scatter plot, simply with the scatter control. And we'll do, let's do the variable x plus, let's throw some randomness in here. Usually scatter plots have a lot of random numbers connected to them. That's why they do them on there. And so the bigger the x gets, the bigger the randomness, so 0.25 times the randomness. And what we should end up down here is with the scatter plot. And you can see as you go up, it just kind of has some random numbers and moves up and down the line. But plots just the points. So if you remember from back up here where we did marker, this is plotting basically just the marker. So it's a scatter plot. Probably less used is a step plot. So for axis 1, we'll go ahead and do a step plot so you can see what that looks like. And this time I'll use our n value instead of x. We generated that n value up here. And so for this we have n times 2, our n squared, n times 2, n squared. Line width equals 2, and if we run that, it creates a nice step up. Let's see, so we've got a scatter plot, we've got a step plot. Let's do a bar plot. And we'll use the same formula, n squared, alignment centered, because you can have them to the left or right, width 0.5, and alpha, if you remember correctly, that's how opaque it is. Let's see what that looks like on there. So we have some nice, you can see here a nice bar plot. It should look very similar to the step plot, but colored in. And we can change the width. Let's see what happens if we do 0.9, run. And if we take width out completely, run that, you can see it starts coming together on there. And we can change the alpha. We can take the alpha out too and run that. So now you have the solid colors. And if we take out the center and run that, everything, you really can't see the shift on here because that's actually the default on this. But these are common settings for the bar graph. Let me just put them back in there. There we go. Alignment, center, and alpha. Now, I can't say I've used a step graph very much. There's certain, I guess, domains of expertise that require a step graph. But the scatter plot and the bar graph, very common, especially the bar graph. And we'll look at histograms here in just a minute. So I use histograms a lot, especially in data science. But this is nice if you have very concrete objects. How many people are wearing yellow hats? That kind of thing. But if we're going to do that, let's go ahead and do the last one, which I see a lot more in the sciences. I'm certainly using the data science, but more like for mapping. I saw a publication on solar flares, and they were discussing the energy, and so filling in the graph gives it a very different look. So we're going to do the fill between. And it's just like you think it'd be. It's fill between, but with a underscore between them. And we'll do x and x squared and x cubed. And we'll do color green and alpha again, in case you had other data you wanted to plot on there. You can see it forms a nice squared coming up here. And also, if you look at the bottom one is your squared value, the upper line is your cubed value, and then it fills in everything in between. If you remember from calculus, this would be if you had like a motor and efficiency, they would talk about the efficiency going up and the loss, and you're looking for the space or the area between the two lines. So it gives you a nice visual of that. And let's look at a few more basic two-dimensionals. So we're going to have our figure size on here. We're going to do a radar chart. To be honest, I've never used a radar chart in business or in data science. I have to find a reason to use one now. So the first line for doing a radar chart, we have to add axes into the figure. And with this actually creates our, let's run it so you can see what it creates. It creates a nice, looks like you're on a submarine and you're tracking the hunt for red October or something like that. And it needs all of these. The polar is the fact that we're doing polar coordinates. 0, 0.6.6 has to do with the size. If you take out any of these things and run them, you get just a box. If you take out the other half, you pretty much get nothing in there. And if you change these numbers and change them a little bit, you can see it gets bigger. They had 0.6 on here. I'll go ahead and leave it as 1 because that's just kind of fun. But that's all about the size on here, the height and the width. And then let's create some data. T equals NP line space. And this is 0 to 2 times NP times pi. So if you remember, that is the distance across, and we're going to generate 100 points. So this is just a thing of data we're putting together. Then we can simply do an AX.plot. And in this case, let's do T comma T, which would be a diagonal line on a regular chart. And we'll give it a nice color equals blue. And line width equals 3. Let's see what that looks like. And we can see here a spiral coming out. And remember, this would be just a diagonal line on a regular chart. What happens if we take this and instead of T times 0.5, there we go. And you can see it slightly alters the way it spirals out. We could do T times 2. Spirals out a little quicker. So it's kind of just a fun. Like I said, I've never used a radar chart. It's a column. But you can always think of radar in a submarine. Kind of looks like one of those, or in an airplane. And none of this would be complete if we didn't discuss histograms. Oh my gosh, do I use a histogram so much. And we'll use our NumPy that we have set as NP to generate, it looks like we have 100,000 variables we're going to set equal to n. And of course we create our figure and our axes. Subplots 1, 2, figure size 12, 14. So we're going to look at 2 different variations of the histogram. And we'll set a title, default histogram, set our title there. And then this is simply hist for histogram, and we'll just go ahead and put in our n in there. And let me run this so you can see what that looks like. And let's talk about what is going on here. So we generated an array here of data, 1,000 random arrays. It looks like they're mostly between -4 and 4, and then it adds up each one. It says 0, you have 35,000 that are 0, so that's what's most common on here. And we have 20,000 that are somewhere in this range right here between the -2 and, well, it looks like 1 and -2. And somewhere between 0 and 1, there's 30,000 numbers. So all this is saying is this is how common these variables are. And this will point you in so many directions when you're looking at data science to go ahead and run your histogram. So you should always have your histogram, and you can always put limits and all the other different things on your array, just like you did on the other graphs on there. And then we're going to do a cumulative detailed histogram. And all it is a histogram. Let me just do that. And we set cumulative equal to true and bins equal 50. And I really want to highlight the cumulative equals true is important. But we can now choose how many bins we have. In the first one, it kind of selected them for us. In this case, let me go ahead and run this, and you'll see it has the prints the data out for us. And here's our, whoops, must have missed, oh, there we go. It doesn't help that I put it over the old one. There we go, okay. So now you have your default histogram, and then we have a cumulative histogram, and we should have 50 steps in there. And let's just find out if that's true, not so much by counting them. I'm not going to count them. If you want to, you can count them. Let's just change it to 10 and see what happens. And we see here we have now 10 counts of that. And we could set that for 5 and run that. And then we have our 5 on there. And we go ahead and take the cumulative equals true out, just so you can see what that looks like. And let me run that on here too. That looks just like it did before. I think there's what, 1, 2, 3, 4, 5, 6, 7, 8. They have 8 different bins on here, is what the default came out of. Put that back in there, run. And so now it should look almost identical, and it does. And then we can put the cumulative back in, see what that looks like with the cumulative. And run that. And we can see how that shifts everything over and has a slightly different look. Wait, it shifts it all to the right? No, it doesn't actually shift it to the right. It's cumulative, so it's the total of the different occurrences. And so what that means is, like, if you consider this like for the year of rainfall, we have like day 1, you had a little bit of rain. Day 2, we have more rain. And so if you look at the number, this is 100,000, 35,000. So it's a cumulative detail, the histogram, the occurrence as it grows. And rainfall is a good one, because that would be a cumulative histogram of how much rain occurred throughout the year. And we're going to look at 2 more graphs. We've already looked at a bunch of them. We looked at our radar graph. We've looked at scatter, step, bar, fill in, basic plots. We've looked at different ways of showing the data. You know, we can increase the size of the line, the look, the color, the alpha setting. So let's look at contour maps. Just put that in there. There we go. Draw a contour map. And before we draw a contour map, we need to go ahead and create data for it. And if you have contours, your data is all going to have 3 different values. So let's go ahead and create the data here. We have our, you'd import your matplot library, your numpy, so we have our numbers array. And we'll import matplot.cm, and that's your color maps. So you have all these different color maps you can look at. There's like hundreds of color maps. So if you don't want to do your own color, you can even do your own color map. They're pretty diverse. And of course our PLT, our pie plot. And to generate our different data, we're going to create a delta 0.025, and we'll start with X. And we're going to create an array between -3 and 3 in delta increments of 0.025. And we'll have our Y, we'll do something similar, and then we'll create our XY into a mesh grid. Again, these are all numpy commands, so if you're not familiar with these, you'll want to go back and review our numpy tutorial. And we'll do an exponential on here, -x squared minus y squared for our z1. We'll do a z2, so we have 2 different areas, and z equals z of 1 minus z2 times 2. So we've created a number of values here. And let me go ahead and run this, and let's plug that in so you can see where those values are going. So once we've set these, we're going to create our figure and our x from our PLT subplots. We're going to create the variable CS. And this is going to be our contour. So right here, CS is our contour surface. And we're feeding it X, Y, and Z. And if you remember, X, Y we created as our X and Y components using our mesh grid. And you know what? Let's do this. Just because it's kind of good to see this. Let's go ahead and print X. And let's print Y. And I always like to do this when I'm working with something that's either is really complicated, in this case is what we're looking at, or you don't understand yet. So we've created a mesh grid. We have X, Y, and when we're done with this, we end up with, here's our X, and this set of values, and our Y, so these are X and Y coordinates. And then we've also created Z based on our X and Y. So we have X, capital Y, and capital Z as our 3 components. X and Y being the coordinates, while Z is going to be our actual height, since we're doing a contour map. So we created our contour map from our X, Y, and Z coordinates. We want to go ahead and put in a C label. Maybe we want to go ahead and do a title on here. We'll put that in our set title, and this is a contour. There we go, contour map. And let's go ahead and run this and see what that looks like. And you'll see we generated a nice little contour map. There's different settings you can play with on this, but you can picture this being you're on a mountain climb, and here we have a line that's represents 0, maybe that's sea level, and then moving on up you have your contours of 0.5 and then -1 and different setups, little hills. I guess if it's minus, that's like a pit. So I guess you're going down into a pit at -5 and -1. And on the other side, you can see you're going up in levels. So here's a mountaintop, and here's like a basin of some kind. And in data science, this could represent a lot of things. This could also be representing two different values and maybe profits and loss. I don't know if I'd ever really do that as a contour map, but I'm sure you can be creative and find something fun to do with a contour map. And then we're going to look at one last map, which is the 3D map. And those can be really important as a final product because they can show so much additional information that you can't fit on two-dimensional graphs. There we go. Draw a 3D image. And so we're going to import from our MPL toolkits the mplot 3D and the axes 3D. We're going to import axes 3D. This is what's going to let us work with the 3D image. And this should look familiar. We're going to create another figure just like we did before. Figure size 14 by 6. That's a good fit on the screen. We'll go ahead and run that. So we have our figure, and let's go ahead and take our x, and we're going to set that equal to fig.add_subplot. That should also be familiar from earlier. And we're going to work with, this sets the settings for the projection. And we're going to use 1, 2, 1 projection 3D. And we'll see what that looks like in just a minute. And we just created some three-dimensional data here before, where we had X, Y, and Z, capital X, Y, and Z. So we're going to reuse that data. We're just going to use that since this is also a three-dimensional image. So let's use that for a three-dimensional graph. And we simply do AX plot underscore surface. And our capital X, capital Y, capital Z, so there's our data coming in. And we're going to add some settings in here. We're going to do R stride 4, C stride 4, and line width 0. And I'll show you what that is here in just a minute. Let's go ahead and run that so we can see our graph. And of course it helps if I don't add an extra comma in there. And you can see it generates this really beautiful three-dimensional graph. So let's take a little bit time to explore some of these numbers we have going in here. We have the R stride 4, the C stride 4, and the projection 3D. Projection 3D is the important one because that's telling us that this is a 3D graph here. So what are these first numbers? 1, 2, 1. Let's just change one of these. I'm going to change this to 5, and it's going to give me an error. Let's change it to 1. And that didn't work. Let's change this middle one to 3 instead. And you're going to see how it starts reshaping the size and how it fits on the screen. And we'll change the first one to 2. We'll run that one. And again, it's changed the dimensions and the size and how it fits on here. Play with these numbers so you get a nice look and feel for it. Part of it is the tilt and the angle. We'll do 7 on this one. There we go. You can see it really shifted it there. But again, that changes the size and how it fits on the canvas. But we'll leave it at the 1, 2, and just so you get a good look at what we're talking about here, this is column width and index from before. If we do 1, 1, 1, you can see that it now spreads it out all the way across. It uses the whole setup on there. So this has to do with the size and how big you want it to be. Now, there's one term that we didn't cover in this yet, but we've used it throughout the whole setup. And I'm just going to type that down here, even though we're not going to go into detail, and that's the term heat map. You might see that is kind of starting to lose ground as far as a common reference, but there sure are a lot of people who still talk about heat maps. What is a heat map? Well, it is simply a color map. That's all it is. So if you ever see the term heat map, that refers to the fact this is in different colors representing different heights. That one isn't a heat map, but you can see up here we switched into, let me go back up here, here we go. This one has different colors for the different values. A lot of times you'll use, like instead of X and Y, you might do a heat map where you have a fourth value, and the fourth value represents the color. And so you'll see this 3D image in a nice colors represented by a heat map. That's all it is. So if you see the term heat map, that only means we're plotting some of the data in color to make it stand out or to give it a fourth dimension in this case. So we've covered a lot of things on Matplot, and that brings us, covered all the basics, so that brings us to practice example. And this is going to be the challenge for you. And let me go ahead and change our cell type markdown and run that so it looks pretty. Practice example, write a Python program to create a pie chart of the popularity of programming languages. Okay, excellent. And if you're going to have a challenge, we need some data. And I'll just throw in import our matplot library at the beginning. You should do that automatically. And so for our data to plot, we're going to have our languages. We're going to have Python, we're going to have Java, PHP, JavaScript, C#, C++. So those are 6 categories. And then we have our popularity. Oops, misspelling there. Popularity. We'll give the first one 22.2%, Java 17.6%. And I don't know if these are real numbers they pulled. My guess is that they might have just been made up, because I don't know if Python's really that much more popular than the other ones. Maybe specific to data science, because Python's very popular in data science right now because it has so many options. The only other program that's highly used and exclusively for data science is R. So Python's big, and Python also does a lot more. It's a full programming language, where R is primarily for data science. They didn't even put R in here. So we have Python, we have Java, we have our PHP, and you can see the different values they've given it, or different percentages. And I did add these up. It does not add up to 100%. It adds up to 71% or something like that. And then we're going to give colors. And we've chosen, these guys in the back brought in these colors. I'm not sure what these colors are. We'll find out in a minute, so it'll be exciting. But you can see they're using the actual color values you can pull off of a color wheel or something like that. You could have just as easily done blue, red, green if you're too lazy to pick the exact colors. And then let's go ahead and solve this and see what we got here. We're going to do something a little fancy just because we can. The first thing we're going to do is we're going to use a variable called explode. And you'll notice that there's 6 variables in here, so that matches our 6 different categories. And the first one we've done is 0.1 and then 0, 0, 0, 0, 0. 0.1, when we put this in here under the explode in the plot, it will actually push that square out. So it's a really cool feature to highlight certain information on a pie chart. And this is simply plt.py. And we're plotting popularity. There we go. And before we add in all the really cool settings for this, let's go ahead and run it. And you'll see we generate a nice flat pie. Not too exciting there. And then we'll go ahead and put in all the extras. I talked about explode, where we can explode one of the values out. So here's our explode equals explode. Labels is languages, because we want to know what the different colors mean. Here's our colors equals colors, our auto picture. And this is standard print format. So that's a Python setup on there. And that's just going to put the value on the pie slice. And then we're going to add shadow, because it just looks cooler with a shadow. Gives it a little 3D look. And we'll do a start angle of 140. Let's go ahead and run this and take a look and see what comes out of that. And look how that changes the whole setup. So here's our labels. There's our value we put on there. There's our slice that's pushed out. There's our shadow, a 3D effect. And then we started at 140. We could also rotate this. Let's just do this angle 90. And if we run it, you'll see the blue pie slice has moved up a little bit. We could actually let's just take the whole starting triangle out and run. It'll default to 0. And this is what it looks like if it defaulted to 0. So depending on where you want the highlighted slice to appear, usually you want that to appear on the left because people read left to right. And so it draws a focus onto, in this case, Python and how great Python is. I'm a little biased. We're teaching a Python tutorial, so it should be understandable that we're looking at Python. And one last reference before we close. You can go over to the matplotlibary.pyplot setup, and if you go underneath the different functions on there, you can look this up on their website. You'll see a full list, and this is why it's so important to go through a tutorial like this, because this list is just so massive. I'm trying to figure out, like, here's our bar plot. There's a bar H. You can add barbs. There's a box plot we didn't cover. C labels, a totally different kind of for your contour plot you can set up in there. If you go down here, we have our figures we used on there. We showed you the basics of how to do the figure. You'll see some closer references on those. There's a histogram down here, HIST. There's also the hist2d, makes a 2D histogram plot. H-lines, all of this, these are all the different commands that are underneath of here. And you can see it's pretty extensive. We've covered all the basic ones so that you now have a solid ground to look at these different options. So when you come to these functions, some of them are going to look a little off, or not off, will look unfamiliar, but you'll still have the availability to probably understand most of this and have a basic understanding of your matplot library.
Let's go ahead and open up another Python 3 setup in here. And so we want to explore what happens when you want to display this. This is where it starts getting, in my opinion, a little fun, because you're actually playing with it and you have something to show people. And we'll go ahead and rename this. We're going to call this Pandas and PyPlot. So Pandas PyPlot, just so I can remember for next time. And we want to go ahead and import the necessary libraries. We're going to import Pandas as PD. Now remember, this is a data frame, so we're talking rows and columns, and you'll see how Pandas works so nicely when you're actually showing data to people. And then we're going to have NumPy in the background. NumPy works with Pandas, so a lot of times you just import them by default. Seaborn sits on top of the Matplot library. So sometimes we use the Seaborn because it kind of extends. It's one of the 100 packages that extends the Matplot library. Probably the most common used because it has a lot of built-in functionality. Almost by default, I usually just put Seaborn in there in case I need it. And of course we have Matplot library as PyPlot, as PLT. And note we have as PD, as NP, as SNS, as PLT. Those are pretty standard. So when you're doing your imports, I would probably keep those just so other people can read your code and it makes sense to them. That's pretty much a standard nowadays. And then we have the strange line here. It says ampersand Matplot library inline. That is for Jupyter Notebook only. So if you're running this in a different package, it'll have a pop-up when it goes to display the Matplot library. You can, with the most current version of Jupyter, usually leave that out and it will still display it right on the page as we go. And we'll see what that looks like. And then we're going to go ahead and just do the Seaborn, the sns.set, and we're going to set the color codes equals true. Let them just keep the default ones so we don't have to think about it too much. And we of course have to run this. The reason we run this is because these values are all set. If we don't run this and I access one of these afterward, it'll crash. The cool thing about Jupyter Notebooks is if you forgot to import one of these, you forgot to install it, because you do have to install this under your Anaconda setup or whatever setup you're in, you can flip over to Anaconda and run your install for these. And then just come back and run it. You don't have to close anything out. And we'll go ahead and paste this one in here real quick, where we have car equals pd.read_csv, and then we have the actual path. This path, of course, will vary depending on what you are working with. So it's wherever you save the file at. And you can see here I have like my OneDrive documents, Simplilearn, Python, data analytic, using Python, / car CSV. It's quite a long file. When we open that up, what we get is we get a CSV file, and we have the make, the model, the year, the engine, fuel type, engine horsepower, cylinders, and so on. And this is just a comma separated file. So each row is like a row of data. Think of it as a spreadsheet. And then each one is a column of data on here. And as you can see right here, it has the make, model. So it has columns for a header on here. Now, your Pandas just does an excellent job of automatically pulling a lot of this in. So when you start seeing the Pandas on here, you realize that you are already like halfway done with getting your data in. I just love Pandas for that reason. NumPy also has it. You can load a CSV directly into NumPy, but we're working with Pandas, and this is where it really gets cool, is I can come down here and I can print, you remember our print statement, we can actually get rid of it, and we're just going to do car head because it's going to print that out. The head is going to print the top values of that data file we just ran in. And so you can see right here, it does a nice printout. It's all nice and inline because we're in Jupyter Notebook. I can scroll back and forth and look at the different data. And just like we expected, we have our column, and it brought the header right in. One thing to note is the index. It automatically created an index 0, 1, 2, 3, 4, and so on. And we're just looking at the head. So we got 0, 1, 2, 3, 4. You can change this. You might want to just look at the top two. We can run that. There's our top two BMWs. Another thing we can do is instead of head, we can do tail. And look at the last three values that are in that data file. And you can see right here, it numbered them all the way up to 11,913. Oh my goodness, they put a lot of data in this file. I didn't even look to see how big the file was. So you can really easily get through and view the different data in here. When you're talking about big data, you almost never just print out car. In fact, let's see what happens when we do. If we run this and we just run the car, it's huge. In fact, it's so big that the pandas automatically truncates it and just does head plus tail, so you can see the two. So we really don't want to look at the whole thing. We'll go and go back to, let's stick with the head, displaying our data. There we go. So there's the head of our data. It gives us a quick look to see what's actually in there. I can zoom out if we want, so you can actually get a better view. Although we'll keep it zoomed in so you can see the code I'm working on. And then from the data standpoint, we of course want to look at data types. What's going on with our data? What does it look like? Now this, you show when you're talking to your shareholders, they like to see these nice, easy to read charts. They look like a spreadsheet. So it's a nice way of displaying pieces of the chart. When we talk about the data types, now we're getting into the data science side of it. What are we working with? Well, we have make model, we have an integer 64 for the year. Engine fuel type is an object. If we go up here, you can see that most of them are it's a set manual, rear wheel drive. So they might be very limited number of types in there. And so forth. And it's either going to be a float 64, an integer, or an object is the way it's going to read it on here. And the next thing you're going to know is like your columns. And since it loaded the columns automatically, we have here the make, the model, the year, the engine, the size, all the way up to the MSRP. And just out of something you'll see come up a lot is whenever you're in pandas and you type in dot values, it converts it from a pandas list to a numpy array. And that's true of any of these. So then you end up in a numpy array. So you'll see a little switch in there in the way that the data is actually stored. And that's true of any of these. In this case, we want car.columns. You have a total list of your car columns. And like any good data scientist, we want to start looking at analytical summary of the data set. What's going on with our data? So we can start trying to piecemeal it together. So we can do car, describe, and then what we'll do include equals all. So a nice panda command is to describe your data. If you're working with R, this should start looking familiar. And we come down here and you can see count. There's the make, the model, the year, how many of each one, how many unique values of each one, the top value of each one, what's most common, the frequency, the mean. Clearly on some of these it's an object, so it really can't tell you what the average is. It'd just be the top one's the average, I guess. The year, what's the average year on there? All this stuff comes down here. Your standard deviation, your minimum value, your maximum value, what's in the lower quarter, 50% mark, where's that line at, and what's in the upper 75%, the top 25% going into the max. Now, this next part is just cool. This is what we always wanted computers to be back like in the 90s, instead of 5,000 lines of code to do this. Maybe not 5,000. All right, I built my own plot library back in 95, and the amount of code for doing a simple plot was, I don't know, probably about 100 lines of code. This is being done in one line of code. We have our car, which is our pandas. We generated that. It's our data frame. And we have .hist for histogram. That is the power of Seaborn. Now it's still going to generate a numpy graph, but Seaborn sits on top, and then we can do the figure size. This is just so it fits nicely on the paper on here. And we do something simple like this, and you can see here where it comes up, and it does say matplot library and does subplots and everything. But we're looking at a histogram of all the different pieces in our database. And we have our engine cylinders. That's always a good one because you can see like they have some that they had a null on there, so they came out as 0. Maybe one of them had a 2-cylinder engine way back when. 4 is a common, 6 a little less common, and then you see the 8-cylinder. 12-cylinder engines. Boy, that's got to be a speedster or something. But you can see right here, it just breaks it down. So now you have how many cars with how many, whatever it is, cylinders, horsepower, and so on. And it does a nice job displaying it. You can see if you're working with your, you're going into your demo, it's really nice just to be able to type that in and boom, there it is. It can see it all the way across. And we might want to zero in and use like a box plot. And this time we'll go ahead and call the Seaborn, SNS, box plot. And we're going to go ahead and do vehicle size versus engine horsepower XY plot. And the data comes from the car. So if we run this, we end up with a nice box plot. You see our mid-size, compact, and large. You can see the variation. There's our outlier showing up there on the compact. That must be a high-end sports car. Large car might have a couple engines, and again, we have all these outliers and then your deviation on them. Very powerful and quick way to zero in on one small piece of data and display it for people who need to have it reduced to something they can see and look at and understand. And that's our Seaborn box plot, or SNS.boxplot. And then if we're going to back out and we want a quick look at what they call pair plotting, we can run that, and you can see with the Seaborn, it just does all the work for you. It takes it just a moment for it to pull the data in and compile it. And once it does, it creates a nice grid. And this grid, if you look at this one space here, which is, you might not be able to see the small number, it says engine horsepower. This is engine horsepower to the year it was built, and it's just flipped. So everything to the right of the middle diagonal is just the rotation of what's on the left. And as you expect, the engine horsepower gets bigger and bigger and bigger as time goes on. So the year it was built, the further up in the year, the more likely you are to have a heavy horsepower engine. And you can quickly look at trends with our pair plot coming up. And look how fast that was. It took it a couple, moment to process. But right away, I get a nice view of all these different information, which I can look at visually and kind of see how things group and look. Now, if I was doing a meeting, I probably wouldn't show all the data. One of the things I've learned over the years is people, myself included, love to show all our work. We were taught in school, show all your work, prove what you know. The CEO doesn't want to see a huge grid of graphs, I guarantee it. So what we want to do is we want to go ahead and drop the stuff that might not be interested in. And I'm not really a car person. Our guy in the back is, obviously. So you have your engine fuel type. We're going to drop that. We're going to drop market category, vehicle style, popularity, number of doors, vehicle size. And we have the axes in here. If you remember from NumPy, we have to include that axes to make it clear what we're working on. That's also true with pandas. And then we'll look at just what it looks like from the head. And you can see that we dropped out those categories, and now we have the make, model, year, and so forth. And we took out the engine fuel type, market category, etc. And this should look familiar to you now. When you start working with pandas, I just love pandas for this reason. Look how easy it is. It just displays it as a nice spreadsheet for you. You can just look at it and view it very easily. It's also the same kind of view you're going to get if you're working in Spark or PySpark, which is Python for Spark, across big data. This is the kind of thing that they come up with, and this is why pandas is so powerful. And we may look at this and decide we don't like these columns. And so you can go in here and we can actually rename the columns. Simple command, car equals car, rename. Columns equals engine horsepower equals horsepower. This is just your standard Python dictionary. So it just maps them out. And instead of having like the lengthy, here we had engine horsepower. We just want horsepower. We don't need to know it's the engine horsepower. Engine cylinders, we don't need to know that it's for the engine, because there's only one thing we're describing if we're talking about cars, and that's cylinders. And we'll go ahead and just run this. And again, here's our car head, and you can see how that changed. We have model year and horsepower versus model year, engine horsepower, engine cylinders, and just cylinders. Again, we want to keep reducing this so it's more and more readable. The more readable you get it, the better. And of course, we can also adjust the size a little bit so that when it prints out, instead of splitting it on 2 lines, we get like a single line. We can do that also. That's just your control mouse up or plus sign you use in Chrome. That's a Chrome command. And if you remember from NumPy, we had shape. Well, Pandas works the same way. We can look at the shape of the data. So we now have 11,914 rows and 10 columns. So you see some similarities because Pandas is built on NumPy. And questions that come up just like you did in NumPy, we might want to know duplicate rows. And so we can do car. And look at this switch here. We're doing a selection. This is a Pandas selection with the brackets. But we want to select it based on car.duplicated. So how many duplicates on there? So it's starting to look a little bit different as far as how we access some of the data on here. This can be a logical statement. And we get the number of duplicate rows. We have 989 rows by 10 columns again. And this is one of those troubleshooting things that we end up doing a lot, more than we really feel like we should. We might go ahead and do like a car count just to see how many rows we're dealing with. And then right after that, we might want to go ahead and say, hey, let's drop duplicates. So remember we did all the duplicates on there. So car equals car.drop duplicates. And then we can print the head again. We'll just do car head here. And you can see the data on there looks the same as before. And just note that we did car equals car.drop duplicates. There are commands in here where you can do, where it changes the actual value. And it works on some of them and not on others depending on what you're doing. But by default, it always returns a copy. So when we do this, we're reassigning it to car. And you can see it's the same header, but we want to go ahead and do count and see how the count changes. Let's go ahead and run this. And you can see here, instead of 11,914, we have 10,925. So we've removed about 100 cars that were duplicated, just slightly under 100 there. And then as we're prepping our data, we might want to know car is null. So it's going to count the values of null, and then we want to sum that up. And when we do that, we do the car is null function.sum. We end up with HP, the horsepower is 69 have null values, and 30 have cylinders have null values. Now, if you don't put the sum at the end, it's just going to return a mask with the true false of is it null or is it not, by 0 and 1. So you're summing up the ones underneath each column. And this, of course, then you have to decide what you're going to do with the null values. There's a lot of different options. It might be that you need to put in the average or means. Maybe you want to put in the median value. There's a lot of different ways to fill it. Usually when you first start out with the data, a lot of them you just drop your null values. And you can see here car.drop NA, which is equal to all. And then we're going to go ahead and count it. And you can see that we've dropped almost another 100 values. So from 10,925 to 10,827, maybe 75 or so values. So we cleaned it. This is really a big part of cleaning data. You need to know how to get rid of your null values, or at least count them, and what to do with them. And of course, if we go back to counting our null values, we should now have null values. There we go. And you'll see there's 0 null values. I don't know how many times I've been running a model that doesn't take null values and it crashes, and I just sit there and look at it trying to get, why did that crash? It should have worked. It's because I forgot to remove the null values. So we've been jumping around a lot. We're going to go back to finding outliers, and let's go ahead and bring that back into our Seaborn. And if you remember, we did a box plot earlier. This time we're going to do a box plot just on the price. And you can see here our price value, and we have the deviation with the 2 thinner bars on each side of the main value. And then as we get up here, we have all these outliers. In fact, we have one way out here that's probably a really expensive high-end car is what we're looking at. If you were doing fraud analysis, you would be jumping on all over these outliers. Why are these deviation from the standard? What are these people doing? Again, this is probably, like I said, a really high-end expensive car out here. That's what we're looking at. And we can also look at the box plot for the horsepower. We'll put that in down here and run that. And you can see again, here's our horsepower, and it just jumps, and there's these really odd, huge muscle cars out here that are outliers. And we're going to jump into making this a little bit more, as you start displaying your data or your information to your shareholders. We're going to look at plotting a histogram for the number of cars per brand. And the first thing we want to go ahead and do is we have with our car, go back over here, here we go. We have our make value counts, largest plot, and we want to do a kind equals bar, figure size 10.5. And right off the bat, we jump up here and we see Chevrolet. It's going against, what was it? It's figure ratio, the value counts, and we want the largest value. So here's our value counts and compared to what the different cars are. Chevrolet puts out a lot of different kinds of cars. I didn't realize that they made that many cars or different types. And then for readability, let's go ahead and add a title, number of cars by make, number of cars, and make. If you had looked at this the first time, you would have been like, well, what the heck am I looking at? Well, we're looking at the number of cars by make. And then you can see here, now we're talking about the type of cars and the different ones are put out. Lotus, I guess, only had a few different kinds of cars over there. Very high-end cars. And then as doing data analytics and as a data scientist, one of the things I am most interested in is the relationship between the variables. So this is always a place to start. We want to know what's going on with our variables and how they connect with each other. So the first thing we're going to do is we're going to go ahead and set a figure size because we want to make sure it fits our graph. We'll just go ahead and set this one plot figure set to figure size 2010. If you never use the matplot library, which is sitting behind Seaborn, whatever is in the PLT, this is what's loaded. It's like a canvas you're painting on. So the second you load that PyPlot as PLT, anything you do to that is affecting everything on it. And then we want to go ahead, since we're using Seaborn, we'll go ahead and create a variable C for relationships or correspondence, and car.corr. That's a correlation in Seaborn on top of pandas. Again, one line and you get the whole correlation on there. And because we're working with Seaborn, let's put it into a nice heat map. If you're not familiar with heat maps, that means we're just using color as part of our setup. So we have a nice visual. And we can see here that the Seaborn connected to the pandas prints out a nice chart. We'll talk a little bit about the color here in a second. It prints out a nice chart. This is a chart I look at. As a data scientist, these are the numbers I want to look at. And we'll just highlight one of them. Here's cylinders versus horsepower. The closer to 1, the higher the correlation. So 0.788. Pretty high correlation between the number of cylinders and how heavy the horsepower is. I'm betting if you looked at the year versus horsepower, we can just look at that one. Here's year and horsepower. 0.314, not as so much, but if you combine them, you don't actually add them. But if you combine them, you'll start to see an increase in horsepower per year and cylinders. You could probably get a correlation there. And just like 0.78 is a positive correlation, you might notice if we look at cylinders, or let's look at horsepower and mileage. So if we go here to horsepower to mileage, you get a nice negative. We'll do cylinders, that's a bigger number. With cylinders to the miles per gallon, it's a minus 0.6. So it's a negative correlation. The closer to -1, the more the negative correlation is. And then the chart you would actually show people is a nice heat map. This is all our colors, and it's just those numbers put into a heat map. The darker the color, the higher the correlation. You can see straight down the middle, obviously the year correlates directly with the year, horsepower with horsepower, and so on. That's why it's a 1. The closer to the 1, the higher the correlation between the two pieces of data. Now, this is a good introduction. Pandas goes way beyond this. Most of the functionality in NumPy, since Pandas sits on it, is also in Pandas, and then it even has additional features in it. And we use Seaborn pretty extensively sitting on top over our PyPlot. So keep in mind that our PyPlot has a ton of other features in it that we didn't even touch on in here. We couldn't, even if you had a sole course in it, there's just so many things hidden in there depending on what your domain you're working on. But you can see here, here's our Seaborn and here's our Matplot library. That's all our graphics that we did. And then the Seaborn works really nicely with the pandas. We really like that.
In the next project, we'll understand how to perform data analysis using Uber dataset from New York City. So let me show you the dataset first. So this is the dataset that we'll be using for our analysis. You can see this dataset has around 5,64,516 rows. It has information about Uber bookings in the New York City. You have the date and time column when the booking was done, or you can say when the pickup or the trip was made. Next, we have the latitude and longitude information, basically defining the location from where the Uber was booked. The last column is the base column. It has data regarding TLC base company code affiliated with the Uber pickup, that is, the base that dispatched the Uber. Now let me take you straight to my Jupyter notebook where I have implemented this project. So I have my code ready. I'll run through each cell of code and tell you what it does. In the process, we'll also learn some of the functionalities of Python 2. First, let's start by importing the libraries. So first, we are importing NumPy library as NP, Pandas as PD. Now NumPy is used for numerical computation. Pandas is used for pre-processing and data manipulation. Finally, we have Matplotlib and Seaborn for data visualization and exploratory data analysis. So let me hit Shift Enter to run this cell. Okay. Now let's go ahead and import our Uber dataset. So it's a CSV file. For that, I'm using the pandas library and read_CSV function. And inside this function, I provided the location where the data file is. You can see this is my location, followed by the dataset name. This is the name of my dataset, and the extension as well, that is .csv. Let me hit Shift Enter to run this cell. Now we have successfully imported our dataset. Now to display the head of the dataset, I'll write uber.head. This is the function which is used to display the head of the dataset. Now the .head function will display the top 5 rows from this dataset. There you go. So we have our first 5 rows from the dataset. Now if you want to display some additional information about the dataset, you can use info function. So let me hit Shift Enter to run this cell. You can see the info function gives you the total number of rows and columns in the dataset. You can see we have 5,64,516 entries, that is rows, and now we have a total of 4 columns, and you can see all the columns listed here: date, time, latitude, longitude, base, and we also have the data type for each of these columns. Now moving ahead, in the following cell, we'll check if there are any missing values or null values in all the columns. For that, I have defined a function called numMissing, and it has one argument, that is x. I'm using the isNull function to return the total sum of null values. In the final print statement, I have used pandas library and apply method. Now this apply method takes a function and applies it to all the values of pandas series. Now let's run this cell. You can see none of the columns have any missing values. It says 0, 0, 0 and 0, which means there are no missing values in any of the columns. Next, there's another method to find null values where you can use isAny function. So let me show you how to do that. I'll write Uber, which is my data frame, dot isAny is my function, and I'll use the sum function. Let me run this. There you go. It has returned the same results, indicating there are no null values or missing values. Now we are interested to extract some additional information from the data. So I'm converting the datetime column into a data frame using to_datetime function, and I have my format specified. You can see it here. Next, I'm finding the day of week num, which means I want to know a particular day falls on which week number. So 0 for Monday, 1 for Tuesday, 2 for Wednesday, and so on. You can see I have used dt.dayofweek method. Similarly, you can also find the weekday name, that is if a particular day is a Monday or a Tuesday or a Sunday or anything. And for that I have used dt.weekday_name. Now let me extract two more information, that is the day number and the hour of the day at which the trip was made. So I'll write Uber, which is my data frame name. I'll give square brackets, and inside that I pass in my column names, say day num, and that will be equal to my data frame, that is Uber, followed by my column name, that is date/time, and I'll use the method dt.day. Similarly, to find the hour, I'll write Uber, within square brackets I give my column name hour of day, that will be equal to Uber followed by the original column name date/time, and the method I'll use is dt.hour. Let's run this. Okay. Now let me display the head of the dataset once again. So I'll write Uber.head. You can see towards the right we have our new columns added that did not exist in our original dataset. Now you can also display the shape of the dataset. Now the shape will return the total number of rows and columns present. So I'll use Uber.shape. You can see we have 5,64,516 rows and 8 columns now. Earlier, if I go on top, we had 4 columns. Now there are 8 columns in total. You can also find out all the unique base code names from where the Uber was dispatched. So let me show you how to do that. I'll write Uber, and inside square brackets I'll give my column as base and give the unique function. If I run this, you can see we have 5 different base code names. Now coming to our first visualization of the project, here we'll see the total count of Uber trips from each base. For that I've used the Seaborn library and cat plot function. In the x-axis I have my base column defined. I have passed my data frame name, that is Uber, and kind I have given as count, that is I want to count the number of bookings at each base. So let me run it. This might take some time. There you go. You can see on the screen we have a nice bar graph here. The x-axis shows the count of trips for each base code. So base 02682 had the highest number of trips or bookings in April 2014, and base 02764 had the lowest number of bookings. In the next cell, let's explore another feature of Pandas library, that is to create a pivot table. For that I have used pivot_table function. For index I'm using the column names day of week num and day of week. Values I have passed my base column, and the aggregate function I have used is count. Now the cell of code will create a table to understand the total number of trips for each day of the week. Let me run this. You can see in April 2014, Wednesdays had the highest number of trips, which is around 1,08,000, while Sundays had the lowest, 51,251. Now that makes sense because Sunday is a holiday in New York and people would like to spend time at home. Now let's visualize the pivot table in the form of a bar plot. So I'll write Uber underscore week underscore data dot, I'll use the plot function. Inside plot function I'll give kind is bar, so I want a bar plot, and I'll define my figure size and I'll give equal to, let's say, 8,6. Run this cell. There you go. As we saw above, Wednesday had the highest number of Uber pickups while Sunday had the lowest. Similarly, let's visualize the bookings based on hour of the day. So I have created a pivot table and then I'm trying to plot a line graph. Let's run this. Okay. You can see the trend. At midnight, the number of trips are less. It slowly increases early in the morning, and during the evening time, Uber bookings are higher. So you can see around 4 in the afternoon to 7 in the evening, Uber trips attain a peak and trips gradually decrease after 8 p.m. in the evening. Moving ahead, let's now analyze the number of Uber bookings based on each day in the April month of 2014. So I have created my pivot table and then I'm trying to plot a bar graph. You can see I have kind equal to bar. Let's run this. Okay. We have our bar graph ready. Now this bar graph depicts 30th of April had the highest number of Uber bookings, followed by 4th of April, that is this one. Now I can show you in the next two cells of code. Now in the current cell, we are basically counting the number of trips for each day in April month. I have grouped each day number using the group by function and used the apply function to count rows. Let's run it. So I have all the day numbers listed and the total number of trips that were made for each day of the month. Now let me sort the bookings for each day in ascending order. So I'll write by underscore date underscore sorted equal to by underscore date dot, I'll use the function sort underscore values. Now to display, I'll again use by underscore date underscore sorted. Let me run it. Now we have arranged this in ascending order. The results tell us that 20th of April had the lowest number of trips while 30th of April had the highest, followed by 4th of April. Now you can also create a histogram to analyze the pickups by hours. Let's run this cell. I've used the hist function for this. Okay, so we have our histogram ready. Now this histogram is similar to the line graph that we plotted above, this one. Now let's create a cross table to analyze Uber bookings based on day of week num and hour of day. So here I have used group by function, split function, apply, as well as unstack function. Let me run this. There you go. So this is my cross table ready. On the top we have day of week num, that is 0 for Monday, 1 for Tuesday, 2 for Wednesday, 5 for Saturday, 6 for Sunday, and then here we have the hour of day. Now let me tell you how to read this table. For example, at 11 a.m. On Tuesday, there were 2,949 trips. If I scroll down, let's consider this one at 2 p.m. on Sundays, there were 2,934 trips. Let's move on to our final section of the demo. Here, we'll create a heat map to analyze bookings in terms of hour of day and day of week number. For this, I'm using sns.heatmap function. The brightest spot will tell the day or the hour with the highest frequency of trips. Let's run this. There you go. We have a nice heat map ready. The dark regions depict the frequency of trips were less, while the bright regions show the highest number of trips. So if I come down, these are the bright regions. So if we look at this heat map, we can conclude that 5 p.m. on Wednesdays had the maximum number of trips because this region is the brightest.
And now let us focus on benefits of using R. Why do companies extensively use R for data analysis, and why is it chosen? Firstly, R is an open source programming language, which means that there is no license required to work with R. And R does not require you to have a coding experience, which means that a non-technical person in your team can also learn R very easily and start coding or building models in few lines of codes. R can also be used with other programming languages such as Java, C++, and Python. And the integration of R with other programming tools or BI tools is very simple and easy. And various statistical models are readily available in R, which also means that there are plenty of inbuilt libraries and packages already available. And reporting the results of an analysis becomes easier by using these inbuilt packages and for creation of these models in just simple few lines code. With this understanding of the benefits of using R, let us quickly hop on to R Studio and start performing the hands-on exercise for data analysis. For this exercise, we will use a dataset named as demographics, which is in a .csv file type. Firstly, let us load the dataset to R Studio, and we will locate this in an variable named as demo. We also refer to this as a data frame. And now you will notice that a variable is created in an environment section, which is in the bottom right hand side of the R Studio window. And this particular variable comprises of 510 observations or records with 8 variables. Let us simply expand this particular data frame and have a quick check on the data structure and understand the data types. This particular data frame includes variables such as age, marital, income, the unit of income is dollar per day, education levels, the car price, car category with several levels, gender, and retired status. Now let us view the top 6 records of this particular data set. For this, let's simply type head of demo. And the result is now visible in the console section. If you're interested to view all the records, then simply type view of demo. And this new window will show you every single record that is being loaded to R Studio. You may also simply apply the filters and the filter section here on individual categorical variables. Now that we have loaded the dataset and also viewed individual records, let us focus on creating subsets of records by applying filters on individual variables or multiple variables. So firstly, let us apply filter on gender. We will only retrieve the records where gender is equal to female, and we will locate these records in a variable named as demo2. As you notice now in the environment section, the second variable is also created, that is demo. And this now is comprising of 250 observations, which means the records are filtered down to only gender female. Next, let us see how to apply a filter on income variable. Let us only retrieve the records where income is greater than 100. Let's view the result. As we see here, all the records include income greater than 100. Now let us modify this query and we will ensure that the retrieved records includes income greater than 100 and also specific variables are returned. Let's say we only want to have the first variable, third variable and the seventh variable returned as the result. Let's have a quick check. So we only have the first, third and the seventh variable returned. How about we only exclude the variable 6 to 8? For this we include a prefix of minus sign. And now let us see what is the result. We have the variables from first to the fifth variable. However, we don't have 6, 7 and 8th variable. I hope it's clear so far. Yes? Alright. Now let us see how can we apply condition by including both the variables, that is gender and income, and then we will filter the record and create a subset of data. Now let's view the result. Income is greater than 100 and the gender is only female. This is one way of creating subsets. However, now let us see how to use the subset command and create the subset. Let's create a subset of records by applying filter on marital status and age. We'll only retrieve records where marital status is equal to married and age is greater than 35. Let's now view the result. So here we have the age greater than 35 and marital status is married. Let's use the same code and this time we will retrieve selected variables. Let's say variables ranging from 1 to 3. Let's have a quick check. So there are 3 variables. Age is greater than 35 and marital status is married. Now let us see how to structure the data by sorting the data frame in ascending and in descending order. We will apply this order function on the variable income. Firstly, let us see how to order income variable in ascending order. Let's do a quick check. And here we have income in ascending order. Now let's see how to modify the same code and view the records with income in descending order. So we have now the income in descending order. How about include two variables and sort the variables accordingly? Firstly, we will sort the records by ordering income and age in ascending order. Let's quickly view the result. We have income in ascending and age as well in ascending. Let's now modify this code. This time we will order income in descending and age in ascending. Let us view the result. So the income is in descending and age is in ascending order. So hope this is clear on how to sort the data frame by ascending and descending order per variable or by using multiple variables. With this, we will focus on learning statistical analysis. How to perform statistical analysis on individual variable or multiple variable. Let's start by understanding the data distribution of variable income so that we identify what is the minimum value of income, what is the maximum, what is the range, what is median, what is the mean, and we will also focus on the quantile distribution, which is also analyzed in a box plot. What is the minimum value in the variable income? It's 9. And what is the maximum? So we have the maximum value. Now let us see what's the range. So the range shows you the result with minimum and the maximum value. How about the difference of maximum and the minimum? Now let us focus on other summaries of data distribution for this variable income. Let's identify what is the mean value of income. The mean is 78. Let's also understand what is the standard deviation. Alright, so the standard deviation is $112. Let us see what is the variance. The variance should be larger than the standard deviation. Now let's see what is the median absolute deviation. As you notice here, the median absolute deviation value is lower than standard deviation. Why do we make this comparison? From this, it is evident that median absolute deviation is robust to outliers and standard deviation is sensitive to outliers and also to the change in the mean value. Now let us understand the quantile distribution. This is the same analysis that is visualized in a box plot, ranging from 0% to 100%. Identifying the individual data points. And we can also refer and compare this to the min, the max and the median values. Let us quickly see what is the median value of income. As you notice here, the median is 45. As well, the 50th percent of quantile is 45, which means 0% is minimum and 100% is the maximum value. Now if your question is what is 25% and 75%, this is again used for identifying the range of interquartile. The interquartile range is nothing but the difference of 75% minus the 25%. Let's quickly see what is the IQR of income. The IQR of income is 58. Let us do a quick check. 75% of quantile is 86 and 25% of quantile is 28. And the value is 58, which is equal to the IQR result. Now that we have focused on the statistical analysis of the individual variables data distribution, let us focus on the data visualization. In this, we will have a pictorial representation of analysis to identify the outliers, to see what is the minimum and where do we see the data densely populated and how is it scattered, etc. We will begin with creating a histogram. Now, histogram can be used for univariate analysis, which means in this scenario we will consider income variable and we will see how the count of income ranges gets distributed in a histogram. For this, we will have to install a package called as ggplot2 and also call this library ggplot. Let us install the package. Now let us call the library. Alright, and we are ready now to begin with visualization. For this, we will use the geometric object histogram on the data demo data frame. Let me expand this window so that the code is visible, and also use an aesthetic mapping for variable income. This will be helpful for filling colors or filtrations, etc. And only include 30 bins with individual bin size width of 100, which means there will be 100 incomes in individual bins. Let's quickly look at the distribution of this histogram. As you notice, there are a couple of outliers. The counts of these income range are very limited. However, we see the densely populated income ranges with higher counts between 0 to $200 per day. This is also a way to identify and segment the customers based on their income ranges. Now let us see how to change the color of this histogram and also the border of the histogram. For this, we will include some additional options such as fill with blue color, and the border color is black. Now, as you notice here, the executed code provides us the histogram with blue color bars and black color border lines. Now we will focus on creating a facet grid. Facet grid is also an aesthetic mapping object. We will see how to enable the multiple histograms across the marital status and the genders, so that we identify how the income is distributed for individual marital status as well the genders. Let's zoom this view and have a look at it. As you notice here, there are some interesting outliers here in the data distribution. Female unmarried drawing higher income, and male unmarried and married also drawing higher income as compared to the females. Whereas if you notice that the female unmarried is drawing much higher income than the male. This may also be very much related to the age. Now let us see how to create a stacked histogram. When I say a stacked histogram, I mean instead of filling the color, we will fill the gender, so that there is a stack within the histogram. So as you notice here, I have made couple of changes. I have included fill equal to gender within the aesthetic mapping. Now let us look at this histogram. As you see here, the gender is filled in the histogram, hence we have stacked distribution of female and the male. Now let us focus on creating a bar chart with education versus income, where we can identify the education levels and the income ranges for these education levels. As you notice here, we are going to create a visualization where we have the aggregation in form of mean, and the geometric object used here is bar plot. Now let's zoom this view and understand which education level have higher average income. So as we see here, the blue color bar is the post-undergraduate degree, which means this education level draws higher average income as compared to other education levels. Now let's create a histogram where we will see car price and the number of cars for individual category. Let's look at this visualization. This visualization provides us some interesting insight. Just by looking at the distribution of the car prices and the counts of the cars at the car category, economy, and even the luxury. Luxury car category or car price is pretty much distributed, whereas economy car category is dense, which means that we could also look back into the income and age variables and try to figure out further more insights, and then segment the customers for further targeting of these customers. Now what happens if we simply change this bin width to 30? As you observe here, changing the bin width or increasing the bin width will also reduce the number of bins. Now we only have 4 bins here, and the car category is filled. That is what we have enabled within the aesthetic mapping. And we see some more interesting insight. As you look at the standard and the luxury car category, the car prices are pretty much overlapping for the car category luxury and standard. This could be the starting car price of the luxury brands. Now let us create a clustered bar chart. Let's look at this visualization. In this visualization, as you observe, though we have enabled fill equal to gender in the aesthetic mapping, we do not have the view in stacked form, but we have the bars one besides the other. It is also because we have enabled a position called as position equal to dodge in the code. Now, what is the insight that we can draw from this visualization? As you see, postgraduate degree with female gender is drawing higher average income as compared to any other education level. Now let us see how to create a box plot for variable income across the genders. So the box plot can be enabled if there is a bivariate analysis to be performed on a continuous variable and a categorical variable, or multiple categorical variables with a continuous variable. Now let's look at this visualization. What does this say? We have data distribution of income for individual genders, that is for female and the male, and we also notice outliers here. Anything above this whisker is considered to be outliers. It might make more sense if we also include some coloring for these outliers, maybe also enable shape. So now we have colored the outliers and it's colored orange. Let's see if we can also enable the shapes. And now we have here the outlier color as well the shape enabled. Now let us see how to enable a violin plot. What is the utility of violin plot? With a box plot, we understand the analysis and the distribution of the data points is to identify the outliers, to know what is the minimum value, what is the max, what is the median, and what are the outliers. But what is the purpose of a violin plot? Let us have a quick check. As you observe, there is some concentration of data points in the bottom of every car category. However, the concentration is higher for standard car category as compared to economy and the luxury. Now, this is an interesting insight that you wouldn't have come across in box plot. The box plot is a very good representation for identifying outliers. However, violin plot will help you focus on the nuances which is not captured by the box plot. We can also simply combine the box plot and the violin plot together. Simply include this geo object. Let's zoom this. Now you have a representation of box plot and the violin plot, both combined in a single visualization. Interestingly, you notice the outliers as well the concentration in the bottom of this violin plot. So this could be some interesting insights that you draw and focus on these data points and understand what exactly is happening there. Now let's focus on the density plot, that is density estimate of the histograms rather than just viewing the frequencies. Now we see the frequency in the y-axis across the income distributions. How about enabling the probability as true, so that we enable the density instead of the frequency? So now we have the density in the y-axis, and in the x-axis we still have the income distribution. This is the way of also adding a line plot, which is a density plot on the histogram. Now as you observe here, the density plot is not in the same level as the bar. So let us adjust this line. For this we will include adjust, let's say equal to 3, and now let us see how the visualization appears. Now the density plot is on the same level as the bar. Now let us see how to create a cross table for car category and gender. For this, let us call the library DESCR. Now let us create the visualization, enabling cross table for car category and gender. Let's look at the result in console. As you see here, now we see the counts of the gender for individual car category. The values over here represents that there are 67 females falling within the car category economy and 80 males within the car category economy. And for luxury, we see that the count of female is higher than the male. As well, the proportions. Now, how do you understand what proportions are presented here? We may simply turn off some of the proportions like the t-test, the chi-square, etc. Let us see how to enable that. Now let's look at the result. This looks better. Now that we have the counts, the female counts and the male counts across individual car category, we also see the percentages rather than just looking at the absolute value. So there are 45.6% of female within the car category economy and 54.4% of male within the car category economy. Similarly across rest of the car categories. This kind of cross table or a contingency table is also helpful when you want to analyze the different categorical variables and identify the counts or the proportions. Now let us see how to use a scatter plot of age versus income. Scatter plot is a visualization used for bivariate analysis. When you want to perform some analysis between two continuous variables at a data point level, rather than performing the analysis at an aggregated level, such as sum or mean. And now we have a scatter plot of age versus the income, age in the x-axis and income in the y-axis. Though we do not see any kind of a positive correlation or a negative correlation, but we still see some interesting insights over here. Some of the data points are pretty much scattered and much away from densely populated data points. I hope the learning has been informative and interesting so far. We have covered the concepts of data analytics As well, we have performed some hands-on, doing some statistical analysis and also creating interesting visualization.
Hi everyone, welcome to this section of R programming. Let's learn about data manipulation in R, and here we will learn about dplyr package. And when we talk about this dplyr package, it is much faster and much easier to read than base R. So dplyr package is used to transform and summarize tabular data with rows and columns. You might be working on a data frame, or you might be getting in a inbuilt R data set, which can then be converted into a data frame. So we can get this package dplyr by just calling in library function, and this can be used for grouping by data, summarizing the data, adding new variables, selecting different set of columns, filtering our data sets, sorting it, selecting it, arranging it, or even mutating. That is basically creating new columns using functions on existing variables. So let's see how we work with dplyr. Now here I can basically get the package here. So I can just say install.packages dplyr. Now we already see the package here, which is showing up. So I will just select this one. I can do a control enter, and that will basically set up the package dplyr successfully unpacked. So that is done. Now you can start using this package by just doing a library dplyr, and this was built. It shows me my version of R. So let's also use a inbuilt data set, that is New York flights 13. So we can do install.packages, and that will search and get that relevant data set. I can again call it by using library function. Now once that is done, we can look at some sample data here by just doing view flights, and that shows me the data in a neat and a tabular format, which shows me year, month, day, departure time, scheduled departure time, and so on. Now we can also do a head to look at some initial data, which can help us in understanding the data better. So what is this data about? How many columns we have? What are the data types or object types here? It shows me how many variables we have. So this is fine. Now we can start using dplyr, and in that we can use, say, filter function if we would want to look in for specific value. Now here we have the column as month, so I will do a filter. Now I'm creating a variable f1. I'm using the filter function on flights, which we already have. And then what we can do is we can basically look at the month, where the month value is 07. So let's look at that. And this one, you can do a view on F1, which shows me the data wherein you have filtered out all the data based on month being 7. So this is a simple usage of filter. We can take some other example. We may want to include multiple columns. So we can say F2 filter flights, and here we will say month is equal to 7, day is 3, and then look at the value of F2 if you are interested in seeing this. And that tells you the month is 7 and day is 3. You could also look into a more readable format by using view on F2, and that gives me my selected result. So we are just extracting in some specific value. We can keep extending this. So here we can say flights is what we would want to work on. I'm using the filter function, so I can straight away, instead of creating a variable then doing a view, I can also do a view in this way. I can just pass in my filter within the view, and within this I'm saying filter. I would want to look at the flights, month being 09, day being 2, and origin being LGA, and then that shows me the value here. And obviously you can scroll and look at all the columns, and if you see the origin column, it shows the selected value. So now we have filtered our data based on values in 3 different columns. Now what we can also do is we can use AND, or we can use OR operators. So I could have done this in a little different way. So I could have said head, which shows me initial result. I will do a flights. So within my head function, I'm passing in this. And what does that contain? So you are saying flights. And in this flights data set, you would want to pick up the month being the column. So we use the dollar symbol here. We give in a value and I'll say and I'll again say flights, wherein I will select the day being 2 and remember, when you talk about and, it is going to check if all the values are met true. So then you say flights origin, LGA, and you look at the value. So in this way, I can filter out specifically multiple values by specifying columns. Now we could have done it in this way. We could have created a view, or we could have assigned this to a variable and then done a view on that, where we could have selected month being day and origin. Or you can be more specific in specifying all the columns. It makes the code more readable. So let's look at the values, and here you are looking at head, which shows me based on month, day, and then you can look for further columns for other variables, that is origin being LGA. Now what we can also do is we can do some slicing here to select rows by particular position. So I can say slice, and I would want to look at rows 1 to 5, and I can do this. So you can always assign or look at the view of this. I can just do here. So when I did a slice 1:5, it shows me my entries for 1 to 5. Now similarly, we can do a slice 5 to 10, and now you're looking at 5 to 10 values. So you can always look at the complete data and then you can slice out particular data. Now mutate is usually a function which is used when you would want to apply some variable on a particular data set, and then you would want to add it to your existing data frame, or you would want to add a new column. So this is where you use mutate, which is mainly used to add new variables. So let's see how you work on mutate. So it's pretty simple. So you create a variable over delay. Now I would want to do a mutate so that it adds a new column. So I'm selecting my data, which is flights. I will call the new column as overall delay, and then basically I can look at overall delay being arrival delay minus departure delay. So let's create this and let's look at view of this, which shows me, or which should show me, my new column, which is overall delay, which was not in my original data set. So you can anytime do a head on this one to compare the value. So this one shows me arrival delay, and then there are many other variables. What you can also do is you can do a view, and you could have just look at flights if you would want to compare. So you can look at the flights, and this one would not have any overall delay column. So it basically shows me 19 columns only, what we see here. And if you do a view on overall delay, then that basically shows me 20 columns. So we know that the new column has been added to this overall delay. So if you would want to work with 20 columns, you will use overall delay. If you would want to work with your original data set, you will use flights. Now you can also use a transmute function, which is used to show only the new column. So we can do an overall delay, and at this time we will say transmute, we will say flights overall delay. The computation remains same, but at this time if I look at view on overall delay, it only shows me the new column. So sometimes we may want to compute result based on two variables or two columns and just look at the new value, and then we can decide if we would want to add it to our existing structure. Now you can also use summarize, and summarize basically helps us in getting a summary based on certain criteria. So we can always do a summarize, and what we can do is we can look at our data and we can say on what basis we would want to summarize this particular data. So we can do a summarize function. Now summarize on flights, I will say average air time, and I would want to calculate an average. So for that, I'm using an inbuilt function called mean. I will do that on airtime column. So let's look at flights once again, and here we can see there is arrival time, not airtime, sorry, arrival time, and we would want to do some average on this particular data. We would want to summarize this. So what I'll do is I will use the summarize function. I will say average airtime, and this one I will look at mean of airtime. So let's see if there is a airtime column. I might be, let's look at this one, arrival delay, and yes, we have an airtime. So we were actually looking at summarizing based on airtime, not the arrival time. So airtime is how much time it takes in air for this particular flight, and we will want to use the summarize function, not the transmute. So summarize flights average airtime, and this one we will calculate the mean of average airtime, and I will also do a NA removal, which is I'm saying true. So let's do this, and that basically shows me the average airtime is 151. I can also do a total airtime where I'm doing a summation of values, or I can get the standard deviation, or I can basically get multiple values such as mean. I can say total airtime where I'm doing a summation, and then I can look at other values, which is if you would want to put in standard deviation here, you could do that. So let's look at the result of this summarize, and this basically allows me to get some useful information which is summarized based on a particular function such as mean, sum, standard deviation, or all three of them. Now let's look at grouping by. So sometimes we may be interested in summarizing the data by groups, and that's where we use the group by function. So we can always use the group by clause. Now here we are taking a different data set. So we will say, for example, let's look at head of empty cars, and that is basically my data set on empty cars. Now that shows me the model of the car, it shows me mileage, cylinder power, and your horsepower, and various other characteristics or variables in this particular data set. So here we can say let's do a grouping by gear. So there is a column called gear, so I will call it by gear. I will look at my data set, and then what I'm using here, which you see with these percentage and greater symbol, is called piping. So that basically feeds your previous data frame into next one. So this is sometimes useful, and you can get this by just saying Control Shift and M, and you can then use this. So we are going to have piping. So I'm saying empty cars. Now this is my original data set where I did a head, or I could have done a view on this one if you would want to see it in a more readable format, and that basically shows me the data. So we are using a different data set, so I want to group it by the gear column. So I'm going to call it by gear, and this one takes my data that is empty cars. I'm using the piping, and then I'm saying group the data based on gear column. That's done. Now let's look at the value of by gear, or you can always do a view. So remember, whenever you're doing a group by, it is giving you a internal object where your data is grouped based on a particular column. So we can look at the values here. You can do a view that shows you your data grouped based on a particular column. Now I can again use the summarize function where I would want to now work on the new one where it was grouped based on gear. So I'm doing a summarize, and here I'm going to say gear 1, which will be having the value of summation on the gear column, and then I'm saying gear 2, which is mean. Well, you could give some meaningful names to this, and let's look at the value of this one where we are basically now looking at the values, which is sum and mean values based on the gear. Similarly, we can look at different example. So we can say by gear, and I'm again using piping, but earlier we had taken gear, we had grouped the data and we called it by gear. So we took our original data set empty cars, but now within this particular data, which was grouped by gear, I will take this data set, I will use the piping and I will summarize it where I am saying within this particular data set, I would want to get the sum or I would want to get the mean, and then you can look at the values. So what you're doing is you are either looking at your original data set or you're looking at the data which was already grouped, and then you can look at the values. Now here what we can do is we can group by cylinder. Say might be you are interested in looking at data which is summarized based on the cylinder column, you can do that. And then for this by cylinder, I'm doing a piping where I'm using the summarize function, and summarizing will then be done based on the mean values of the gear column or the horsepower. So let's do this, and then you can basically look at the value. At any point you may want to look at the data set again, so just do a head and you can look at what does the value contain, and by cylinder or by gear and do a head, and it gives you the value. So you can always do some summarizing or grouping in these ways. Now here we are going to use sample underscore n function and sample underscore fraction for creating samples. So for this, let's take the flights data set again, and we would want to get 15 random values. Now that is done, and it shows me 15 rows with some random values from the data. What you can also do is you can do a portion of data by using sample underscore fraction, and here I'll say flights, I'll say 0.4, which will return 40% of the total data. So this can be useful when you are building your machine learning, where you would want to split your data into training and test. Might be you are interested in some portion of the data, so you can do this, which is very useful function, and then you can look at the value of that. Now what we can also do is we can use a range function. So like we were doing a grouping by, or we were trying to pull out a particular column, so in the same way we can use a range, which is a convenient way of sorting than your base R sorting. So for a range function, let's do a view based on a range. So we will work on the flights data set which we have, and here what we would want to do is we would want to arrange the flights data set which is based on year and departure time, and we are doing a view out of it. So that basically gives me the data which is arranged based on your year and departure time. Now I can do a head to give me some highlighting of that data. Now the piping operator what we are using can be used in these ways also. So here I will say df, I will just assign the data set empty cars to it. Let's look at the df, which has basically your different models. You can obviously look at the head or view of it to look at useful information. We can also go for nesting options, which can be useful. So we are creating a variable called result here. Now that has the arrange function. So what does this arrange function do? So when we would want to use arrange to sort the data, so I would want to sort the data, but what data would I sort? So I will use sample n, which will give me some portion of the data or some sample data. Now what is that sample data? So here we are using nesting. That is, earlier when we did a sample, we just said data and how many random samples we want. But instead of giving that, what we are going to do is we are going to use filter here. Now this filter will work on df. So filtering will happen based on the mileage, which is greater than 20. I will say size is 5, and I would want to basically arrange this in a descending order. So I'm using the des on this particular mileage column. By default, it is always ascending. So let's get the result out of this, which will basically show me the mileage details in a descending order. So this is my data frame, and now we can look at the result, what we have created. So just do a view or do a head and look at the view. So here you see mileage, where the highest value is on the top, and we were only interested in 5 values in our random sample. So that's why when you did a view, it shows your 5 values and it shows in a descending order based on mileage. So we have not only used an inbuilt function, we have not only arranged the data, that is, we have sorted the data, but we have sorted the data based on a descending order on a particular column. We have said the value should be greater than 20, and we have also said we just need 5 random samples. Now let's look at some other examples. So you can always do a multi-assignment. So I can say filter, wherein I'm going to use DF, which was assigned empty cars. I'm going to say mileage should be greater than 20. Then I say B, which is going to get a sample out of A, and I just want 5 random values. So let's look at that. So we have B, which is going to get a set of 5 values from A. Now I will create a result variable which will arrange B, which is sample data, in a descending order. Now let's look at the result of this, and that basically shows me what we were seeing earlier. So you can do a multi-assignment where you can create a variable, get a sample out of it, and then basically whatever is that result, you can arrange that or sort that in a descending or by default descending order. So same thing, we can do it using pipe operator. So piping. So here I will say result. I'm passing in my DF, that's the data set. I'm using piping, and which basically tells what you need to do on this particular data set. So I'm going to filter out the data based on mileage 20. Then I'm going to push that or forward it to get the random sample, and whatever is this random sample is going to be pushed. So you are arranging this in a descending order. So this is one more way of doing it, and then basically you can look at the result. So these are some simple examples where you can use your dplyr with multiple assignments, or using your nesting to filter out the data. You can also do a range, which is to sort the data. You can get some random samples out of it. You can summarize the data. You can also summarize the data based on 1 or 2 or multiple columns, and you can use some inbuilt functions to summarize the data based on some functions which are applied on the variables or on the columns. You can transmute it, where you would be interested in only looking at one column. You can mutate it, where you want to add a new column. You can slice it, and you can give the conditions where you can say and or to filter out the data. So what we can also do is, on this particular data set which we have, say for example DF, where I have my data, let's look at this one. And if I just do a DF at this point, it shows me my data set. And if you would be interested only in particular column, then your dplyr also allows you to, either we can do a filter or we can simply do a select. Now for selecting, we can choose our data. So for example, I'll say df underscore, I'm interested in mileage, I'm interested in horsepower, might be I'm interested in your cylinders in this. And for this one, what I can do is, when I would want to do a select, I can basically say selected df, let's call it some name. I can say control shift m, which is for piping. And then basically what you can do is you can do a select, and you can choose your columns. So I was interested in mileage, I was interested in horsepower, I was interested in cylinder. And here what I'm doing is I'm using a select, where I can look at the new data frame. So let's do this. And I'm sorry, here we will have to give it df. This is where you are passing in your data. Yeah, now this one is done, and we can look at the value of this one by just doing a df or head, on df underscore mileage horsepower cylinder and look at the selected result. So you can be looking at selective columns. I could have done this filter, but filter will always look for a condition. Say your mileage is greater than 20, or might be your cylinders are more than 4 or something else. But when you do a select, you are selecting specific columns. So view always gives you all the columns, head gives you highlight, but then select can be useful when we are interested in looking at only specific data. So this is how you can use dplyr for manipulation, for your data transformation, for basically filtering out the data by selecting particular data and then working on it. So similarly, there is one more package called tidyr, and we'll see how we can use data manipulation done using your tidyr package.
Let's learn about the tidyr package, which makes it easy to tidy your data. And this basically helps you creating a more cleaner data, so which is easy to visualize and model. Now this comes with mainly 4 functions. So you have gather, which makes your data wide, or it makes wide data longer. So that is basically used to stack up multiple columns. You have spread function, which makes long data wider, that is stacking the data together, or stack if you would want to unstack the data to data, and you are talking about data which has same attributes. And then your spread can spread the data across multiple columns. You have separate, which is function which splits single column into multiple columns. And to complement that, you have one more function, which is unite, and that combines multiple columns into single columns. So these are 4 main functions which are used in your tidyr package. So let's look how we work with this. So let me bring up my R Studio here. Now for this, first is, let me just clean up my screen here, doing a Control L. So I will install the package. It is already installed, but we can just do a Control Enter. And then I can say, do you want to restart R prior to reinstall? So install, I'll say okay. And it is basically going to get the package. Now it says package TIDYR, that is tidyr, has been successfully unpacked. Let's use that package using our library function. And that was built under R version 3.6. Now I can basically start using these functions. So for example, here we are creating a data frame. So let's say n is 10. And then we basically would say, we will call it wide. Now that's the variable name. I'm using the data.frame function. I'm saying ID, which will be 1 to n. So that will take the values from 1 to 10. And then these are the values which have 10 entries. So this is a vector, phase 1, phase 2, phase 3. Let's create a data frame out of it. Now that's done. We can have a look at our data frame by just doing a view wide, and that shows me the ID column, and it has phase.1, phase.2, and phase.3. Now we can use our function. So for example, we can work with gather, that is reshaping the data from wide format to long format. And basically you can say stacking up multiple columns. So let's see how we do that. Here I'll call it long. I'm working on wide. I'm using the piping functionality, and then I'm using gather. So this one, I will say what will be the data which I will use. So we are using wide as a data frame. Then I'm saying response time. So that will be basically one more column. And then you have your columns which you would want to basically stack. So I'm saying from phase 1 to phase 3. So let's do this. And once this is done, let's have a look at our variable long. So this one shows me that I have an ID column, I have the response time column, and I have the phase column, which we mentioned. And that basically has all the values stacked in. So you have phase.1, phase.2, and phase.3. So all the columns are being stacked here. So all my data, so now I have totally 30 entries in this one. So this is basically using your gather function. Now sometimes we may want to use a separate function. Now separate function is basically splitting a single column into multiple columns, so which we would want to use when multiple variables are captured in a single variable column. Okay, so let's look at an example of this one. So let's say long separate, that's what we will call. We will work on this long, which has all the data stacked in as the columns we selected. Then I'm saying separate, I want the face column, and then I would say when I separate the columns, what are my column names. Now I could also give a separator by giving a comma and then mentioning the separator if that is required. So let's do this. Now once this is done, let's have a look at our long separate. So what we see here is the column which we used. So we were doing a face column, and that was to be split, and we wanted to split it into target and number. So that's what we see here. So you have face being split into target and number, and then you have the response time. So this is how you use the separate function. Now there is also something called as unite function, which is basically a complementing of separate function. So it takes multiple columns and combines the elements to a single column. So for example, here we will call it long unite, and we will take long separate, which was separating the data. We want to unite, so we will take face, target, number, and we want to have a separator between them. So let's basically do this. And now let's look at the result of this unite. So you see, you have the face and target merged together. So you have face dot one, the separator is dot as we have mentioned, and we have united multiple columns. So this is one more function of your tidyr, which helps you basically tidy up your data or put it in a particular way. Now then you have your spread function, and this is basically for unstacking. So that is, if you would want to convert a stack to data, or if you would want to unstack the data which is of same attributes, spread can be used so that you can spread the data across multiple columns. So it will take two columns, say key and value, and spread it into multiple columns. So it makes long data wider. So we can look at this one. We will say long unite. I'm using the piping. I will use the spread function. I'll work on the face column and response time. And let's do this. And then let's do a view on this. So it tells me our data is back in the shape as it was in the beginning. So these are four functions which are very helpful when we work with tidyr package.
Welcome to this video tutorial on Introduction to SQL by Simplilearn. In this session, we are going to learn about databases, how data is stored in relational databases, and we'll also look at some of the popular databases. Finally, we'll understand various SQL commands on MySQL Server. Now let's get started with what is a database. So according to Oracle, a database is an organized collection of structured information or data that is typically stored electronically in a computer system. A database is usually controlled by a database management system or DBMS. So it is a storage system that has a collection of data. Relational databases store data in the form of tables that can be easily retrieved, managed, and updated. You can organize data into tables, rows, columns, and index it to make it easier to find relevant information. Now talking about some of the popular databases, we have MySQL database, we also have Oracle database, then we have MongoDB, which is a NoSQL database. Next, we have Microsoft SQL Server. Next, we have Apache Cassandra, which is a free and open source NoSQL database. And finally, we have PostgreSQL. Now, let's learn what is SQL. So SQL is a domain-specific language to communicate with databases. SQL was initially developed by IBM. Most databases use structured query language or SQL for writing and querying data. SQL commands help you to store, process, analyze, and manipulate databases. With this, let's look at what a table is. So this is how a table in a database looks like. So here you can see the name of the table is players. On the top, you can see the column names. So we have the player ID, the player name, the country to which the player belongs to, and we also have the goals scored by each of the players.
So these are also known as fields in a database. Here each row represents a record or a tuple. So if you have the player ID, which is 103 here, the name of the player is Daniel, he is from England, and the number of goals he has scored is 7. So you can use SQL commands to query, update, insert records, and do a lot of other tasks. There are mainly 4 types of SQL commands. So first we have data definition language or DDL. So DDL commands change the structure of the table, like creating a table, deleting a table, or altering a table. All the commands of DDL are auto-committed, which means it permanently saves all the changes in the database. We have create, alter, drop, and truncate as DDL commands. Next, we have data manipulation language or DML. So DML commands are used to modify a database. It is responsible for all forms of changes in the database. DML commands are not auto-committed, which means it can't permanently save all the changes in the database. We have select, update, delete, and insert as DML commands. Now select command is also referred to as DQL or data query language. Third, we have data control language or DCL. So DCL commands allow you to control access to data within the database. These DCL commands are normally used to create objects related to user access and also control the distribution of privileges among users. So we have grant and revoke, which are the examples of data control language. Finally, we have something called as transaction control language or TCL. So TCL commands allow the user to manage database transactions. Commit and rollback are example of TCL. Now let's see the basic SQL command structure. So first, we have the select statement. So here you specify the various column names that you want to fetch from the table. We write the table name using the from statement. Next, we have the where clause to filter out our table based on some conditions. So you can see here where condition 1, condition 2, and so on. Then we have the group by clause that takes various column names. So you can write group by column 1, column 2, and so on. Next, we have the having clause to filter out tables based on groups. Finally, we have the order by clause to filter out the result in ascending or descending order. Now talking about the various data types in SQL. So we have exact numeric, which has integer, small int, bit, and decimal. Then we have approximate numeric, which are float and real. Then we have some date and time data types such as date, time, timestamp, and others. Then we have string data type, which includes char, this varchar, and text. Finally, we have binary data types, and binary data types have binary, var binary, and image. Now let's see some of the various operators that are present in SQL. So first we have our basic arithmetic operators. So you have addition, the subtraction, multiplication, division, and modulus. Then we have some logical operators like all, and, any, or, between, exists, and so on. Finally, we have some comparison operators such as equal to, not equal to, this greater than, less than, greater than equal to, or less than equal to, not less than, or not greater than. Now let me take you to my MySQL workbench where we will learn to write some of the important SQL commands, use different statements, functions, data types, and operators that we just learned. Now let me now go ahead and open my MySQL workbench. So in the search bar, I'll search for MySQL workbench. You can see I'm using the 8.0 version. I'll click on it, and here it says welcome to MySQL workbench. And below under connections, you can see I have already created a connection which says local instance. Then you have the root, the local host, and the port number. Let me click on it. You can see the service, the username is root, and I'll enter my password and hit OK. Now this will open the SQL editor. So this is how the MySQL workbench looks like. Here we learn some of the basic SQL commands. So first, let me show you the databases that are already present. So the command is show databases. You can hit tab to autocomplete. I'll use a semicolon. I'll select this, and here on the top you can see the execute button. So if I run this, below you can see the output. It says show databases. 7 rows are returned, which means currently there are 7 databases. You can see the names. Alright, now let's say I want to see the tables that are present inside this database called world. So I'll use the command use world, which is the database name. Now let me run it. So currently I'm using the world database. So to display the tables that are present in the world database, I can use the show command and write show tables. Give a semicolon and I'll hit Control Enter this time to run it. Alright, so you can see the tables that are present inside this world database. So we have 3 tables in total: city, country and country language. Now if you have to see the rows that are present in one of the tables, you can use the select command. So I'll write select star, which basically means I want to display all the columns. So star here means to display all the columns. Then I'll write my from the table name, that is city. So this command is going to display me all the rows that are present inside the city table. So if I hit Control Enter, alright, you can see the message here. It says 1000 rows were returned, which means there were total 1000 records present inside the city table. So here you can see there's an ID column, a name column, this country code, district and population. Alright. Similarly, you can check the structure of the table by using the describe command. So I'll write describe and then I'll give the table name, that is city. Now let's just run it. There you go. The field shows the column names. So we have ID, name, country code, district, population. Type here shows the data type of each of the columns. So district is character 20, ID is an integer, population is also integer. Null says yes or no, which means if no, then there are no null values. If it's yes, which means there are null values in your table. Key here represents whether you have any primary key or foreign key, and these are some extra information. Now let's learn how to create a table in MySQL. So I'll use the create table command for this, and before that let me create a database and I'll name it as SQL intro. So the command is create database and I'll give my database name, that is SQL_intro. Let me give a semicolon and hit Control Enter. So you can see I have created a new database. Now if I run this command, that is show databases, you can see this newly created database, that is SQL intro. If I scroll down, there you go, you can see the name here, SQL intro. Okay, now within this database we'll create a table called employee details. Now this will have the details of some employees. So let me first show you how to create a table that will be present inside the SQL intro database. So I'll use the command create table and then I'll give my table name, that is going to be employee_details. Next, the syntax is to give the column names. So my first column would be the name column, which is basically the employee name, followed by the data type for this column. Since name is a text column, so I'll use varchar and I'll give a value of 25. So it can hold only 25 characters. Okay. Next, I also want the age of the employee. Now age is always an integer, so I'll give int. Okay. Then we can have the gender of the employee. So gender can be represented as F or M, F for female and M for male. So I'm using the char data type or character data type and I'll give the value as 1. Then let's have the date of join or DOJ, and this is going to be of data type date. Alright. Next, we'll have the city name, that is the city to which the employee belongs to. So again, this is going to be varchar 15. Finally, we'll have a salary column, and salary we'll keep it as float, since salary can be in decimal numbers as well. Now I'll give a semicolon. Alright, so let me just quickly run through it. So first I wrote my create command, then the table, which is also a keyword, followed by
the table name, which is employee details here, and then we gave the column names such as name, age, this gender, date of join, city, and salary. For each of the columns, we also give the data type. Alright, so let me just run it. Okay, so here you can see we have successfully created our first table. Now you can use the describe command to see the structure of the table. I'll write describe emp underscore details. If I run this, there you go. So under field you can see the column names, then you have the data types. Null represents if the table can accept null values or not, and these are basically empty, and we haven't set any default constraint. Alright, moving ahead, now let's learn to add data to our table using the insert command. So on a notepad I have already written my insert statement, so let me just copy it and then I'll explain it one by one. Alright, so if you see this, so we have used an insert into statement or a command followed by the table name, that is emp details. Then this is the syntax. Using values I have passed in all the records. So first we have Jimmy, which is the name of the employee, then we have 35, which basically represents the age, then M means the gender or the sex, then we have the date of join, next we have the city to which the employee belongs to, and finally we have the salary of the employee. So this particular information represents one record or a tuple. Similarly, the next employee we have is Shane. You can see the age and other information. Then we have Mary, there's Dwayne, Sarah, and Amy. Alright, so let me go ahead and run this. So this will help you insert the values in the table that you have created. You can see we have successfully inserted 6 records. Now to display the records, let me use the select statement. So I'm using select star from emp underscore details. If I run this, you can see my table here and the values it has. So we have the name column, the age column, the state of join, city, salary, and these are the values that you can see here. Moving ahead, now let's say you want to see the unique city names present in the table. So in this case, you can use the distinct keyword along with the column name in the select statement. So let me show you how you can print the distinct city names that are present in our table. Now if you notice this table clearly, we have Chicago, Seattle, Boston, Austin, there's New York, and there's Seattle repeated again. So I only want to print the unique values. So for that I can write my select statement as select distinct, then I'll give my column name, which is city, from my table name, that is emp details. If I run this, you can see my query has returned 5 rows and these are the values. So we have Chicago, Seattle, which was repeated twice, is just been shown once. Then we have Boston, Austin, and New York.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now let's see how you can use inbuilt aggregate functions in SQL. So suppose you want to count the number of employees in the table. In that case, you can use the count function in the select statement. So let me show you how to do that. So I'll write select. I'll use my function name, that is count. Now since I want to know the total number of employees, I'm going to use their name inside the brackets from employee underscore details. Now if I run this, this will return the total number of employees that are present in the table. So we have 6 employees in total. Now if you see here in the result, it says count name. Now this column is actually not readable at all. So what SQL provides is something called as an alias name. So you can give an alias to the resultant output. So here I can write select count of name and use an alias as I can give an alias as
count underscore name and run this statement again. There you go. You can see here in the resultant output we have the column name as count name, which was our alias name. Now suppose you want to get the total sum of salaries, you can use another aggregate function called sum. So I'll write my select statement, and this time instead of count I'm going to write sum, and since I want to find the sum of salaries, so inside the bracket I'll give my salary column from my table name, that is employee details. If I run this will result in the total sum of salaries. So basically it adds up all the salaries that were present in the salary column. Now let's say you want to find the average salary, so instead of sum you can write the average function, which is avg. So this will give you the average salary from the column salary. So you can see it here, this says average salary. Now if you want, you can give an alias name to this as well. Now you can select specific columns from the table by using the column names in the select statement. So initially we were selecting all the columns. For example, like you saw here, the star represents that we want to see all the columns from the employee details table. Now suppose you want to see only specific columns, you can mention those column names in the select statement. So let's say I want to select just the name, age and the city column from my table, that is employee details. So this will result in displaying only the name, age and city column from the table. If I run it, there you go. It has given only 3 columns to me. Now SQL has a where clause to filter rows based on a particular condition. So if you want to filter your table based on specific conditions, you can use where clause. Now where clause comes after you give your table name. So suppose you want to find the employees with age greater than 30. In this case you can use a where clause. So let me show you how to do it. I'll write select star from my table name, that is employee details, and after this I'll use my where clause. So I'll write where age greater than 30. If I run this, it will give me the output where the age is only greater than 30. So it excluded everything that is less than 30. So we have 4 employees whose age is greater than 30 here. Now suppose you want to find only female employees from the table, you can also use a where clause here. So I'll write select, let's say I want only the name, the gender, which is sex here, comma city from my table, that is employee details, where I'll give my column name, that is sex, is equal to, since I want only the female employees, I'll give F and run this statement. Okay, you can see here our employee table has 3 female employees. Now suppose you want to find the details of the employees who belong to Chicago or Austin. In this case you can use the OR operator. Now the OR operator in SQL displays a record if any of the conditions separated by OR is true. So let me show you what I mean. So since I want the employees who are from Chicago and Austin, I can use an OR operator. So I'll write select star from emp details, which is my table name. Then I'll give my where clause, where city equal to, I'll give my city name as Chicago, and then I'm going to use the OR operator, or city equal to, I'll write Austin. I'll give a semicolon and let me run it. There you go. So in the output you can see all the employees who belong to the city Chicago and Austin. Now there is another way to write the same SQL query. So you can use an in operator to specify multiple conditions. So let me just copy this, and instead of using the OR operator, this time I'm going to use the in operator. So I'll delete this. After the where clause I'm going to write where city and use the in operator. Inside bracket, I'll give my city names as Chicago and I want Austin. So I'll give a comma and write my next city name, that is Austin. So this query is exactly the same that we wrote on top. Let me run this. You will get the same output. There you go. So we have Jimmy and Dwayne, who are from Chicago and Austin respectively. Now SQL provides the between operator that selects values within a given range. The values can be numbers, text or dates. Now suppose you want to find the employees whose date of join was between 1st of Jan 2000 and 31st of December 2010. So let me show you how to do it. I'll write select star from EMP details where my date of join, that is DOJ, between, I'll give my two date values, that is 1st of Jan 2000 and I'll give my second value, the date value, that is 31st of December 2010. So every employee who has joined between these two dates will be displayed in the output. If I run it, we have two employees who had joined between 2000 and 2010. So we have Jimmy and Mary here, who had joined in 2005 and 2009 respectively. Alright. Now in where clause, you can use the AND operator to specify multiple conditions. Now the AND operator displays a record if all the conditions separated by AND are true. So let me show you an example. I'll write select star from employee details table where I want the age to be greater than 30 and I want sex to be male. Alright, so here you can see I have specified two conditions. So if both the conditions are true, only then it will result in an output. If I run it, you can see there are two employees who are male and their age is greater than 30. Now let's talk about the group by statement in SQL. So the group by statement groups rows that have the same values into summary rows. Like for example, you want to find the average salary of customers in each department. Now the group by statement is often used with aggregate functions such as count, sum and average to group the result set into one or more columns. Let's say we want to find the total salary of employees based on their gender. So in this case you can use the group by clause. So I'll write select, let's say sex, comma, I want to find the total sum of salary as I'll give an alias name, let's say total salary, from my table name, that is employee details. Next I'm going to group it by sex. Okay, let me run it. There you go. So we have two genders, male and female, and here you can see the total salary. So what this SQL statement did was, first it grouped all the employees based on the gender and then it found the total salary. Now SQL provides the order by keyword to sort the result set in ascending or descending order. Now the order by keyword sorts the records in ascending order by default. To sort the records in descending order, you can use the DESC keyword. So let's say I want to sort my employee details table in terms of salary. So I'll write select star from EMP underscore details and I'll use my order by clause on the salary column. So this will sort all the records in ascending order of their salary, which is by default. You can see the salary column is sorted in ascending order. Now suppose you want to sort the salary column and display it in descending order, you can use this keyword, that is DESC. Let me run it. You can see the output. Now this time the salary is sorted in descending order and you have the other values as well. Now let me show you some basic operations that you can do using the select statement. So suppose I write select and do an addition operation, let's say 10 plus 20, and I'll give an alias name as addition. If I run this, it will give me the sum of 10 and 20, that is 30. Similarly, you can use the subtraction operator and you can change the alias name as, let's say, subtract. Let's run it. You get minus 10. Now there are some basic inbuilt functions. There are a lot of inbuilt functions in SQL, but here I'll show you a few. Suppose you want to find the length of a text or a string, you can use the length function. So I'll write select and then use the length function. I'll hit tab to autocomplete. Let's say I want to find the length of country India, and I'll give an alias as total length. If I run it, you see here it returns 5 because there are 5 letters in India. There's another function called repeat. So let me show you how repeat works. So I'll write select repeat. Let's say I want to repeat the symbol that is at the rate. I'll put it in single quotes because it is a text character, and I want to repeat this character for 10 times. Close the bracket and let's run it. You can see here in the output it has printed at the rate 10 times. You can count it. Alright. Now let's say you want to convert a text or a string to uppercase or lowercase. You can do that as well. So I'll write select and use the function called upper. Let's say I want to convert my string, that is India, to uppercase. I'm not giving in any alias name. If I run this, see, my input was capital I and everything else was in small letter. In the output you can see it has converted my input to all caps. Similarly, you can change this. Let's say you want to print something in lowercase, you can use the lower function. Let's say this time everything is in uppercase. If I run it, it converts India to lowercase. Now let's explore a few date and time functions. Let's say you want to find the current date. There's a function called CUR, which stands for current, and this is the function I'm talking about, which is current date. If I run this, you will get the current date, that is 28th of Jan 2021. And let's say you want to extract the day from a date value, so you can use the day function. Let's say I'll use day and I want to find the day from my current date. If I run this, you get 28, which is today's day. Now similarly, you can also display the current date and time. So for that you can use a function that is called now. So this will return the current date and time. You can see this is the date value and then we have the current time. Alright, and this brings us to the end of our demo session. So let me just scroll through whatever we have learned. So first I showed you how you can see that databases present in MySQL. Then we used one of the databases and checked the tables in it. Then we created another database called SQL Intro for our demo purpose. We used that database and then we created this table called employee details with column names like name, integer, the sex, date of join, city and salary. I showed you the structure of the database. Let me run this again so you get an idea. You can see this was the structure of our table. Then we went ahead and inserted a few records. So we inserted records for 6 employees. So you have the employee name, the age, the gender, the date of join, the city to which the employee belongs to, and the salary of the employee. Then we saw how you can use the select statement and display all the columns present in the table. We learned how you can display the unique city names. We learned how to use different aggregate functions like count, average and sum. Then we learned how you could display specific columns from the table. We learned how to use where clause. Then we used an OR operator. We learned about in operator.
the between operator, then we used an AND operator to select multiple conditions. Finally, we learnt about group by, order by, and some basic SQL operations. We are going to learn two important SQL statements or clauses that are widely used, that is group by and having. First, we'll understand the basics of group by and having, and then jump into MySQL Workbench to implement these statements. So let's begin. First, what is group by in SQL? So the group by statement or clause groups records into summary rows and returns one record for each group. It groups the rows with the same group by item expressions and computes aggregate functions for the resulting group. A group by clause is a part of select expression. In each group, no two rows have the same value for the grouping column or columns. Now below, you can see the syntax of group by. So first we have the select statement, and then followed by the column names that we want to select. From, we have the table name, followed by the where condition, and next we have the group by clause, and here we include the column names. Finally, we have the order by and the column names. Now here is an example of the group by clause. So we want to find the average salary of employees for each department. So here you can see we have the employees table. It has the employee ID, the employee name, the age of the employee, we have the gender, the date on which the employee had joined the company, then we have the department to which each of these employees belong to, we have the city to which the employees belong to, and then we have the salary in dollars. So actually we'll be using this employees table on MySQL Workbench as well. So if you were to find the average salary of employees in each department, so this is how your SQL query with group by clause would look like. So we have selected department, and then we are using an aggregate function that is AVG, which is average, and we have chosen the salary column, and here we have given an alias name which is average underscore salary, which appears in the output, you can see here, from employees, and we have grouped it by department. So here in the output you can see we have the department names and the average salary of the employees in each department. Now let me take you to my MySQL Workbench, where we will implement group by and solve specific problems.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Okay, so I am on my MySQL Workbench. So let me make my connection first. I'll enter the password. So this will open my SQL editor. So first of all, let me check the databases that I have. So I'll use my query that is show databases. Let's run it. Okay, you can see we have a list of databases here. I'm going to use my SQL underscore intro database. So I'll write use SQL underscore intro. So this will take us inside this database. I'll run it. Alright. Now you can check the tables that are present in SQL underscore intro database. If I write show tables, you can see the list of tables that are already present in this database. To do our demo and understand group by as well as having, let me first create an employee table. So I'll write create table employees. Next, I'll give my column name as employee underscore ID, which is the ID for each employee. I'll give my data type as integer, and I'll assign employee ID as my primary key. Next, I'll give employee underscore name, and my data type would be varchar. I'll give the size as 25. My third column would be the age column. Age would obviously be an integer. Then I have my gender column. I'll use character data type and assign a value of 1 or size of 1. Next we have the date of join, and the data type will be date. We have the department column as well. This is going to be of varchar, and 20 will be the size. Next, we have the city column, which is actually the city to which the employee belongs to. And finally, we have the salary column, which will have the salary for all the employees. Okay, now let me select and run this. You can see here we have successfully created our table. Now to check if our table was created or not, you can use the describe command. I'll write describe employees. You can see the structure of the table so far. Alright, now it's time for us to insert a few records into this employees table. So I'll write insert into employees, and I'll copy paste the records which I have already written on a notepad. So let me show you. So this is my EMP notepad, and you can see I have already put the information for all the employees. So let me just copy this and we'll paste it here. Alright, let me go to the top and verify if all the records are fine. Alright, so let's run our insert query. Okay, so you can see here we have inserted 20 rows of information, and now let's check the table information or the records that are present in our employees table. I'll write select star from employees. If I run it, you can see here I have my employee ID, the employee name, age, gender, we have the city, salary, and in total we have inserted 20 records. Now let me run a few SQL commands to check how the structure of our table is. Let's say I want to see the distinct cities that are present in our table. So I'll write select distinct city from employees. If I run this, you see here there are total 8 different cities present in our employees table. So we have Chicago, there's Seattle, Boston, we have New York, Miami, and Detroit as well. Now let's say you want to know the total number of departments that are present. So you can use distinct department. If I run this, alright, you can see we have 7 rows returned, and here are the department names. So we have sales, marketing, product, tech, IT, finance, and HR. Alright, now let me show you another SQL command. Now this is to use an aggregate function. So I want to find the average age of all the employees from the table. So I can write select AVG, which is the aggregate function for average. Inside that I have passed my age column from employees. If I run this, so the average age of all the employees in our table is 33.35. Now say you want to find the average age of employees in each department. So for this you need to use the group by clause. I'll give a comment here. I want to find the average age in each department. So I'll write select department, comma, I'll write average of age from employees group by department. Now if I run this, you can see here we have our 7 departments on the left, and on the right you can see the average age of employees in each of these departments. Now you can see here in the output it says AVG of age, which is not readable, so I can give an alias name as average age. Alright, I can bring this down, and if you want you can round the values also.
So you can round the decimal places. So I'll use a round function before the average function, and the round function takes two parameters. One is the variable and the decimal place you want to round it to. So if I run this, there you go. You can see here we have the average age of all the employees in each of these departments. Alright. Now suppose you want to find the total salary of all the employees for each department. So you can write select department, comma. Now I want the total salary, so I'll use the sum function and I'll pass my column as salary from employees group by department. Let's run this query. You can see here in the output we have the different departments, and on the right you can see the total salary of all the employees in each of these departments. Now here also you can give an alias name as total underscore salary. Let's run it again and you can see the output here. Alright, now moving ahead, you can also use the order by clause along with the group by clause. Let's say you want to find the total number of employees in each city and group it in the order of employee ID. So to do this, I can use my select query. I'll write select count of, let's say, employee ID, and I want to know the city as well, from employees group by city, and next you can use the order by clause. I'll write order by count of employee ID, and I'll write DESC, which stands for descending. If I run this query, you can see here on the left you have the count of employees, and on the right you can see the city names. So in Chicago we had the highest number of employees working, that was 4. Then we had Seattle, Houston, Boston, Austin, and the remaining also had 2 employees. So in this case we have ordered our result based on the count of employee ID in descending order. So we have the highest number appearing at the top and then followed by the lowest. Okay, now let's explore another example. Suppose we want to find the number of employees that joined the company each year. We can use the year function on the date of joining column. Then we can count the employee IDs and group the result by each year. So let me show you how to do it. So I'll write select. I'm going to extract year from the date of join column. I'll give an alias as year. Next, I'll count the employee ID from my table name, that is employees, and I'm going to group it by year, date of join. I give a semicolon. Alright, so let's run this. Great. You see here in the result we have the year that we have extracted from the date of join column, and on the right you can see the total number of employees that joined the company each year. So we have in 2005 there was 1 employee. Similarly we have in 2009 there were 2 employees. If I scroll down, you have information of other years as well. Now if you want, you can order this as well based on year or count. Okay. Now you can also use the group by to join 2 or more tables together. So to show you this operation, let me first create a sales table. So I'll write create table sales, and the sales table will have columns such as the product ID, which is going to be of integer type. Then we have the selling price of the product. Now this will be a float value. Then we have the quantity sold for each of the products. So I'll write quantity. Quantity will be of integer type. Next we have the state in which the item was sold, and state I'll put it as varchar and give the size as 20. Let's run this so that we'll create our sales table. Alright, so we have successfully created our sales table. Next we need to insert a few values to our sales table. So I have already written the records in a notepad. Let me show you. Okay, so here you can see I have my sales text file. Let me just copy these information. I'll just paste it on the query editor. Okay, now let me go ahead and run this insert command. Alright, so you can see here we have successfully inserted 9 rows of information. So let me just run it through what we have inserted. So the first column is the product ID column. Then we have the selling price at which this product was sold. Then we have the quantity that was sold and in which state it was sold. So we have California, Texas, Alaska. Then we have another product ID which is 123, and these are the states in which the products were sold. So let me just confirm with the select statement. I'll write select star from sales. If I run this, you can see we have successfully created our table. Okay, now suppose you want to find the revenue for both the product IDs 121 and let's say 123, since we have just 2 product IDs here. So for that you can use the select query. So I'll write select product ID. Next I want to calculate the revenue. So revenue is nothing but selling price multiplied by the quantity. So I'll use the sum function to find the total revenue, and inside the sum function I'll use my selling price column multiplied by my quantity column. I'll give this an alias name as revenue from my table name, that is sales. Finally I'll group it by product ID. Let's run it. There you go. So here you can see we have the 2 product IDs 121 and 123, and here you can see the revenue that was generated from these 2 products. Alright, now let's say we have to find the total profit that was made from both the products 121 and 123. So for that I'll create another table. Now this table will have the cost price of both the products. So let me create the table first. I'll write create table. Let's say the table name is C product, which stands for the cost price of the products. I'll give my first column as product ID. This will be an integer, and I'll have my second column as cost price. Cost price will have floating type values. Let's run this. So we have successfully created our product cost table. Now let me insert a few values into the C product table. So I'll write insert into C underscore product. I'll give my values for 121. Let's say the cost price was $270 for each, and next we have my product as 123, and let's say the cost price for product 123 was $250. Let's insert these 2 values. Okay, next we'll join our sales table and the product cost table. So this will give us the profit that was generated for each of the products. So I'll write select C dot product underscore ID, comma, I'll write sum S dot cell underscore price. Now here C and S are alias names. So if I subtract my cost price from the selling price, that will return the profit that was generated. I'll multiply this with S dot quantity, close the bracket. I'll give an alias name as profit from sales as S. So here S stands for the sales table. I'm going to use inner join C underscore product table as the alias name should be C, where S dot product underscore ID is equal to C dot product underscore ID. We are using product underscore ID because this column is the common column to both the tables. And finally, I am going to group it by C dot product underscore ID. Alright. So let me tell you what I have done here. So I am selecting the product ID. Next, I am calculating the profit by subtracting the cost price from the selling price, and I have multiplied the quantity column. I am using an inner join to connect my sales and the product cost table, and I am joining on the column that is product ID, and I have grouped it by C dot product ID. Let's run this. There you go. So here you can see for product ID 121, we made a profit of $1,100, and for product ID 123, we made a profit of $840. So now that we have learnt group by in detail, let's learn about the having clause in SQL. The having clause in SQL operates on grouped records and returns rows where aggregate function results matched with given conditions only. So now having and where clause are kind of similar, but where clause can't be used with an aggregate function. So here you can see the syntax of having clause. You have the select statement followed by the column names from the table name, then we have the where conditions, next we have the group by, finally we have having, and at last we have order by column names. So you can see here we have a question at hand. We want to find the cities where there are more than 2 employees. So you can see the employee table that we had used in our group by clause as well. So if you were to find the cities where there are more than 2 employees, so this is how your SQL query should look like. So we have selected the employee ID and we are finding out the count using the count function. Next we have selected the city column. From employees, we have grouped it by city, and then we have used our having clause. So we have given our condition having count of employee ID should be greater than 2. So if you see the output, we have the different city names, and these were the cities where the count of employees was greater than 2. Alright, so let's go to our MySQL workbench and implement how having works. So suppose you want to find those departments where the average salary is greater than $75,000. You can use the having clause for this. So let me first run my table, which is employees. If I run this, you can see we had inserted 20 rows of information, and the last column we had was salary. So the question we have is, we want to find those departments where the average salary is greater than $75,000. So let me show you how to do it. So I'll write select department, comma, I'll use the aggregate function that is average salary. I'll give an alias name as avg underscore salary from employees, Next, we'll use the group by clause, and I want to group it by each department. And then I'm going to write my having clause. So in having clause, I'll use my condition, that is having average of salary greater than $75,000. Let's run it and see the output. There you go. So here you can see there were total 3 departments in the company, that is sales, finance and HR, where the average salary is greater than $75,000. Okay. Next, let's say you want to find the cities where the total salary is greater than $200,000. So this will again be a simple SQL query. So I'll write select city, comma, I want to find the total salary, so I'll use the sum function and I'll pass my column as salary, as I'll give a alias name as total from employees group by city, and then I am going to use my having clause. I'll pass in my condition as having sum of salary greater than $200,000. Alright, so let's run this query. There you go. So the different cities are Chicago, Seattle and Houston, where the total salary was greater than $200,000. Now suppose you want to find the departments that have more than 2 employees. So let's see how to do it. I'll write select department, comma, this time since I want to find the number of employees, I'm going to use the count function. I'll write count star as employee underscore count or emp underscore count, which is my alias name, from employees. Next, I'll group it by department, having, I'll give my condition count star greater than 2. Let's run this. Okay, so you have departments such as sales, product, tech and IT, where there are more than 2 employees. Okay, now you can also use a where clause along with the having clause in an SQL statement. So suppose I want to find the cities that have more than 2 employees apart from Houston. So I can write my query as select city, comma, count star as emp count from employees, where I'll give my condition city not equal to Houston. I'll put it in double quotes since I don't want to see the information regarding Houston. I'll group it by city, having count of employees greater than 2. So if I run this query, you see we have information for Chicago and Seattle only, and we have excluded the information for Houston. Now you may also use aggregate functions in the having clause that does not appear in the select clause. So if I want to find the total number of employees for each department that have an average salary greater than $75,000, I can write it something like this. So select department, comma, count star as emp count from employees group by department, and in the having clause I'm going to provide the column name that is not present in the select expression. So I'll write having average salary greater than 75,000.
This is another way to use the having clause. Let's run this. Alright, you can see we have department sales, finance and HR, and you can see the employee count where the average salary was greater than 75,000. Okay. So let me run you from the beginning what we did in our demo. So first we created a table called employee, then we inserted 20 records to this table. Next we explored a few SQL commands like distinct, then we used average, and finally we started with our group by clause, followed by looking at how group by can be used along with another table, and we joined two tables, that was sales and product cost table, to find out the profit. Then you learned how to use the having clause. So we explored several different questions and learned how to use having in SQL. We will learn about joins in SQL. Joins are really important when you have to deal with data that is present on multiple tables. I'll help you understand the basics of joins and make you learn the different types of joins with hands-on demonstrations on MySQL Workbench. So let's get started with what are joins in SQL. SQL join statement or command is often used to fetch data present in multiple tables. SQL joins are used to combine rows of data from two or more tables based on a common field or column between them. Now consider this example where we have two tables, an orders table and a customers table. Now the order table has information about the order ID, which is unique here. We have the order date, that is when the order was placed. Then we have the shipped date. This has information about the date on which the order was shipped. Then we have the product name, which basically is the names of different products. We have the status of delivery, whether the product was delivered or not, or whether it was cancelled. Then we have the quantity, which means the number of products that were ordered. And finally we have the price of each product. Similarly, we have another table called customers, and this customer table has information about the order ID, which is the foreign key here. Then we have the customer ID, which is the primary key for this table. We also have the phone number, customer name and address of the customers. Now suppose you want to find the phone numbers of customers who have ordered a laptop. Now to solve this problem, we need to join both the tables. The reason being, the phone numbers are present in the customers table, as you can see here, and laptop, which is the product name, is present in the orders table, which you can see it here. So using a join statement, you can find the phone numbers of customers who have ordered a laptop. Now let's see another problem where you need to find the customer names who have ordered a product in the last 30 days. In this case, we want the customer name present in the customers table and the last 30 days order information, which you can get from the order date column that is present in the orders table. Okay, now let's discuss the different types of joins one by one. So first we have an inner join. So the SQL inner join statement returns all the rows from multiple tables as long as the conditions are met. From the diagram above, you can see that there are two tables, A and B. A is the left table and B is the right table. The orange portion represents the output of an inner join, which means an inner join returns the common records from both the tables. Now you can see the syntax here. So we have the select command and then we give the list of columns from table A, which you can see here is the left table, followed by the inner join keyword and then the name of the table, that is B, on a common key column from both the tables A and B. Now let me take you to the MySQL Workbench and show you how inner join works in reality. So here I'll type MySQL. You can see I have got MySQL Workbench 8.0 version installed. I'll click on it. So it will take some time to open. Okay, I'll click on this local instance and here I'll give my password. Okay, so this is how an SQL editor on MySQL Workbench looks like. So first of all, let me go ahead and create a new database. So I'll write create,
database. This is going to be my command, followed by the name of the database, that is going to be SQL_joins. If I give a semicolon and hit Control Enter, this will create a new database. You can see here one row affected. Now you can check whether the database was created or not using show databases command. If I run it, here you can see I have SQL joins database created. Now I'll use this database, so I'll write use SQL_joins. Okay. Now to understand inner join, consider that there is a college, and in every college you have different teams for different sports such as cricket, football, basketball and others. So let's create two tables, cricket and football. So I'll write create table, and my table name is going to be cricket. Next, I'm going to create two columns in this table. The first column is going to be cricket ID. Then I'm going to give the data type as int and use the auto increment operator. I'm using auto increment because my cricket ID is going to be my primary key. Then I'm going to give the name of the students who are part of the cricket team, and for this I'll use varchar data type and give the length as 30. I'll give another comma and I'll assign my cricket ID as primary key. Within brackets I'll give cricket_ID. Cricket ID is nothing but a unique identifier for each of the players, like you have roll numbers in college. Okay, let me just run it. Alright, so we have successfully created our cricket table. Similarly, let me just copy this and I'll paste it here. I'll create another table called football. This will have the information of all the students who are part of the football team, and instead of cricket I am going to give this as football ID. Alright, and the name column will have the names of the students. I'll change my primary key to football ID. Alright, let me run this. Okay, so now we have also created our football table. The next step is to insert a few player names into both the tables. So I'll write my insert into command. First, let's load some data to our cricket table. So I'll write cricket and I'll give my name column followed by values, and here I'll give some names such as, let's say, Stuart. I'll give another comma. The next player I'll choose is, let's say, Michael. Similarly, I'll add a few more. Let's say we have Johnson. The fourth player I'll take is, let's say, Hayden. And finally we have, let's say, Fleming. Okay. Now I'll give a semicolon and run this. Okay, so let me just check if all the values were inserted properly. For this I'll use select star from table, that is cricket. If I run it, you can see I have created a table and have successfully inserted 5 rows of information. Now similarly, let's insert a few student names for our football table. So I'll change this to football, and obviously there would be students who will be part of both cricket and football team. So I'll keep a few repeated names. Let's say Stuart, Johnson, and let's say Hayden are part of both cricket and football team. Then we have, let's say, Langer, and let's say we have another player in the football team, that is Aston. I'll just run it. Okay, you can see there are no errors. So we have successfully
inserted values to our football team as well. Let me just recheck it. I'll write select star from football. Alright, so we have 5 players in the football team as well. Okay, now the question is, suppose you want to find the students that are part of both the cricket and football team. In this case, you can use an inner join. So let me show you how to do it. So I'll write select star from cricket, as I'm using an alias name as C, which stands for cricket. Then I'm going to write inner join. My next table is going to be football as F, which is an alias name for the football table. Then I'm going to use the on command or operator, and then I'll give the common key, that is name here. So c dot name is equal to f dot name. So based on this name column from both the table, my inner join operation will be performed. So let's just run it. There you go. So Stuart, Johnson and Hayden are the only 3 students who are part of both the teams. Alright. Now you can also individually select each of the columns from both the tables. So let's say I write select c dot cricket underscore id, comma c dot name, comma f dot football underscore id, comma f dot name. From, I'll write cricket as C, inner join football as F on C dot name is equal to F dot name. Now if I run this, you see we get the same output here as well. Alright. Now let's explore another example to learn more about inner joins. So we have a database called classic models. Let me first use classic models. I'll run this. Okay, now let me just show the different tables that are part of classic tables. Alright, so here you can see there are tables like customers, there's employees, office, there's office details, orders, payments, products and product lines as well. Alright, so let me use my select statement to show what are the columns present in the products table. Okay, so this product table has information about different product names. You have the product code. Now this product code is unique here. We also have the product vendor, a little description about the product. Then we have the quantity in stock, buying price and MSRP. Let's see what we have in product lines. If I run it, you see here we have the product line, which is the primary key for this table. Then we have the textual description for each of the products. This is basically some sort of an advertisement. Alright, now suppose you want to find the product code, the product name and the text description for each of the products. You can join the products and product lines table. So let me show you how to do it. I'll write my select statement and choose my columns as product code. Then we have product name, and let's say I want the text description. So I'll write this column name. Okay, then I'll use from my first table, that is products, inner join product lines. I can use using the common key column, that is product line. Close the bracket, I'll give a semicolon, and if I run it, there you go.
So you can see the different product codes, then we have the different product names and the textual description for each of the products. So this we did by joining the products table and the product lines table. Alright. Now suppose you want to find the revenue generated from each product order and the status of the product. To do this task, we need to join three tables, that is orders, order details and products. So first let me show you what are the columns we have in these three tables. We have obviously seen for the products table. Now let me show you for orders and order details table. So I'll write select star from orders. If I run it, you can see it has information about the order number, the date on which the order was placed. We also have the shipment date. We also have the status column which has information regarding whether the order was shipped or cancelled. Then we have some comments column. We also have the customer number who ordered this particular product. Similarly, let's check what we have under order details. So I'll write select star from order details. If I run it, you can see it has the order number, the product code, quantity of each product, we have the price of each product, then we have the order line number. Okay, so using the product orders and order details, let's perform an inner join. So I'll write select O dot order number comma O dot status comma I need the product name which I'll take from the products table, so I'll write p dot product name. Now here O, P are all alias name for the tables, orders, products, and I'll use OD for order details, comma since we want to find the revenue, we actually need to find the product of quantity ordered into price of each product. So I'll use a sum function, and inside the sum function I'll give quantity ordered multiplied by the price of each item. I'll use an alias as revenue. Then I'll use my from clause from orders as O, inner join order details as I'll use an alias name as OD, on I'll write O dot order number is equal to OD dot order number. I'll use another inner join, and this time we'll join the products table. So I'll write inner join products as P on P dot product code is equal to OD dot product code. And finally I'll use the group by clause and group it by order number. Alright, let me run this. Okay, there's some mistake here. We need to debug this. It says you have an error in your SQL syntax. Check the manual. Alright. Okay, I think the name of the tables is actually orders and not order. Alright, now let's run it. Okay, there's still some error. It says classic models dot product doesn't exist. So again, the product name is, the table name is products and not product. So let's run it again. Alright, there you go. So we have the order number, the status, the product name and the revenue. This we got it using inner join from three different tables.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now talking about left joins, The SQL left join statement returns all the rows from the left table and the matching rows from the right table. So if you see this diagram, you can see we have all the rows from the left table, that is A, and only the matching rows from the right table, that is B. So you can see this overlapped region. And the syntax for SQL left join is something like this. So you have the select statement and then you give the list of columns from table A, which is your left table. Then you use the left join keyword followed by the next table, that is table B, on the common key column. So you write A dot key is equal to B dot key. Okay, now in our classic models database we have two tables, customers and orders. So if you want to find the customer name and their order ID, you can use these two tables. So first let me show you the columns that are present in customers and orders. I think orders we have already seen. Let me first show you what's there in the customers table. Okay, so you can see we have the customer number, the name of the customer, then we have the contact last name, the contact first name, we have the phone number, then there's an address column. There are two address columns actually. We have the city name, the state, and we have other information as well. And similarly we have our orders table. So I'll write select start from orders. So I'll write select star from orders. If I run this, you can see these are the information available in the orders table. Okay, so let's perform a left join where we want to find the customer name and their order IDs. So I'll write select c dot customer name, or let's say first we'll choose the customer number, comma, then I want the customer name, so I'll write c dot customer name. Then we have the order number column which is present in the orders table, and let's say I also want to see the status. Then I'll give my left table, that is customers as C, left join, orders as O, on C dot customer number equal to O dot customer number. Let's run it. Okay, again there is some problem. Alright, so the table name is customers. Let's run it. So there's another mistake here. This is customer number, so B is missing. Cool. Let me run it. Alright, so here you can see we have the information regarding the customer number, then the respective customer names, we have the order number and the status of the shipment. So if I scroll down, you'll notice one thing, there are a few rows you can see which have null values. This means for customer number 125 and for this particular customer name there were no orders. And similarly if I scroll down, you will find a few more null values. You can see here there are two null values here. For customer number 168 and 169 there were no orders available. Alright, now to check those customers who haven't placed any orders, you can use the null operator. So what I'll do is here I'll just continue with this. I'll use a where clause and write where order number is null. Now let me run this. Okay, so here you can see there are 24 customers from the table that don't have any orders in their names. Okay, now talking about right joins. So SQL right join statement returns all the rows from the right table and only matching rows from the left table. So here you can see we have our left table as A and the right table as B. So the right join will return all the rows from the right table and only the matching rows from the left table. Now talking about the syntax. So here you can see we have the select statement. Followed by the select statement, you will have the list of columns that you want to choose from table A, right join table B on the common key column from both the tables. Alright.
Now to show how right join works, I'll be using two tables, that is customers and employees. So let's see the rows of data that are present in the customer table first. So I'll write select star from customers. Let's run it. So here you have the customer number, the customer name, then we have the phone number, the address of the customers. You also have the country to which the customer belongs to, the postal code, and the credit limit as well. Similarly, let's see for the employees table. Here I'll change customers to employees. Let's run it. Okay, so we have the employee number, the last name, the first name, we have the extension, the email ID, the job title, and also reports to here means the manager. Okay, so based on these two tables, we'll find the customer name, the phone number of the customer, and the email address of the employee, and join both the tables, that is customers and employees. So let me show you the command. So I'll write select c dot customer name, comma, then we have c dot phone. I'll give a space here. Next, I want the employee number from the employee table, so I'll write e dot employee number, comma, e dot email from customers as C, right join employees as E on E dot, my common key column is employee number here, so I'll write E dot employee number is equal to C dot, we have sales representatives employee number, and I'm also going to order it by the employee number column. Okay, so you can see I have my customer name selected from the customers table, the phone number of the customer, then we have the employee number and the email address. So let me run it. Okay, there's some problem. Alright, so the table name is customers actually. Let's run it once again. There you go. So you can see here we have all the values selected from our right table, which is the employees table. You can see right join employees, which means your employees table is to the right, and then we have the customer name and phone numbers of the customers from the customer table, which is actually your left table. So you have a few employee numbers such as 1002, there's 1056, which don't have any customer name or phone numbers. Okay, so there's another popular join which is very widely used in SQL, known as self joins. So self joins are used to join a table to itself. So in our database we have a table called employees. Let me show you the table first. Alright, so here you can see we have the employee number, the last name, the first name of the employee, we have the email ID, and here if you see we have a column called reports to. Now this you can think of as the manager column. So the way to read is, for example, for employee number 1056, the manager is 1002. So if you check for 1002, we have Dane Murphy. Then if I scroll down, let's say for employee number 1102, for employee number 1102, the manager is 1056. So here you can see who is at 1056. You have Mary Patterson. Similarly, if I scroll down, let's say for employee number 1188, we have the manager as 1143. Now if I check the table at 1143, we have Anthony Bow. So the employee Julie Firelli reports to Anthony Bow. Alright, now suppose you want to know who is the reporting manager for each employee. So for that you can use a self join.
So let me show you how to join this employees table. I'll write select, and then I'm going to use a function called concat. Within brackets I'll start with my alias name, that is m dot, then I'll write last name. I'm going to concat last name followed by a comma, then I'll have my first name. I'll close this bracket, and then I'm going to give my alias name, let's say manager, comma. Next I'm going to concat the same last name and first name, and this time I'm going to use a separate alias, let's say E, which stands for employee. So I'll write E dot last name, comma, and within single quotes I'll give my comma, and then I'll write E dot first name. I'll close this bracket. I'll give an alias as, let's say, employee. From, I'll write employees as E, inner join employees as M on M dot. I'll use my common key column as employee number, so I'll write M dot employee number is equal to E dot, here I'm going to use the reports to column, and then I'll order it by, let's say, manager. Okay, now let's run this. There you go. So you have your two columns as manager and employee. So for employee Louis Bonder, the manager is Gerard Bonder. Similarly, if I scroll down, you have there are multiple employees reporting to this particular manager. Similarly, we have our manager as Anthony Bow, and we have different employees who are reporting to this particular manager, and so on. Alright, now moving ahead. Now let's see what a full join is. So SQL full outer join statement returns all the rows when there is a match in either left or right table. Now you must remember that MySQL Workbench does not support full outer join by default, but there's a way to do it. So by default, this is how the syntax of full outer join looks like. Now this statement will work on other SQL databases like Microsoft SQL Server, but it won't work on MySQL Workbench. I'll show you the right way of using full outer join on MySQL Workbench. So to show full outer join, I'm going to first use a left join, and then we'll also use a right join, and finally we'll use a union operator. So the union operator is used to combine the result set of two or more select statements. So first of all, let me write C dot customer name. So for this example, I'm using the customer table and the order table, comma O dot order number. So I just want to know the customer name and the order number related to the customer. From, I have customers as C, left join, I'll write orders as O on C dot customer number is equal to O dot customer number. Let me just copy this, and after this I am going to use my union operator. So union operator is used to merge results from two or more tables. So basically this performs a vertical join. And next I am going to use my right join operation. So here instead of left join, I'll write right. Rest all looks fine. Let me just run it. There you go.
So we have successfully run our full outer join operation. You can see we have the different customer names and the order that each customer had placed. Alright.
Today we're going to jump into some common questions you might see on NumPy arrays and Pandas data frames in the Python, along with some Excel, Tableau, and SQL. Let's start with our first question. What is the difference between data mining and data profiling? It's real important to note that data mining is a process of finding relevant information which has not been found before. It is a way in which raw data is turned into valuable information. You can think of this as anything from the sales stats and from their SQL server all the way to web scraping and Census Bureau information. Where the heck do you mine it from? Where do you get all this data and information? Then we look at data profiling. Is usually done to assess a data set for its uniqueness, consistency, and logic. It cannot identify incorrect or inaccurate data values. So if somebody has a statistical analysis on one side and they're doing you might the wrong data to then program your data setup. So you got to be aware that when you're talking about data mining, you need to look at the integrity of what you're bringing in, where it's coming from. Data profiling is looking at it and saying, hey, how is this going to work? What's the logic? What's the consistency? Is it related to what I'm working with? Define the term data wrangling and data analytics. Data wrangling is a process of cleaning, structuring, and enriching the raw data into a desired usable format for better decision making. And you can see a nice chart here with our Discover It. We structure the data how we want it. We clean it up, get rid of all those null values. We enrich it, so we might take and reformat some of the settings. Instead of having 5 different terms for height of somebody, in American, English, or whatever, we clean some of that up, and we might do a calculation and bring some of them together. And validate. I was just talking about that in the last one. You need to validate your data. Make sure you have a solid data source. And then, of course, it goes into the analysis. Very important to notice here in data wrangling, 80% of data analytics is usually in this whole part of wrangling the data, getting it to fit correctly. And don't confuse that with data cooking, which is actually when you're going into neural networks, cooking the data so it's all between 0 and 1 values. What are common problems that data analysts encounter during analysis? Handling duplicate and missing values, collecting the meaningful right data the right time, making data secure and dealing with compliance issues, handling data purging and storage problems. Again, we're talking about data wrangling here. 80% of most jobs are in wrangling that data and getting it in the right format and making sure it's good data to use. Number 4, what are the various steps involved in any analytics project? Understand the problem. We might spend 80% doing wrangling, but you better be ready to understand the problem, because if you can't, you're going to spend all your time in the wrong direction. This is probably the most important part of the process. Everything after it falls in, and then you can come back to it. 2, data collection, data cleaning. Number 3, 4, data exploration analysis, and 5, interpret the results. Number 5 is a close second for being the most important. If you can't interpret what you bring to the table to your clients, you're in trouble. So when this question comes up, you probably want to focus on those 2, noting that the rest of it does, 80% of the work is in 2, 3, and 4, while 1 and 5 are the most important parts. Which technical tools have you used for analysis and presentation purposes? Being a data analyst, you are expected to have knowledge of the below tools for analysis and presentation purposes. There's a wide variety out there. SQL Server, MySQL, you have your Excel, your SPSS, which is the IBM platform, Tableau, Python. You have all these different tools in here. Now, certainly a lot of jobs are going to be narrowed in on just a few of these tools. Like, you're not going to have a Microsoft SQL Server or MySQL Server, but you better understand how to do basic SQL polls, and also understanding Excel and how the different formats for column and how to get those set up. Number 6, what are the best practices for data cleaning? This is really important to remember to go through this in detail. These always come up because 80% of most data analysis is in cleaning the data up. Make a data cleaning plan by understanding where the common errors take place and keep communications open. Identify and remove duplicates before working with the data. This will lead to an effective data analysis process. Focus on the accuracy of the data, maintain the value types of data, provide mandatory constraints and set cross-field validation. Standardize the data at the point of entry so that it is less chaotic and you will be able to ensure that all the information is standardized, leading to fewer errors on entry. Number 7, how can you handle missing values in a data set? Listwise deletion. In listwise deletion method, entire record is excluded from analysis if any single value is missing. Sometimes we're talking about records. Remember, this could be a single line in a database. So if you have your SQL comes back and you have 15 different columns, every one of those that has a missing value, you might just drop it just to make it easy because you already have enough data to do the processing. Average imputation. Use the average value of the responses from the other participants to fill in the missing value. This is really useful, and they'll ask you why these are useful, I guarantee it. If you have a whole group of data that's collected and it doesn't have that information in it, at that point you might average it in there. Regression substitution. You can use multiple regression analysis to estimate a missing value. That kind of goes with the average imputation input. Regression model means you're just going to guess, you're going to actually generate a prediction as to what you think that value should be for those people based on the ones you do have. Multiple imputation. So when we talk about multiple inputs, it creates plausible values based on the correlations for the missing data and then average the simulated data sets by incorporating random errors in your predictions. What do you understand by the term normal distribution? And the second you hear the word normal distribution, should be thinking a bell curve like we see here. Normal distribution is a type of continuous probability distribution that is symmetric about the mean, and in the graph, normal distribution will appear as a bell curve. The mean, median, and mode are equal. That's a quick way to know if you have normal distribution, is you can compute mean, median, and mode. All of them are located at the center of the distribution. 68% of the data lies within one standard deviation of the mean. 95% of the data falls within 2 standard deviations of the mean. 99.7% of the data lies within 3 standard deviations of the mean. What is time series analysis? Time series analysis is a statistical method that deals with ordered sequence of values of a variable of equally spaced time intervals. Time series data on a COVID-19 cases. And you can see we're looking at by days, so our space is of days, and each day goes by. If we take and graph it, you can see a time series graph always looks really nice if you have like 2 different, in this case we have the United States going over there. I'd have to look at the other setup in there, but they picked a couple different countries. And it's time sensitive. You know, the next result is based on what the last one was. COVID is an excellent example of this. Anytime you do any word analytics where you're figuring out what someone's saying, what they said before makes a huge difference as to what they're going to say next. Another form of time series analysis. 10. How is joining different from blending in Tableau? So now we're going to jump into the Tableau package. Data joining. Data joining can only be done when the data comes from the same source. Combining 2 tables from the same database or 2 or more worksheets from the same Excel file. All the combined tables or sheets contains common set of dimensions and measures. Data blending. Data blending is used when the data is from 2 or more different sources. Combining the Oracle table with the SQL server, or 2 sheets from Excel, or combining an Excel sheet and Oracle table. In data blending, each data source contains its own set of dimensions and measures. How is overfitting different from underfitting? Always a good one. Overfitting. Probably the biggest danger in data analytics today is overfitting. Model trains from the data too well using the training set. The performance drops significantly over the test set. Happens when the model learns the noise and random fluctuations in the training data set in detail. And again, the performance drops way below what the test set has. The model neither trains the data well nor can generalize to new data. Performs poorly both on train and the test set. Happens when there is less data to build and an accurate model, and also when we try to build a linear model with a nonlinear data. In Microsoft Excel, a numeric value can be treated as a text value if it proceeds with an apostrophe. Definitely not an exclamation. If you're used to programming in Python, you'll look for that hash code and not an amber sign. And we can see here, if you enter the value 10 into a field, but you put the apostrophe in front of it, it will read that as a text, not as a number. What is the difference between count, count A, count blank, and count if in Excel? We can see here when we run in just count, D1 through D23, we get 19. And you'll notice that there is 19 numbers coming down here. And so it doesn't count the cost of each, which is the top bracket. It doesn't count the blank spaces either with the straight count. When you do a count A, you'll get the answer is 20. So now when you do count A, it counts all of them, even the title cost of each. When you do count blank, we'll get 3. Why? There's 3 blank fields. And finally, the count if. If we do count if of E1 to E23 is greater than 10, there's 11 values in there. Basic counting of whatever's in your column, pretty solid on the table there. Explain how VLOOKUP works in Excel. VLOOKUP is used when you need to find things in a table or arrange by row. The syntax has 4 different parts to it. We have our lookup value, that's a value you want to look up. We have our table array, the range where the lookup value is located, column index number, the column number and range that contains the return value, and the range lookup. Specify true if you want an approximate match or false if you want an exact match of the return value. So here we see VLOOKUP F3 A2 to C8 2, 0 for prints. Now they don't show the F3. F3 is the actual cell that prints is in. That's what we're looking at is F3. So there's your prints. He pulls in from F3. A2 to C8 is the data we're looking into, and then number 2 is a column in that data. So in this case we're looking for age, and we count name as 1, age as 2. Keep in mind this is Excel versus a lot of your Python and programming languages where you start at 0. In Excel we always look at the cells as 1, 2, 3, so 2 represents the age. 0 is false for having an exact matchup versus 1. We don't actually need to worry about that too much in this. 0 or 1 would work with this example. And you can see with the Angela lookup, again, her name would be in the F column number 4. That's what the F4 stands for, is where they pulled Angela from. And then you have A1 to C8, and then we're looking at number 3. So number 3 is height, name being 1, age 2, and then height 3. And you'll see here it pulls in her height 5.8. So we're going to jump over to SQL. How do you subset or filter data in SQL? To subset or filter data in SQL, we use where and having clause. And you can see we have a nice table on the left where we have the title, the director, the year, the duration. We want to filter the table for movies that were directed by Brad Bird. Why? Just because we want to know what Brad Bird did. So we're going to do select star. You should know that the star refers to all. In this case, what are we going to return? We're going to return all title, director, year, and duration. That's what we mean by all. From movies, movies being our table, where director equals Brad Bird. And you can see he comes back and he did The Incredible on Ratatouille. To subset or filter data SQL, we can also use the where and having clause. So we're going to take a closer look at the different ways we can filter here. Filter the table for directors whose movies have an average duration greater than 115 minutes. So there's a lot of really cool things into this SQL query, and these SQL queries can get pretty crazy. Select director, sum duration as total duration, average duration as average duration from movies, group by director having average duration greater than 115. So again, what are we going to return? We're going to return whatever we put in our select, which in this case is director. We're going to have total duration, and that's going to be the sum of the duration. We're going to have the average duration, average underscore duration, which is going to be the average duration on there. And then we, of course, go ahead and group by director. And we want to make sure we group them by anyone that has having an average duration greater than 115. These SQL queries are so important. I don't know how many times the SQL comes up, and there's so many different other languages, not just MySQL and not Microsoft SQL, but in addition to that, where the SQL language comes in, especially with Hadoop and other areas. So you really should know your basic SQL. It doesn't hurt to get that little cheat sheet and glance over it and double check some of the different features in SQL. What is the difference between where and having clause in SQL? Where clause works on row data. In where clause, the filter occurs before any groupings are made. Aggregate functions cannot be used. So the syntax is select your columns from table where what the condition is. Having clause works on aggregated data. Having is used to filter values from a group. Aggregate functions can be used, and the syntax is select column names from table where the condition is, grouped by, having a condition ordered by column names. What is the correct syntax for reshape function in NumPy? So we're going to jump to the NumPy array program. And what you come up with is you have, in this case, it'd be numpy.reshape. A lot of times you do an import numpy as np, reshape, and then your array and the new shape. And you can see here as the actual example comes in, the reshape is A, and we're going to reshape it in 2, 5 setups. And you can see the printout in there that prints in 2 rows with 5 values in each one. What are the different ways to create a data frame in Pandas? Well, we can do it by initializing a list. So you can import your pandas as PD, very common. Data equals Tom 30, Jerry 20, Angela 35. We'll go ahead and create the data frame, and we'll say pd.dataframe is the data, columns equals name and age. So you can designate your columns. You can also designate index in there. You should always remember that the index, in this case, maybe you want the index instead of 1, 2 to be the date they signed up, or who knows, whatever. And you can see right there, it just generates a nice pandas data frame with Tom, Jerry, and Angela. Another way you can initialize a data frame is from dictionary. You can see here we have a dictionary where the date equals name, Tom, Jerry, Angela, Mary. Age is 20, 21, 19, 18. And if we do a df pd.dataframe on the data, you'll get the same kind of setup. You get your name, age, Tom, Jerry, Angela, and Mary. Write the Python code to create an employee's data frame from the emp.csv file and display the head and summary of it. To create a data frame in Python, you need to import the pandas library and use the read CSV function to load the CSV file. And here you can see we have import pandas as PD, employees, or the data frame employees, equals pd.readcsv, and then you have your path to that CSV file. There's a number of settings in the read CSV where you can tell it how many rows are the top index. You can set the columns in there. You can have skip rows. There's all kinds of things. You can also go in there and double check with your read CSV, but the most basic one is just to read a basic CSV. How will you select the department and age columns from an employee's data frame? So we have import pandas as PD. You can see we have created our data. We will go ahead and create our employees PD data frame on the left. And then on the right, to select department and age from the data frame, we just do employees, and you put the brackets around it. Now, if you're just doing one column, you could do just department. But if you're doing multiple columns, you got to have those in a second set of brackets. So it's got to be a reference with a list within the reference. What is the criteria to say whether a developed data model is good or not? A good model should be intuitive, insightful, and self-explanatory. Follow the old saying, KISS, keep it simple. The model developed should be able to easily consumed by the clients for actionable and profitable results. So if they can't read it, what good is it? A good model should easily adapt to changes according to business requirements. We live in quite a dynamic world nowadays, so that's pretty self-evident. And if the data gets updated, the model should be able to scale accordingly to the new data. So you have a nice data pipeline going where when you get new data coming in, you don't have to go and rewrite the whole code. What is the significance of exploratory data analysis? Exploratory data analysis is an important step in any data analysis process. Exploratory data analysis, EDA, helps to understand the data better. It helps you obtain confidence in your data to a point where you're ready to engage a machine learning algorithm. It allows you to refine your selection of feature variables that will be used later for model building. You can discover hidden trends and insights from the data. How do you treat outliers in a data set? An outlier is a data point that is distant from other similar points. They may be due to variability in the measurement or may indicate experimental errors. One, you can drop the outlier records. Pretty straightforward. You can cap your outliers data so it doesn't go past a certain value. You can assign it a new value. You can also try a new transformation to see if those outliers come in if you transform it slightly differently. Explain descriptive, predictive, and prescriptive analytics. Descriptive provides insights into the past to answer what has happened. Uses data aggregation and data mining techniques. Examples: an ice cream company can analyze how much ice cream was sold, which flavors were sold, and whether more or less ice cream was sold than before. Predictive understands the future to the answer. What could happen? Uses statistical models and forecasting techniques. Example: predicts the sale of ice creams during the summer, spring, and rainy days. So this is always interesting because you have your descriptive, which comes in, and your businesses are always looking to know what happened. Hey, did we have good sales last quarter? What are we expecting next quarter in sales? And we have a huge jump when we do prescriptive. Suggest various courses of action to answer what should you do. Uses optimization and simulation algorithms to advise possible outcomes. Example: lower prices to increase sale of ice creams, produce more or less quantities of certain flavor of ice cream. And we can certainly, today's world with the COVID virus, because we had that on our earlier graph, you could see that as a descriptive. What's happened? How many people have been infected? How many people have died in an area? Predictive: where do we predict that to go? Do we see it going to get worse? Is it going to get better? What do we predict that we're going to need in hospital beds? And prescriptive: what can we change in our setup to have a better outcome? Maybe if we did more social distancing, if we tracked the virus. How do these different things directly affect the end, and can we create a better ending by changing some underlying criteria? What are the different types of sampling techniques used by data analysts? Sampling is a statistical method to select a subset of data from an entire data set, population, to estimate the characteristics of the whole population. One, we can do a simple random sampling, so we can just pick out 500 random people in the United States to sample them. We call it a population. In regular data, we also call that a population, just because that's where it came from, was mainly from doing census. Systematic sampling, cluster sampling, stratified sampling, and judgment or purposive sampling. Then we have our systematic sampling. That's where you're doing like using 1, 5, 10, 15, 20. Use a very systematic approach for pulling samples from the setup. Cluster sampling, that's where we look at it and we say, hey, some of these things just naturally group together. If you were talking about population, which is really a nice way of looking at this, cluster sampling would be maybe by zip code. We're going to do everybody's zip code and just naturally cluster it that way. Stratified sampling would be more looking for shared things the group has, like income. So if you're studying something on poverty, you might look at their naturally group people based on income to begin with, and then study those individuals in the income to find out what kind of traits they have. And then judgmental. That is where the researcher very carefully selects each member of their own group. So it's very much based on their personal knowledge. Jumping on to 26, what are the different types of hypothesis testing? Hypothesis testing is a procedure used by statisticians and scientists to accept or reject statistical hypotheses. We start with the hypothesis testing. We have null hypothesis and alternative hypothesis. On the null hypothesis, it states that there is no relation between the predictor and the outcome variables in the population. It is denoted by H0. Example, there is no association between patients, BMI, and diabetes. Alternative hypothesis, it states there is some relation between the predictor and outcome variables in the population. It is denoted by H1. Example, there could be an association between patients' BMI and diabetes. And that's the body mass index, if you didn't catch the BMI and you're not in medical. Describe univariate, bivariate, and multivariate analysis. A univariate analysis, it is the simplest form of data analysis where the data being analyzed contains only one variable. An example is studying the heights of players in the NBA. Because it's so simple, it can be described using central tendencies, dispersion, quartiles, bar charts, histograms, pie charts, frequency distribution tables. The bivariate analysis, it involves analysis of two variables to find causes, relationships, and correlations between the variables. Example, analyzing sale of ice creams based on the temperature outside. Bivariate analysis can be explained using correlation coefficients, linear regression, logistic regression, scatter plots, and box plots. And multivariate analysis, it involves analysis of three or more variables to understand the relationship of each variable with the other variables. Example, analyzing revenue based on expenditure. So if we have our TV ads, we have our newspaper ads, our social media ads, and our revenue, we can now compare all those together. The multivariate analysis can be performed using multiple regression, factor analysis, classification and regression trees, cluster analysis, principal component analysis, clustering bar chart, dual axis chart. What function would you use to get the current date and time in Excel? In Excel, you can use the today and now function to get the current date and time. And you can see down here with the two examples where just equals today or equals now. Using the SUMIFS function in Excel, find the total quantity sold by sales representatives whose names start with A and the cost of each item they have sold is greater than 10. And you can see here on the left we have our actual table, and then we want to go ahead and SUMIFS. So we want the E2 through E20, B2 through B20 greater than 10. And this basically is just saying, hey, we're going to take everything in the E column and we're going to sum it up, but only those objects where the D column is greater than 10. That's what that means there. Is the below query correct? If not, how will you rectify it? Select customer ID, year, order date as order year from order where order year is greater than or equal to 2016. And hopefully you caught it right there. It's in the devil's in the details. We can't not use the alias name while filtering data using the where clause. So the correct format is all the same except for where it says where the year order date is greater than or equal to 16 versus using the order year, which we assign under the select setup. How are union, intersect, and except used in SQL? The union operator is used to combine the results of two or more select statements. And you can see here we have select star from region 1. We're going to make a union with select star from region 2. And it basically takes both these SQL tables and combines them to form a full new table on there. So that's your union as we bring everything together. When we look at the intersect operator, it returns the common records that are the result of the two or more select statements. So you can see here we select star from region 1, intersect, select star from region 2, and we come up with only those records that are shared, that have the same data in them. And hopefully you jumped ahead to the except. The except operator returns the uncommon records that are the result of two or more select statements. So these are the two records, or the records that are not shared between the two databases. Using the product price table, write an SQL query to find the record with the fourth highest market price. So here we have a little bit of a brain teaser. They're always fun. And the first thing we want to do is we're going to go ahead and if you look at the script on the left, we really want the fourth one down. So we're going to select the top 4 from product price. But we're going to order it by market price descending. SP ordered by market price ascending. So what we do is we take the top 4 of the market price ascending, and that's going to give us the 4 greatest values. And then we're going to reverse that order and do descending. And we're going to take the top one of that, which is going to give us the lowest value, which will be the 4th greatest one in the list. From the product price table, find the total and average market price for each currency where the average market price is greater than 100 and currency is in the INR or the AUD. So INR or AUD, India Rupee or Australia dollar. You can see over here the SQL query. If you had trouble putting this together, you might actually do some of it in reverse. And you can see right here where the average market price is greater than 50. Remember, we use having, not where, at the end because it's part of the group. So group by currency, because we want those two currencies. And we want the currency India Rupee, the INR or the AUD. And as you keep going backwards, we're actually going to be selecting the currency, the sum of the market price as total price, and the average market price as average price. So there's our select. It's going to come from the product price, which is just our table over there, and then we have where our currency is in. And like I said, you can put it together however you want, but hopefully you got to the end there. So this question will test your knowledge in Tableau, exploring the different features of Tableau, and creating a suitable graph to solve a business problem. And of course, Tableau is very visual in its use, so it's very hard to test it without actually just getting your hands on. And if you can't visualize some of this and how to do it, then you should go back and refresh yourself. Using the sample superstore dataset, create a view to analyze the sales, profits, and quantities sold across different subcategories of items present under each category. So the first step is to go ahead and load the sample superstore dataset. So make sure you know how to load the sample, the superstore dataset. That's underneath either the connect button in the upper left or the Tableau icon up there, and be able to pull in the dataset. And then once you've done that, you just drag the category and subcategory on rows and salaries onto columns. It will result in a horizontal bar chart. So in this one, we're just going to drag profit onto color and quantity onto label. Sort the sales axes in descending order of sum and sales within each subcategory. And if you're at home doing this, you'll see that chairs under furniture category had the highest sales and profit, while tables had the lowest profit. For office supplies, subcategory binders made the highest profit, even though storage had the highest sales. Under technology category, copiers made the highest profit, though it was the least amount of sales. Let's work to create a dual axis chart in Tableau to present sales and profits across different years using sample superstore dataset. Load the orders sheet from the sample superstore dataset. Drag the order data field from the dimensions onto columns and convert it into continuous month. Drag cells onto rows and profits to the right corner of the view until you see a light green rectangle. One of those things, if you haven't done this hands-on, you don't know what you're doing, you're going to run into a bind because you're going to be just kind of dropping it and wondering what happened. Synchronize the right axes by right-clicking on the profit axis. And then let's finalize it by going under the marks card, change some cells to bar and some profit to line, and adjust the size. And then we have a nice display that we can either print out or save and send off to the shareholders. Let's go ahead and do one more Tableau. Design a view in Tableau to show state-wise sales and profits using the sample superstore dataset.
In here you go ahead and drag the country field onto the view section and expand it to see the states. Drag the states field onto size and profit onto color. Increase the size of the bubbles, add a border and a halo color. States like Washington, California, and New York have the highest sales and profits, while Texas, Pennsylvania, and Ohio have a good amount of sales but the least amount of profits. We'll go ahead and skip back to Python NumPy. Suppose there is an array number equals NP, or NumPy if you're using NumPy, depending on how you set it up, dot array, and we just have 1 to 9 broken up into 3 groups. Extract the value 8 using 2D indexing. So you can see on the left we have our import NumPy as NP, number equals our NP array. If we print the number, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Since the value 8 is present in the second row and first column, we use the same index position and pass it to the array. And you just have number 2, 1, and you get 8. And remember, we're in Python, so you start at 0, not 1 like you do in Excel. Always gets me if I'm working between Excel and Python, where I just kind of flip, and usually it's the Excel that messes up because I do a lot more programming. Suppose there's an array that has values 0, 1, all the way up to 9. How will you display the following values from the array? 1, 3, 5, 7, 9. So first of all, we go ahead and create the array np.arange of 10, which goes from 0 to 9, because there's 10 numbers in it, but we don't include the 10. We print it out. The first thing you want to do is, what's going on here with 1, 3, 5, 7, 9? Well, if we divide by 2, there's going to be a remainder equal to 1. And then from Python, remember that if you use the percentage sign, you get the remainder on there. So the remainder is 1. And then you have your NumPy array, and then we just want to do a logical statement of all values that have a remainder of 1, and that generates our nice 1, 3, 5, 7, 9. There are 2 arrays, A and B. Stack the arrays A and B horizontally. Boy, these horizontal vertical questions will get you every time. And in NumPy, we go ahead and we've created 2 different arrays over here, A and B. The first one is your concatenate, np.concatenate A and B on axes equal 1. That is the same as hstack. And in the back end, they're still identical. They run the same. That's all hstack is, a concatenate axes equals 1. How can you add a column to a pandas data frame? Suppose there's an imp data frame that has information about few employees. Let's add address column to that data frame. And you can see on the left we have our basic data frame. You should know your data frames very well. Basically it looks like an Excel spreadsheet. As you come over here, it's really simple. You just do df of address equals the address once you've assigned values to the address. Using the below given data, create a pivot table to find the total cells made by each sales represented for each item. Display the cells as a percentage of the grand total. So we're back in Tableau. Select the entire table range, click on Insert tab, and choose Pivot Table. Select the table range and the worksheet where you want to place the pivot table. It will return a pivot table where you can analyze your data. Drag the cell total on the values in sales rep and item onto row labels. It will give the sum of the sales made by each representative for each item they have sold. And finally, right-click on Sum of Cell Total and expand Show Values as to select percentage of grand total. Real important just to understand what a pivot table is. We're just pivoting it from rows and columns and switching this direction on there. And finally, we have our final pivot table, and you can see the values, roles, and sum of total sale. So we're going to go ahead and take a product table. This is off of an SQL, so we're going to do some SQL here. And we're going to use the product and sales order detail table. Find the products that have total units sold greater than 1.5 million. And here's our sales order detail table. So we have a product table and a sales order detail table, 2 separate tables in the database. And what we're going to do is put together the SQL query. We want to select PP name, sum sod unit price as cells, and then we have our pp.product.id from production product as pp inner join, cells.cells order detail as sod on pp product id equals sod.product id group by pp.name, comma pp.product id having a sum of sod.unit price greater than the 150 million there. That's a mouthful. And again, these SQL queries, they start looking really crazy until you just break them apart and do them step by step. And what we're looking for is the inner join and how did you do the group by. That's really what they know. How do you do this inner join? This comes up so much in SQL. How do you pull in the ID from one chart and the information from another chart and the sum totals on that chart? How do you write a stored procedure in SQL? Let's create a stored procedure to find the sum, the squares of the first n natural numbers. So here we have our formula, n times n plus 1 times 2n plus 1 over 6. And you can see from the command prompt or the setup you have, depending on what your login is, the command is create procedure square sum 1. Declare our variable at n of integer as begin, and then we're going to declare the sum of integer, set sum equals n times n plus 1 plus 2 times n plus 1 over 6. And then of course we can go ahead and print those out. Print first cast ampersand n, or our variable, as a variable character 20 natural numbers. Print the sum of the square is cast the at sum as variable character 40 end. And then we do the output, display the sum of the square for first 4 natural numbers. We have execute square sum 1, and then we're going to put in 4, and you can see here where it brings up the first 4 natural numbers. Sum of square is 30. Write a store procedure to find the total even number between 2 user-given numbers. A couple of things to note here. First, we go ahead and create our procedure. You have your 2 different variables, the n1, n2. And we go ahead and begin. We're going to declare our variable count as an integer. We're going to set count equal to 0. And then we have while n is less than n2. We're going to begin. And if n1 remainder 2 equals 0, so we're going to divide it by 2, even number, begin. We're going to set the count equal to count plus 1. We're going to print even number plus cast n as a variable character 10 for printing. Count is plus cast variable count as variable character 10 end. Else print odd number plus cast variable number 1 as variable character 10. And then we go ahead and set the increment our variable 1 up 1. So it'll go from n1 all the way to n2. And it'll print the total number of even numbers. And you can see here we went ahead and executed it. We're going to count the even numbers between 30 and 45. And you can just see it goes all the way down to 8. What is the difference between tree maps and heat maps in Tableau? Now, if you've worked in Python and other programmings, you should automatically know what a heat map is. But a tree map are used to display data in nested rectangles. You use dimensions to define the structure of the tree map and measure to define the size or color of individual rectangles. Tree maps are a relatively simple data visualization that can provide insight in a visually attractive format. And again, you can see the squares over here. This is our tree map over here with each block also has its information inside of its different blocks. A heat map helps to visualize measures against dimensions with the help of colors and size to compare one or more dimensions and up to 2 measures. The layout is similar to a text table with variations in values encoded as colors. In heat map, you can quickly see a wide array of information. And in this one, you can see they use the colors to denote one thing and the size of the little square to denote something else. A lot of times you can even graph this into a 3-dimensional graph with other data so it pops out. But again, a heat map is the color and the size. Using the sample superstored dataset, display the top 5 and bottom 5 customers based on their profit. So you start by dragging the customer name field onto rows and profit on columns. Right-click on the customer name column to create a set. Give a name to the set and select Top Tab to choose top 5 customers by sum profit. Similarly, create a set for the bottom 5 customers by some profit. Select both the sets, right-click to create a combined set. Give a name to the set and choose all members in both sets. And then you can drag top and bottom customer sets onto the filters and profit field onto color to get the desired results. As we get down to the end of our list, we're going to try to keep you on your toes. We're going to skip back to NumPy. How to print 4 random integers between 1 and 15 using NumPy. To generate random numbers using NumPy, we use the random integer function. And you can see here we did the import NumPy as np random arrangement equals np.random.random integer 1 through 15 of 4. From the below data frame, going to jump again on you, now we're into pandas. How will you find the unique values for each column and subset the data for age less than 35 and height greater than 6? To find the unique values and the number of unique elements, use the unique and the InUnique function. You can see here we just did df height, so we're selecting just the height column, and we want to look for the unique. That returns an array, where InUnique, if we do that on the height or the age, will return just the number of unique values. And then we can do a subset the data for ages less than 35 and height greater than 6. So if we look over here, we have a new df. Remember, this is going to be taking slices of our original data frame. It doesn't actually change the data frame. So our new df equals the data frame, or df, the data frame where age is less than 35 and the height is greater than 6. And in case you're not using Tableau, which has a lot of its own different mapping programs in there, make sure you understand how to use the basics of Matplotlib. Plot a sine graph using NumPy and Matplotlib in Python. And the way we did this is we went ahead and generated an x. We know our y equals np.sine of x. If you print out x, you'll see a whole value here. Our Matplotlib PyPlot as PLT. If you are working in Jupyter Notebook, make sure you understand the Matplotlib inline, that little percentage sign Matplotlib inline. That prints it on the page in the Jupyter Notebook. The newer version of Jupyter Notebook or Jupyter Labs automatically does that for you, but I usually put it in there just in case I end up on an older version. If you print y, you can see here we have our different y values and our different x values. You simply put in plt.plot xy and do a plot show. And before we go, let's get one more in. We're going to do a pandas using the below pandas data frame. Find the company with the highest average sales, derive the summary statistics for this sales column, and transpose these statistics. That's a mouthful, and just like any of these computer problems, break it apart. So first of all, we're looking for the highest average sales. So group the company column and use the mean function to find the average sales. And you can see here by company equals df.groupBy company. Once we've done that, using the describe function, we can now go ahead and look at the summary of statistics on here. Use the describe function to find the summary. So by company, those are groups. We're just going to describe them. And you could actually bundle those together if you wanted and just do them all in one line. So here we go, by company.describe. You can see we have a nice breakout. Always good to remember. Whether you're using any of the packages, whether it's Tableau or Pandas in Python, or even R or some other package, being able to quick look and describe your data is very important. And then we can go ahead and just do a basic apply a transpose function over the describe method to transpose the statistics. All we've done here is flip the index with the column names, but if you're following the numbers, a lot of times it's easier to follow across one line, or maybe you want to average out the count, or it's all kinds of different reasons to do that.
And with that, we have come to the end of this video on Data Analyst Full Course. I hope it was informative and interesting. If you have any questions related to the topics that were covered in this video, please ask away in the comment section below. Our team will help you solve your queries. Thanks for watching, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.